Docker is one of the leading container orchestration tools in today's market. Hi all, I welcome you to this full course session on Docker, and what follows is the complete crash course on the same. But before we begin, let's take a look at today's agenda. So we'll start off with introduction to Docker, where we'll talk about what is Docker, its components and its architecture. After that, we'll talk about how to install and set up Docker on CentOS machine and on Windows. Later on in the session, we'll look into Dockerfile and commands, where we'll understand how to create and run a Dockerfile and use various commands. After that, I'll talk about how to use Docker Compose and Docker Swarm. So over here, you'll understand how to run various containers to host a single application, and also coming to Docker Swarm, you'll understand how to create a cluster to achieve high availability. Moving forward in the session, we'll look into Docker networking, where we'll understand the various aspects of Docker networking, and after that, I'll talk about Dockerizing an application. So over here, you'll understand how to Dockerize an application, either it be an AngularJS application, a microservice application, or a Node.js application. And finally, I'll end this session by talking about the differences between Docker and virtual machine, and also comparing Docker versus Kubernetes. Right? With that, I come to an end to my today's agenda. But before we begin, I would like to request all of you to subscribe to our Edureka YouTube channel to get daily notified on the top trending technologies. On that note, let's get started.
Why we need Docker. So this is the most common problem that industries were facing. As you can see that there is a developer who has built an application that works fine in his own environment. But when it reached production, there were certain issues with that application. Why does that happen? That happens because of difference in the computing environment between dev and product. So I hope we are clear with the first problem. I'll move forward and we'll see the second problem. Before we proceed with the second problem, it is very important for us to understand what are microservices. Consider a very large application. That application is broken down into smaller services. Each of those services can be termed as microservices. Or we can put it in another way as well. Microservices can be considered as small processes that communicates with each other over a network to fulfill one particular goal. Let us understand this with an example. As you can see that there is an online shopping service application. It can be broken down into smaller microservices like account service, product catalog, cart server, and order server. Microservice architecture is gaining a lot of popularity nowadays. Even giants like Facebook and Amazon are adopting microservice architecture. There are three major reasons for adopting microservice architecture, or you can say there are three major advantages of using microservice architecture. First, there are certain applications which are easier to build and maintain when they are broken down into smaller pieces or smaller services. Second reason is, suppose if I want to update a particular software or I want a new technology stack in one of my module or in one of my service, so I can easily do that because the dependency concerns will be very less when compared to the application as a whole. Apart from that, the third reason is, if any of my module or any of my service goes down, then my whole application remains largely unaffected. So I hope we are clear with what are microservices and what are their advantages. So we'll move forward and see what were the problems in adopting this microservice architecture. So this is one way of implementing microservice architecture. Over here, as you can see that there's a host machine, and on top of that host machine, there are multiple virtual machines. Each of these virtual machines contains the dependencies for one microservice. So you must be thinking, what is the disadvantage here? The major disadvantage here is, in virtual machines, there is a lot of wastage of resources. Resources such as RAM, processor, disk space are not utilized completely by the microservice which is running in these virtual machines. So it is not an ideal way to implement microservice architecture. And I have just given you an example of 5 microservices. What if there are more than 5 microservices? What if your application is so huge that it requires 50 microservices? So at that time, using virtual machines doesn't make sense because of the wastage of resources. So let us first discuss the implementation of microservice problem that we just saw. So what is happening here, there's a host machine, and on top of that host machine, there's a virtual machine. And on top of that virtual machine, there are multiple Docker containers, and each of these Docker containers contains the dependencies for one microservice. So you must be thinking, what is the difference here? Earlier we were using virtual machines, now we are using Docker containers on top of virtual machines. Let me tell you guys, Docker containers are actually lightweight alternatives of virtual machines. What does that mean? In Docker containers, you don't need to pre-allocate any RAM or any disk space. So it will take the RAM and disk space according to the requirements of applications. All right. Now let us see how Docker solves the problem of not having a consistent computing environment throughout the software delivery lifecycle. Let me tell you, first of all, Docker containers are actually developed by the developers. So now let us see how Docker solves the first problem that we saw, where an application works fine in development environment but not in production. So Docker containers can be used throughout the SDLC lifecycle in order to provide consistent computing environment. So the same environment will be present in dev, test, and product. So there won't be any difference in the computing environment. So let us move forward and understand what exactly Docker is. So the Docker containers does not use the guest operating system. It uses the host operating system. Let us refer to the diagram that is shown. This is the host operating system, and on top of that host operating system, there's a Docker engine. And with the help of this Docker engine, Docker containers are formed. And these containers have applications running in them. And the requirements for those applications, such as all the binaries and libraries, are also packaged in the same container. All right. And there can be multiple containers running. As you can see that there are two containers here, 1 and 2. So on top of the host machine, there's a Docker engine, and on top of the Docker engine, there are multiple containers, and each of those containers will have an application running in them, and whatever the binaries and libraries required for that application is also packaged in the same container. So I hope we are clear. So now let us move forward and understand Docker in more detail. So this is a general workflow of Docker, or you can say one way of using Docker. Over here, what is happening? A developer writes a code that defines an application requirements or the dependencies in an easy to write Docker file. And this Docker file produces Docker images. So whatever dependencies are required for a particular application is present inside this image. And what are Docker containers? Docker containers are nothing but the runtime instance of Docker image. This particular image is uploaded onto the Docker Hub. Now what is Docker Hub? Docker Hub is nothing but a Git repository for Docker images. It contains public as well as private repositories. So from public repositories, you can pull your image as well, and you can upload your own images as well onto the Docker Hub. All right. From Docker Hub, various teams such as QA or production team will pull the image and prepare their own containers, as you can see from the diagram. So what is the major advantage we get through this workflow? So whatever the dependencies that are required for your application is actually present throughout the software delivery lifecycle. If you can recall the first problem that we saw, that an application works fine in development environment, but when it reaches production, it is not working properly. So that particular problem is easily resolved with the help of this particular workflow, because you have a same environment throughout the software delivery lifecycle, be it dev, test, or product. So I'll move forward and we'll see, for better understanding of Docker, a Docker example. So this is another way of using Docker. In the previous example, we saw that Docker images were used, and those images were uploaded onto the Docker Hub. And from Docker Hub, various teams were pulling those images and building their own containers. But Docker images are huge in size and requires a lot of network bandwidth. So in order to save that network bandwidth, we use this kind of a workflow. Over here, we use Jenkins servers or any continuous integration server to build an environment that contains all the dependencies for a particular application or a microservice. And that build environment is deployed onto various teams like testing, staging, and production. So let us move forward and see what exactly is happening in this particular image. Over here, developer has written complex requirements for a microservice in an easy to write Docker file. And the code is then pushed onto the Git repository. From Git repository, continuous integration servers like Jenkins will pull that code and build an environment that contains all the dependencies for that particular microservice. And that environment is deployed onto testing, staging, and production. So in this way, whatever requirements are there for your microservice is present throughout the software delivery lifecycle. So if you can recall the first problem where application works fine in dev but does not work in prod. So with this workflow, we can completely remove that problem because the requirements for the microservice is present throughout the software delivery lifecycle. And this image also explains how easy it is to implement a microservice architecture using Docker. Now let us move forward and see how industries are adopting Docker. So this is the case study of Indiana University. Before Docker, they were facing many problems. So let us have a look at those problems one by one. The first problem was they were using custom script in order to deploy their application onto various VMs. So this requires a lot of manual steps. And the second problem was their environment was optimized for legacy Java-based applications. But their growing environment involves new products that aren't solely Java-based. So in order to provide their students the best possible experience, they needed to begin modernizing their applications. Let us move forward and see what all other problems Indiana University was facing. So in the previous problem of Indiana University, they wanted to start modernizing their applications. So for that, they wanted to move from a monolithic architecture to a microservice architecture. And the previous slides, we also saw that if you want to update a particular technology in one of your microservice, it is easy to do that because there'll be very less dependency constraints when compared to the whole application. So because of that reason, they wanted to start modernizing their application. They wanted to move to a microservice architecture. Let us move forward and see what are the other problems that they were facing. Indiana University also needed security for their sensitive student data such as SSN and student healthcare data. So there are four major problems that they were facing before Docker. Now let us see how they have implemented Docker to solve all these problems. The solution to all these problems was Docker Data Center. And Docker Data Center has various components which are there in front of your screen. First is Universal Control Plane, then comes LDAP, Swarm, CS Engine, and finally Docker Trusted Registry. Now let us move forward and see how they have implemented Docker Data Center in their infrastructure. This is the workflow of how Indiana University has adopted Docker Data Center. This is Docker Trusted Registry. It is nothing but the storage of all your Docker images. And each of those images contains the dependencies for one microservice. As we saw that Indiana University wanted to move from a monolithic architecture to a microservice architecture. So because of that reason, these Docker images contain the dependencies for one particular microservice, but not the whole application. All right. After that comes Universal Control Plane. It is used to deploy services onto various hosts with the help of Docker images that are stored in the Docker Trusted Registry. So IT Ops team can manage their entire infrastructure from one single place with the help of Universal Control Plane web user interface. They can actually use it to provision Docker installed software on various hosts and then deploy application, so without doing a lot of manual steps. As we saw in the previous slides that Indiana University was earlier using custom scripts to deploy application onto VMs, that requires a lot of manual steps. That problem is completely removed here. When we talk about security, the role-based access controls within the Docker Data Center allowed Indiana University to define a level of access to various teams. For example, they can provide read-only access to Docker containers for production team, and at the same time, they can actually provide read and write access to the dev team. So I hope we all are clear with how Indiana University has adopted Docker Data Center. So we'll move forward and see what are the various Docker components. First is Docker Registry. Docker Registry is nothing but the storage of all your Docker images. Your images can be stored either in public repositories or in private repositories. These repositories can be present locally or it can be present on the cloud. Docker provides a cloud-hosted service called Docker Hub. Docker Hub has public as well as private repositories. From public repositories, you can actually pull an image and prepare your own containers. At the same time, you can write an image and upload that onto the Docker Hub. You can upload that into your private repository or you can upload that on a public repository as well. That is totally up to you. So for better understanding of Docker Hub, let me just show you how it looks like. So this is how Docker Hub looks like. So first you need to actually sign in with your own login credentials. After that, you'll see a page like this which says welcome to Docker Hub. Over here, as you can see that there is an option of create repository where you can create your own public or private repositories and upload images. And at the same time, there's an option called explore repositories. This contains all the repositories which are available publicly. So let us go ahead and explore some of the publicly available repositories. So we have repositories for Nginx, Redis, Ubuntu, then we have Docker Registry, Alpine, Mongo, MySQL, Swarm. So what I'll do, I'll show you a CentOS repository. So this is the CentOS repository which contains the CentOS image. Now what I'll do, later in the session, I'll actually pull a CentOS image from Docker Hub. Now let us move forward and see what are Docker images and containers. So Docker images are nothing but the read-only templates that are used to create containers. These Docker images contains all the dependencies for a particular application or a microservice. You can create your own image and upload that onto the Docker Hub, and at the same time you can also pull the images which are available in the public repositories and in Docker Hub. Let us move forward and see what are Docker containers. Docker containers are nothing but the runtime instances of Docker images. It contains everything that is required to run an application or a microservice. And at the same time, it is also possible that more than one image is required to create one container. All right. So for better understanding of Docker images and Docker containers, what I'll do on my Ubuntu box, I'll pull a CentOS image and I'll run a CentOS container in that. So let us move forward and first install Docker in my Ubuntu box. So guys, this is my Ubuntu box. Over here, first I'll update the packages. So for that, I'll type sudo apt get update. So asking for password. It is done now. Before installing Docker, I need to install the recommended packages. So for that, I'll type sudo apt get install linux -image -extra -uname space -r, and now a linux -image -extra -virtual, and here we go. Press Y. So we are done with the prerequisites. So let us go ahead and install Docker. So for that, I'll type sudo apt get install docker -engine. So we have successfully installed Docker. If you want to install Docker and CentOS, you can refer the CentOS Docker installation video. Now we need to start this Docker service. So for that, I'll type sudo service docker start. So it says the job is already running. Now what I'll do, I'll pull a CentOS image from Docker Hub and I'll run the CentOS container. So for that, I'll type sudo docker pull and the name of the image, that is CentOS. So first it will check the local registry for CentOS image. If it doesn't find there, then it will go to the Docker Hub for CentOS image and it will pull the image from there. So we have successfully pulled a CentOS image from Docker Hub. Now I'll run the CentOS container. So for that, I'll type sudo docker run -it CentOS, that is the name of the image, and here we go. So we are now in the CentOS container. Let me exit from this. Clear my terminal. So let us now recall what we did. First, we installed Docker on Ubuntu. After that, we pulled CentOS image from Docker Hub. And then we built a CentOS container using that CentOS image. Now I'll move forward and I'll tell you what exactly Docker Compose is. So let us understand what exactly Docker Compose is. Suppose you have multiple applications on various containers, and all those containers are actually linked together. So you don't want to actually execute each of those containers one by one, but you want to run those containers at once with a single command. So that's where Docker Compose comes into the picture. So let us proceed with Docker installation. First, I'll make sure my existing packages are up to date. So for that, I'll type sudo yum update, and here we go. So no packages marked for update. I will clear my terminal now. Now I will run a Docker installation script. So for that, I'll type curl -fsl, and now I'll give the link https get.docker.com/sh, and here we go. This script adds the docker.repo repository and installs Docker. It is done now. Our next step is to start a Docker service. So for that, I'll type sudo service docker start, and here we go. So Docker has now started successfully. Now I'll pull a Docker image for Ubuntu operating system. Docker images are used to create containers. If the image is not present locally, Docker will pull the image from registry.hub.docker.com. Currently, I don't have any image. So I'll pull an image for Ubuntu operating system. And for that, I'll use sudo docker run and the image name, that is Ubuntu. And here we go. As you can see, unable to find image. I can highlight that with my cursor as well. So just notice it is unable to find an image locally. That means it is pulling from registry.hub.docker.com. So it has downloaded a newer image for Ubuntu. In order to start using container, you need to type sudo docker run -it and the name of the image, which is Ubuntu. And here we go. As you can see that we are in Ubuntu container right now. I'll open one more tab. Over here, if you want to see all the running Docker containers, you can type sudo docker ps and it will display it for you. So as you can see, the name of image is Ubuntu, and this is the container ID for that particular image.
So why should we use Docker for Windows? Now the first reason is that it avoids the work on my machine but doesn't work on the production problem. Alright. Now this problem occurs due to the inconsistent environment throughout the software development workflow. Now for example, let's say that a developer has built an application on Windows environment, and when he sends the application to the testing server, it fails to run. Now this happens because the testing server operates on an outdated version of Windows. Now obviously the application does not support the dependencies needed to run on the outdated version of Windows. So because of the difference in the software versions in the development and testing server, the application will fail. But when it comes to Docker, we can run our application within a container which contains all the dependencies of the application, and the container can be run throughout the software development cycle. Now this practice provides a consistent environment throughout. Now apart from that, it improves productivity. So by installing Docker on Windows, we're running Docker natively. If you've been following Docker for a while, you know that Docker containers originally supported only Linux operating systems. But later Docker made its platform available for other operating systems, but with a simple limitation. Now the limitation was that Docker engine ran inside a Linux-based virtual machine image on top of the operating system. So basically you could run Docker from Windows or any other operating system, except Linux was still the middleman. But thanks to the recent release, Docker can now natively run on Windows, which means that Linux support is not needed. Instead, the Docker container will run on Windows kernel itself. Alright. So guys, just like I mentioned earlier, Docker for Windows supports native networking. Now, not only the Docker container, the entire Docker toolset is now compatible with Windows. This includes the Docker CLI, Docker Compose, data volumes, and all of the other building blocks for Dockerized infrastructure, which are now compatible with Windows. But how is this advantageous? Now, since all the Docker components are locally compatible with Windows, they can run with minimal computational overhead. Now let's move on to the prerequisites. So before you install Docker for Windows, you need to check if you're running on a Windows 10, Pro Edition, Enterprise Education, Student Edition, 64-bit system. Now guys, a point to note here is that Docker will not run on any other Windows version. So if you're running on an older Windows version, you can install the Docker toolbox instead. Okay. Now Docker for Windows requires a type 1 hypervisor, and in the case of Windows, it's called the Hyper-V. Now what is Hyper-V? Hyper-V is basically a lightweight virtualization solution built on top of the hypervisor framework. So you don't need a virtual box, you just have to enable hypervisor. Alright, and also you need to enable the virtualization in BIOS. Now when you install Docker for Windows, by default all of this is enabled. But in case you're facing any issue during installation, please check if your Hyper-V and your virtualization is enabled. Now let's move on to the demo. So we're going to begin with installing Docker for Windows. Now before we go ahead, guys, you have to make sure that you're using a Windows 10 Pro, Enterprise, Education or Student Edition. One more important point to note here is that if you're using a virtual box on your system, you won't be able to run it because a virtual box will not work with the hypervisor enabled. But in order for your Docker for Windows to work on your system, the hypervisor must be enabled. So guys, basically you cannot run Docker for Windows and a virtual box on the same system side by side. Okay, so if you have a virtual box in your system, it's not going to work because you'll be enabling your hypervisor. So let's get started by installing Docker for Windows. Now in order to install Docker for Windows, you need the Docker for Windows installer. Now I'll leave a link in the description box so that you can download the installer. So guys, I've already installed the Docker for Windows installer. Y'all can go ahead and download it from the link in the description. Now here you can see that I've run the installer. So now let's just wait for the installation to complete. Okay, now let's just click on OK. Alright, so it's unpacking files. Alright, so the installation is completed. So guys, once you've installed it, just open the Docker for Windows app. Alright, it's here on my desktop. So when you try to start the application, you'll see a whale icon on the status bar. Alright, here you can see the whale icon. Now when the whale icon becomes stable, it means that Docker has started and you can start working on it. Okay. So this icon needs to get stable. That means that Docker has started. Alright. So you can see a message popped up like this. Okay, it says Docker is now up and running. Alright. So guys, you can either log into your Docker Hub account from here or you can use the Docker login command and log in. Alright. I'm going to go ahead and log into my Docker Hub account. So now you all can open up any terminal and start running Docker commands. So guys, I'm going to be using Windows PowerShell. Now make sure you run as an administrator because there are a lot of commands which require admin access. Okay, let's say yes. Alright. Now in order to check if we've successfully installed Docker, what we're going to do is we're going to check the version of Docker. So the command for checking the version is docker space -- version. Alright, so it's returning the version of Docker that I've installed, which means that we've successfully installed Docker. Okay. So now that we know Docker is successfully installed, let's run a few basic Docker commands. Okay. So let me just clear the terminal. Now I'm going to run docker run hello world. Now this is the most basic Docker command that's run once you install Docker. Okay. So I'm basically going to run the hello world image. Now let's see what happens. So it's unable to find image locally. So it's going to pull the hello world image from Docker Hub. Okay. All right. So this basically gives a hello from Docker message. So we finished the first command. Now let's try something different. Yeah. So you use Docker images command to check the images that you have in your system. Since we just ran this hello world image from Docker Hub, we have this image in our repository. All right. Now let's pull a Docker image from Docker Hub. Okay. Now in order to do that, you just use this simple command called docker pull and the name of the image that you want to pull. Alright, so I'm going to pull an Ubuntu image. Let's see how it works. So it's basically pulling Ubuntu image from Docker Hub. Alright, now let's run this image. So guys, do you remember that I said that whenever you run a Docker image, it runs as a Docker container. So whenever I perform this command docker run -it -d and name of the image. Alright, so whenever I use docker run and I run an image, it's basically going to create a container from this image. Okay, so it's going to create an Ubuntu container. Alright, now the next command is docker space ps -a. Now basically this will show all the containers. Alright, so basically we have two containers over here because we ran both of these images. Alright, so whenever you run an image, it runs as a container. That's exactly what I told you earlier. Okay, let's clear this. Now let me type this out and then I'll tell you what this does. All right. Now what I'm doing here is I'm just accessing a running container. Okay. This is the container ID, which is basically the Ubuntu image that we pulled. So I'm basically giving the container ID of this Ubuntu image that we pulled. Now we're basically within the container. Okay. You can perform commands like, let's say, echo hello. All right. So it says hello. Now what you can do is you can just exit from here. All right. So you come out of the container. Okay. Now let's try to stop a running container. Okay, let's say docker stop and the container ID. All right, so it stopped that container. Okay. All right, so the next command is docker commit. Okay, let me just type this out and then I'll tell you what it does. Okay, so basically I'm using the docker commit command. So basically it's going to create a new image on the local system. So after docker commit, I have the container ID and I'm going to create an image out of this. And after a space, I've mentioned Zulekha/Ubuntu. Now Zulekha is basically the name of my Docker Hub repository and Ubuntu is the name of the image. All right, so let's see what happens. So basically we created a new image over here. So here you can see that there's another image which is added, which is Zulekha-Ubuntu. Okay, it has a new image ID and so on. All right. Now guys, if you perform this command without logging into Docker Hub, they're going to ask you to log in first. Okay, and for that you can use the command which is docker login. All right. Now I've already logged in earlier in the session, so that's why it says login succeeded. Otherwise it's going to ask you for your credentials. All right, it's going to ask you for your username and your password. Okay, now what we're going to do is we're going to push this image to Docker Hub. So we're going to use the docker push command along with the name of my Docker Hub repository and the image name. All right, so it's preparing and it's going to push this image to Docker Hub. All right, now let's say that you want to delete a container. So what you can do is you can use the docker rm command. So basically the command goes docker rm and the container ID. Okay. All right, now let's look at our containers. Now we have only one container. So basically the container with container ID, this got deleted. Okay. Similarly, you can also remove Docker images. All right. So first let's look at the Docker image ID that you want to remove. All right. Let's say I want to remove Zulekha/Ubuntu. Okay. I'm just going to use this image ID and the command is docker rmi and the image ID. Now let's look at the Docker images. Now you can see only Ubuntu and Hello World is there. So this is how you remove Docker images, and I also showed you how to remove Docker containers. So those of you who weren't familiar with Docker have a good idea of how simple Docker commands work. Alright, so now I'm going to create a simple Python web application using Docker Compose. Okay, now let me tell you a little bit about this application. It basically uses Flask framework and it maintains a hit counter in Redis. So guys, for those of you who don't know what Flask is, it is basically a web development framework which is written in Python, and Redis is an in-memory storage component. It is basically used as a database. Okay. Now guys, don't worry if you don't know Python. This program is very understandable. So we're basically going to use a Docker Compose to run two services, which is web service and Redis service. Now what this application does is it's going to maintain a hit counter every time you access a web page. So each time you access the website, a hit counter gets incremented. Okay, it's simple logic. Just increment the value of the hit counter when the web page is accessed. Okay. All right, so let's begin with creating a directory for your application. It's always a good practice to have a directory which stores all of your code. All right, so let's start with creating a directory. Let's say web application. All right, now I'm going to change to that directory. So guys, I've already typed out the entire code because I didn't want to waste a lot of time. So what I'm going to do is I'm just going to open up the files and I'll explain what the code does. All right, so I have all of my code written in Notepad++. So I'm just opening up Notepad. Also guys, I want to tell you that you don't have to install Python or Redis. We're just going to use Docker images for Python and Redis. Okay. So first what you have to do is you have to create a Python file. Okay, I've called it web app. So I'm not going to spend a lot of time over here. I'll just tell you what we're doing. So first of all, we're going to begin with importing the dependencies. So we're going to import real-time. We need Redis. We also need Flask. Okay, these are the requirements that we're going to import. After that, we're just initializing the name of the application. So here we're just hosting the database and we're connecting to Redis using the port number 6379. All right, this is the default port. Then we define the get hit count function. this basically returns a number of hits. So we're also setting the retries to 5 in case the page does not load. While all of this holds true, the incremented hits are returned. And if there's an error, then we have an exception. So we've also defined exception in case of errors. This function is basically to display the hello world message along with the hit counts. So this is the Python file. It's very simple, guys, very understandable. You don't have to be a pro in Python to understand this. This is very understandable. All right. Now the next file you're going to create is a txt file, which I've named requirements.txt. Okay. Now over here, I'm just going to add my requirements, which is Flask and Redis. So next we have the Docker file. Now this Docker file is used to create Docker images. Okay, I mentioned this earlier in the session that you require Docker files to create Docker images. Okay, so first we're just setting the base image. So we're building an image starting with Python 3.4. Now in this line, we're just going to add the current directory into this -code path of the image. Then we're going to change the working directory to this path. After this, you're going to use a package manager of Python to install the requirements that I mentioned in my requirements.txt file. Okay, so these two were the requirements, which is Flask and Redis. And then finally, we're just setting the default command for the containers to Python web app. Okay, so it's basically going to run my web app. Now we finally have a Docker compose file. Like I mentioned earlier, that a Docker compose or a YAML file is going to contain all of the services. So there is web service over here and there is Redis service. So we're basically running two containers over here, or two services over here, which is web and Redis. So now the web service is basically building the Docker file in the current directory. All right, the dot signifies the current directory, and it forwards the expose port 5000 on the container to the port 5000 on the host machine. Now the Redis service is basically using a Redis image pulled from Docker Hub. So guys, this was all about the files. You need to create a web application file, which is a Python file, and then you have a requirements.txt file, then you have to have a Docker file and a Docker compose file to run both of these services. So guys, now that I've explained the various files, what I'm going to do is I'm going to run both of these services or both of these containers by using the docker-compose up command. All right, guys, make sure to create all of these 4 files, and you have to create them obviously in the web application directory. So if I do ls, I know that I have a docker compose.yaml file, I have a Docker file, I have requirements.txt, and I have a web app.python file. Now let's use docker-compose up to run all of these containers. So it's just building from my Docker file. So now it's installing my requirements over here. So now it's running my web app.python file. Now it's creating 2 services over here, which is web service and Redis service. So what I'm going to do is I'm going to look at the output by using Kitematic. So guys, I told you all earlier that Kitematic is basically a UI tool for Docker for Windows. So just left click on the Docker icon over here, and here you're going to see Kitematic. Okay, click on it. Alright, I think I'm facing an error. I'm just going to go back to my files and see if I have missed out any line. Alright, so over here I have written RT. This is actually import time. Okay, this was a simple mistake. So let me just save this and let's try and run this again. Now it should definitely work. I'll just clear the terminal and we're going to use docker-compose up. Alright. Now guys, what I'm going to do is I'm going to show you the output using Kitematic. Here you can see an option Kitematic. So click on this. Now it shows 2 applications over here which are running. One is the web service and the other is the Redis service. Now when you go to the web service, you can see the output over here. Let's click on this. So whenever you refresh the page, the hit count increases. So this is how the application works. If you keep refreshing, the hit count will keep increasing. So guys, this was a simple web application, and I also showed you all how to view this using Kitematic. Okay, so now you can see that this is green, which means that it's running. All right, you can also restart the container, you can stop it, you can enter into the container, and you can run a few commands. Okay, you can use Kitematic in a lot of other ways.
Let's go about writing a Docker file. First of all, your Docker file is just gonna be a file, okay? Just gonna be a text file without any .txt extension, okay? And your Docker file will basically contain commands and arguments only. And that is all that is needed to run, okay, these commands and arguments. But additionally, if you want to just comment something, if you want to use bogus lines, then you can use it. Then you can write it by using this hashtag over here, okay? So technically it might involve you having commands and arguments, okay? So my commands and arguments are the ones which are going to help me customize my Docker image, and the commands is something which I can write for my explanation, okay? So if I say hashtag over here, then whatever comes in that particular line after the hashtag would be ignored. So if I say print welcome to Edureka, then I'm just giving a sample here. So this line would be completely ignored and not executed. But however, in the second line, if I have run echo welcome to Edureka, then this line would be executed, okay? And in this case, I have my commands and arguments. Run is going to be my command, and echo welcome to Edureka will be my arguments. So I can have argument 1, I can have argument 2, I can have argument 3, and many more. Okay, but by default your arguments would be just 2. Okay, I will have one command and then 2 arguments. Okay, so let me go into more details of these things, and by details I want to talk about the different syntax that I can use here, the different functionalities or the different commands that I can use. Okay, so let me start off by talking about the most important command, which is nothing but the from command. So from is the most important command because without the from command you cannot write a Docker file, because the from command is what is used to specify a base Docker image. Okay, in my case I've specified here Ubuntu, which means that I will be using an Ubuntu as my base Docker image, and all my customizations will be on top of my Ubuntu image. Now think of it very much like you working on a server or you working on a Linux machine. Okay, you have an Ubuntu machine with you, and then if you want to execute or deploy your application on that particular machine of yours, you have to install everything, right? So you've not done the other steps though, but so far by using a from Ubuntu, it means that you have an Ubuntu machine with you. So this is just the base image, which can be equivalent to you just having an Ubuntu machine. Okay, and what you do after that onto that particular Docker image depends on the other functionalities. And then moving on to the next command is the run command. Now this is again, I would say, the second most used command, because at the end of the day, if you want to run a particular image or if you want to run a particular command, then you use this run command. In my case, if I have an Ubuntu image and if I want to install say Java or Jenkins or React or curl, then I will be using this run command. Okay, so I have my run command, and then my arguments here would be apt-get install with a yes flag. I'm saying React or Jenkins or whatever. Okay, so that's what my run command does. It's basically for executing any command of mine, but it has a slight difference when compared to CMD. Okay, because run is used to run a command. Okay, it can be a command which is it could be a shell command, or it could be a command which basically runs my image into a container. Okay, and that is what the difference is with respect to CMD. With CMD, you again can execute your shell commands like I've done here. I can say CMD echo welcome to Edureka, but however I cannot use a CMD command for building my Docker image. Okay, so I cannot execute my Docker image, or I cannot build my Docker image with the help of the CMD command. So if I want to execute a command on my shell, I can use either run or CMD, and if I want to basically build my Docker image, then I can only use run. In such places CMD don't work. Okay, so moving on, the next important command is the entry point command. Okay, the entry point command is basically used to basically override whatever function your CMD command does. Or the entry point basically suggests that when you've finished building your Docker image, then the command which is specified with the entry point, that will be the one which will be executed first when you run the Docker container of that particular image, right? So I can build a Docker image which has this entry point command, and my Docker image will be built, and when I execute that particular Docker image, then the command which is specified with entry point will be the first command to be executed. Okay, and the additional functionality that entry point has is the one which I already said, which is nothing but it can override your CMD command. So take for example over here. So here I'm saying CMD welcome to Edureka. Okay, and here if I say entry point echo, then my entry point will basically override this, because most of the time your CMD commands would be the first set of commands which would be executed in your Docker file. Okay, you can have a lot of things, but in your CMD command you will have some set of arguments present over here. So in this case I have one command and then one argument, but with my entry point, if I say entry point echo, then this would be used as my argument to execute this argument of mine. Okay, so that is the whole point of entry point, and this is the subtle difference between entry point and CMD. Entry point can basically override your CMD commands. So next comes the add command. Now the add command or the copy command, these are commands which can be used interchangeably, because the add command is used to copy whatever files which are there in one particular directory to another directory. Okay, so it could be copying files from my host to my container. Okay, so I'm saying add, and then I can just specify the path of my source. After that, with a space, I can specify the path of my destination to where I want to copy my files. Okay, so this is also pretty self-explanatory. And then the environment command. Now, if my application needs a particular environment variable, then I can specify to my Docker container that this application needs certain environment variables, and this environment variable is present over here. So an example of this could be, if you want to execute a Java program, then you need Java, right? And you have to set your environment variables. So I can specify my Java environment variables like this inside my Docker container. So my environment would be my command, and these would be my arguments. So server works would be my argument 1, and this would be my argument 2. All right, so that was one example. And then the next important command that you have to be aware of is the working directory command. In your Docker container, a lot of times you would want to go into a particular container and then start execution inside that container, especially when you want to execute certain commands in the shell, right? So if you want to use the cmd command inside your Docker file, then you want to basically execute a particular command on the shell, correct? But where exactly do you want to execute that command? Because these commands will be executed from inside the container. And inside the container, if you want to customize the place where you want to execute that command, if you want to change the place where the cmd command will be executing its arguments, then you have to set the working directory over here. So you will say working directory, and you'll just set the path over here. And then whenever you have a cmd command which gets executed, then that cmd command would be executed in this particular path. Okay, so pretty simple, right? And then we have the expose command. And the expose command is a very important command in case of front-end applications, because so with the expose command, you can specify a port number, and you can specify that this application would be active on this particular port number inside the container. Okay, and yeah, this will be the one which is running inside the container. And however, if you want to execute the same particular application and you want it to run on a particular port number on your host, then you have to do the port mapping, but that comes later on. But inside the Docker file, this is how you specify that. And remember, this is going to be only specific to your container, and this port number is only going to be used from inside your container. The next thing is the maintainer command. So it's not a very technical thing, but if you want to tag your name along with the image which you are building, then you can use this maintainer to specify who's the person that's maintaining this particular Docker image before you upload it to Docker Hub. And then that way, whoever uploads or downloads your image from the Docker Hub will know that, okay, this is the guy that basically built your image. Okay, so you can just set your name over here. And this has to be present only after the from command. That's the point which you have to note. And then we have the user command. And if you want a particular user to execute or to run a container, then you can use this user command and specify the user ID of that particular user whom you want to execute the Docker container. Okay, so it's pretty simple, right? So the user here is my command, and 751 is the argument. And this particular user who's having this UID will be executing that particular Docker container of mine. And then we have the one last command that we're going to talk about, which is nothing but the volume command. So this volume command is basically used to set a custom path where your container will store all the files. So this is the place where all the files related to your Docker container will be present. And even if you want two containers to share the same path, then you can use this volume. So this path, it can be shared by multiple containers. So logically, if you have multiple containers which are hosting the same application, then you might want them all to use the same path, right, where it's stored. So this is the path where it can be present. So that's it. And now let's move on to our demo. And first, I will show you how to install your Apache web server, and I will show you how to write a Docker file. Okay, so in the first demo of mine, I have a simple Docker file where I'm first of all using an Ubuntu image as my base image, and then I'm saying maintainer is Edureka, and then I'm running a few commands. Even if you're trying to install Apache on your local machine on Ubuntu, then you will have to probably run these commands. You'll have to do an apt-get update. This basically updates my apt-get repositories. Okay, and then you'll have to mainly install your Apache service. So the command for that is apt-get install Apache, wherein your Apache will be downloaded from your apt-get repository, and then you will want to clean your apt-get repository. So you'll use the apt-get clean command, and most importantly, we are deleting this particular path. Okay, so you will have various files which are there in this particular path where libapt lists. Okay, so whenever you use an apt-get update, and if you get an error that time, then that's because of the files which are present in this particular path. So to avoid any error that comes in the future, we are deleting whatever is created over here. Okay, and rm-rf is what is used for that. And our run command is what performs all of these. So I have up to 4 functions or 4 commands which need to be run, and I'm using one run command and using an and over here. Okay, an ampersand to say that I have multiple commands which need to be run. So that's the thing. And for my Apache to work, I have to set my environment variables, and that's what I've done here. So it's pretty simple, and it's the same as the installation process. It's just that I'm setting it manually inside the Docker file on my own. Okay, so for Apache run user, for Apache run group, and for Apache log directory, there are various paths where it has to be present, and that's what I've specified in arguments over here. So these are my first arguments, and these are my second arguments. And then I'm saying expose 80, which means that on port number 80, my Apache service would be hosted. Okay, but remember, this is only from within the container. Okay, if I want to access it on my host machine, then I have to do the port mapping while starting this particular container of mine. So inside my container on port number 80, Apache will be present. And finally, if I want to start this Apache service, then I have to go to this particular path, and then I have to start that Apache 2 service, right? I'm doing the same thing over here using my CMD. So using the CMD command, I'm saying go to this particular /user/sbin/apache2, and I'm saying execute this and run it in foreground mode. So -d is the flag which we have to specify, and then I'm saying foreground to basically get the UI up and running and to get it hosted. Okay, now to show you the same demo, let me open up my virtual machine where I have prepared this Docker file. So this is my VM. I hope you all can see my VM over here. Okay, so I'll just open up my terminal and I'll bring up my Mozilla Firefox. Okay, so let me do an ls, and then I have my documents folder, right? So let me do cd documents, and let me do ls. So I have a Docker file here. Let me do cat Docker file and show you that I have the same code present over here. Okay, so what I explained right now as to how to install Apache and then use the various commands, I have copied that same code into this particular Docker file of mine. Now the first thing I have to do is build a Docker image, which is going to be my custom Docker image out of this Docker file. Okay, and the second thing I have to do is to run that particular Docker image into a container. All right, so let me get started with the first thing. So if you want to basically build a Docker image from your Docker file, the command is docker build -t, and then you have to specify the name of your Docker image. Okay, so I'm going to say my Apache image. Okay, and then I'll just say the place where the Docker file is present by mentioning period. So by mentioning period, it means that the Docker file can be present in this particular directory, and based on that Docker file, this Docker image will be built. So let me hit enter and just wait for the various steps to be performed. Okay, so step 1, step 2, step 3, and then all the different steps which I specified inside my Docker file are being executed one after the other. So my first step here is nothing but from Ubuntu, which means that I'm pulling a base Ubuntu image that is present over here, and then I'm saying step number 2, make Edureka as the maintainer, and then step number 3, where I'm installing various functionalities. Okay, so let this complete. Okay, I think this part can be forwarded and moved ahead. Okay, so I think all the steps have been executed successfully because I've got this message, right? Successfully built and the ID of my Docker image. So if you intermittently see step 4 executed, step 5 executed, step 6, step 7, and step 8, everything have been executed. So my Docker image has been built, and then I can verify the same by running this command, docker images. Okay, let me say sudo docker images, and as you can see here, my Apache image with the latest tag has been built 28 seconds ago. All right, and this is the size of this particular Docker image of mine. Now let me use this Docker image and bring up the Docker container out of this image, and the command for that is sudo docker run. And now I have to specify the port number, because inside my Docker file I've specified that the application has to be active on port number 80, and if I want to access that application on my host machine, then I have to do the port mapping of my host port to my container port. So let me say -p and say 80:80. So this means that port number 80 of my container will be mapped to my port number 80 of my host. Okay, so first comes the host, then comes the container. And after this, I can just simply specify the image which I want to build, right? So I can say the name of the image is my Apache image, and I can also give a name to my particular container. I can say hyphen name equal to app1. Okay, so I can give enter, and yes, so ignore this message, but anyways my Apache service would have been installed. So let me just go here, and if you remember, it was port number 80 where it was hosted, right? So let me just type in localhost colon 80, and yes, it says that it works. This is the default page for the server, and the server is running, but no content has been added yet. That's because I have not done anything manually, but it's just that I've hosted the same service which I got. This is my Apache service which I've installed. Okay, so my service is running now, and I can verify that from a different terminal. So let me just go here and say docker ps. Okay, sudo docker ps, and you can see that my Apache image was the name of the image, and then the name of the container is app1, and this has been containerized, and it's basically created these many seconds ago, right? Now if I want to stop running the service, I can either stop this container over here. I can run a command to stop the container, or I can simply use a control C, and with that I'm out, right? This container is not being executed anymore. So this is a shortcut, but it's not advisable. Rather, the command to stop a container is docker stop and then container ID. So I will show you how to do it with the second demo. Okay, but let me just go here and verify that again. So if I refresh this, then the page is not accessible anymore. That means my container is not running, and hence the server is not working. So that's the end of the first demo of mine, which shows how to install Apache. Okay, so let me just do a sudo docker ps -a over here and show you that the same container over here with the same ID has exited. Okay, and let me clear the screen here and over here too. Okay, and then get to my second demo. So my second demo is all about installing Nginx. So again, to install my Nginx server, I'll follow the same steps. Okay, I'll first of all use an Ubuntu base image, and I'll be installing my Nginx service on my Ubuntu machine. So that's why I'm doing from Ubuntu, and then I'm specifying maintainer Edureka, and then similarly I'm using or running the command run apt-get update, run apt-get install -y Nginx, and then I'm doing add an index.html. Okay, now first of all, let me tell you that with respect to the previous demo, I ran these two commands on the same line, correct, with an ampersand. Here I've just divided it into two lines, so it's just to show you the functionality and the shortcut which I used in the previous demo. Okay, but otherwise it's all pretty much the same. And then what is new here is the index.html, because with Nginx, this index.html is not created by default. So I just created an index.html file, and then I put my own code in that index.html file, and that is what I'm putting inside my container over here. So if you remember, the add command basically copies what is there in one path to the destination path. So this is my source path, which is my host path, and this is going to be my container path. So index.html, which was there in my same folder, that is copied inside my container. So there is Nginx inside the user/share. Okay, so inside that there's another folder called HTML, and inside that folder the index.html file will be copied. And once it's copied over there, from here I'm using an entry point command, so that whenever my container is running, right, so I have my Docker image, and then when I execute the Docker container, then this line would be executed. So these will be built, though all the environment would be set up over here, but this command /user/sbin/nginx, so this is the service which needs to be started. So my Docker is going to particularly go to this particular path and then start my Nginx service by giving the flag -g and daemon off. So daemon off here basically helps me bring my application to the foreground. Okay, so if it's daemon on, then the application would be running in my background. Okay, but since I've specified daemon off over here, and because I've specified daemon off and brought it to my foreground, I can see the UI, and I can only see the UI if I say the particular port number, and that is what I've done in my final line. I've said expose port number 80 again. So if I've said expose port number 80, it means that in my container it's going to be hosted on port number 80, and I can map this to my host port in my run command. Okay, and when I run the command, I'm going to repeat again, when I run the command, this would be executed, and this was what brings up my Nginx service. Okay, so let me go back to my terminal and show you the file. But however, it's not in the documents folder, so let me go back and go to my downloads folder. Okay, so here I have my index.html file, and then I have my Docker file for installing Nginx. So first let me do a cat Docker file. So it's the same set of code which I explained a few seconds back. And then let me also do cat index.html. And this is basically my HTML code which will be displayed on my UI. So the title of my page is going to be Edureka's Docker Engines tutorial, and then in hashtags I have hello Edureka learners, and then I have a p tag where I've specified something. So this is the backend of a HTML file, and this is how any HTML file is built, right? So I've just copied it and I've pasted it. So this is how the backend HTML of any web page will look like, right? So I've just created that and hosted. I actually had it on my machine, and then I basically put it inside my Docker container, and then I'm going to start the Nginx service. When I start the Nginx service, this index.html file will be picked up and be used as the default page or the first page which comes up in my UI. Okay, so let me clear the screen and first of all execute this Docker file. Now to build the Docker image out of this Docker file, the command is docker build -t, and then after specify the name of the image, let me say my Nginx image, and then after this let me say the path where the Docker file is present, and I can do that by specifying dot, and let me go ahead and also specify sudo. Okay, so my first step executed, second step also executed, and so is my third step, and let's just wait for all the steps to be executed so that my custom image is built. And trust me, this is my custom Ubuntu image. Okay, okay, so that was my build command, and if I want to execute or bring up the container out of this particular image of mine, I can use the command docker run -p. I'll specify the port number where it will be active, and let me again say 80:80 followed by the name of this particular container. I can say name is equal to app2, and then I'll just specify the image which I'm going to use. So my Nginx image, so this is the name of my image, right? And however, I have to also specify sudo over here. So if I hit enter, my container would be active, and since I've specified entry point, basically it would go to that particular path and start my service. So let me just go to localhost and check if that's working. Okay, I'm going to say localhost 80, and yes, this is my Nginx service. Of course, it's a little different from my Apache service, and I've customized this one to say that this is my page title, Edureka's Docker Nginx tutorial, and then I've specified hello Edureka learners, and then this, right? This is what I also showed you sometime back in that index.html file. So this time, let me show you how to stop this particular container by not doing Control-C, but by actually stopping your container in a healthy way. So let me open up the second tab over here, and over here, let me say sudo docker ps. This would first of all list down this particular Nginx image of mine. Okay, this is the container ID. So I'm going to copy this container ID and then stop this particular container. I can say sudo docker stop and then container ID, and my container would have stopped by now. So if I go back to the other tab, you can see that I've got control back here, which means that my application is stopped being deployed. So if I refresh this page, you can see that I do not have access to the page anymore, right? So that's how you host any application of yours, and that's how you bring it down with the help of your containers. Okay, in a snap of your fingers, you can get anything done, and that's why Docker is really good and really useful.
The commands that you see on your screen here, they are the ones which are most commonly used. So if you are a DevOps engineer, or if you're just someone that's working on Docker, then you might have already used these commands, or you might use them in the near future. Some of those commands are docker version, docker help, docker pull, docker run, docker build, docker login, docker push, docker ps. Here ps stands for Docker processes, and this command is used to see what are the active containers currently. And then you have docker images, then you have docker stop, docker kill. There is docker rm, which of course stands for docker remove, docker rmi, which stands for remove images. We have docker exec, and this is used to access the bash of any active container. And then we have docker commit, we have docker import, docker export, docker container, docker compose, docker swarm, and docker service. So these are the 20+ docker commands which are most commonly used. Now, without wasting much time, let me get started and discuss each of these commands. Docker version. This command is used to find out what is the version of your Docker engine. Okay, so remember, there will be two flags that will come in before writing version. And then we have another command, which is docker, again, 2 flags, and then help. Now, this is basically used to list down all the possible commands that you can use with Docker. So here, Docker will be your parent command, and whatever child commands that are possible here as permutation and combinations, those will be listed down. Now, let me quickly open my terminal and execute these 2 commands for you. Do remember that I will be using my Linux virtual machine, okay? And this Linux virtual machine of mine is an Ubuntu machine, and it's hosted on my VM, like I said. So I'm just going to open my terminal over here, and the first command that we are supposed to execute is docker version, right? So as you can see, the version of my Docker engine is 17.05. Okay, so that's how this command works. Now the next command that we were supposed to execute is docker help. That of course would also come with 2 hyphens. And like I told you, there are various commands that you have in Docker, like docker attach, docker build, docker commit, docker cp, docker create, docker diff. So all of these are the other child commands that can be used with Docker, okay, as a primary command. So I hope that was clear. And at any point of time, if you people have any doubt with respect to usage of any command in Docker, then you can just use the help, right? And help will basically tell you the different commands that are there along with a description. So it will also explain what each and every command does. Now, let's say you have docker build, then you can see the explanation that it says build an image from a Docker file, right? So that's a good enough explanation. If I was a guy that's working on Docker, then I would know which option to use, right? Similarly for everything. So for docker rm, it says remove 1 or more containers, and then for docker start, it says start 1 or more stopped containers, and many more. So whenever in your free time, you can use the docker help command and see what are the different commands possible along with their explanation. Okay, so I am going to clear the screen and go back to my PPT and check what are the next set of commands that I can execute. And remember, these are all still basic Docker commands. Okay, so the next command is docker pull. Now the docker pull command is used to pull any image from the Docker hub. Okay, and then we have docker images command, which of course lists down all the images in your local repository. Now in the previous command, we do a docker pull, right? So for the first time, you will not have any image in your local repository. You will have to pull it from your Docker hub. And when you pull it from your Docker hub, it gets stored in your local repository. And once it is there in your local repository, you can run the docker images command and then check all the different images. So all the images will be listed down. Okay, so that's about these 2 commands. And then we have docker run command. Now, the docker run command is basically used to execute that image. And I'm pretty sure you are aware that whatever you download from the Docker hub are images, right? And if you want a running instance, or if you want it to be active, then you have to run it, because what you will have to deal with, they are containers, right? And to get containers running, then you have to basically run those images. That's the same thing that we are doing here. The command is docker run along with the image name. So supposing I'm pulling an Ubuntu image from Docker, so I will be using this command, docker pull Ubuntu. Okay, and if I want to execute this image and get a running container out of it, then I would have to basically go here and run the command docker run along with that particular image name, docker run Ubuntu. Okay guys, so I think you have a decent understanding of these 3 commands. Now let me again go back to my terminal and execute these 3 commands and show you how they work. So I'm back to my terminal here. Okay, so here let me write down the command docker pull Ubuntu. Now by running this command, I am pulling the latest Ubuntu image from my Docker hub. Okay, so when you hit enter, in spite of the fact that I did not specify any tag over here as latest, it's pulling the latest image that is available on the Docker hub. Okay, so let the process happen, guys. Give it a minute. Perfect. So now you can see the status here, right? It says it has downloaded a newer image for Ubuntu, that is with the tag latest. Now if I want to check if this image has actually been pulled, then I can run the command docker images. Now let me run that command by first clearing the screen and then actually running the command docker images. When you hit enter, like I said, you have the entire list of images available in your repository over here. The entire list is down over here, correct? So you have custom image, you have Vardhan NS /custom image, right? So this is another image which I created. if you want to check if your image is latest, then you look at Ubuntu here, right? So this has the tag as latest. And this was an image which was created 10 days ago in my local repository. And it is about 112 MB. Okay. This is the one which we downloaded recently, and it has the latest tag. So this is how you check the different images that you have in your local repository, guys. Okay, so I'm going to clear the screen, and now it's all about executing a Docker image. So for sample purpose, I can even run any kind of an image and get a container, right? So before I execute an Ubuntu image, let me execute a simple hello world container. So for that, I'm going to say Docker run hello world. Now remember, when we say Docker run hello world, you might ask me a question that, is hello world already present in my local repository? Well, the answer is it's actually already present. So I have an image of hello world in my local repository. But even if I do not have the hello world image in my local repository, this command will run, because when you do a Docker run command, this would first of all look for this particular image in your local repository. If the image is not present, then it will go to the Docker Hub and look for an image with this particular name, and it will pull that image with the latest tag. Okay, so run does two things: it pulls and it executes. Okay, so let me hit enter, and there you go. It says hello from Docker, right? So this is the hello world container for Docker. Now the reason I did not execute the Ubuntu image is because I want to make a few modifications to that image. But if you want to make a few modifications to that image, then you have a different set of commands which are involved. So let me go through those commands and then get back to what I was supposed to do. That was about Docker run. And then we have something called as Docker build. Okay. And this Docker build command is used to build a custom image of yours. Supposing you have an Ubuntu image, okay, but you do not want it exactly as it is, and you want to make a few adjustments to that. So another example for that would be the node image. Right, in my previous sessions, I've had sessions on Docker Swarm, I had a session on Docker Compose, and many more, right? So over there, what happens is I'm using a Node.js image as my base image, and then I'm building my entire application on that. So what you have here is you have a base node image, okay? And on that node image, you build your entire application, be it an Angular application or be it a MeanStack application. And the command that you use to build the entire application is the Docker build command. And as you can see, this is the syntax. You have to say Docker build with the flag -t. And the T flag, what it does is it basically tells you that you can give your name with a tag for your image which you're building, because this image is going to be your image, right? You're customly building this image. So when you custom build this image, you can give it your own name, and that's what this is. And followed by that, with a space, I have specified a dot here. Now the dot specifies that the Docker file which is needed to build this Docker image is present in the current directory where this command is being executed. Now, had I specified the entire path of my Docker file, then I wouldn't be specifying the dot over here, right? But in that case, if I'm specifying the entire path, then that means that my Docker file is present in some other location, not necessarily in the same location where the command is being executed. Okay, I hope that was a little clear to you people. So now if you're still not clear, let me give you a demonstration and then you will be able to understand this in a better fashion. Okay, so let me open my terminal again, and currently we are in the /home/Edureka directory. Now for the demo purpose, I had created a new Docker file. Let me first open and show you that Docker file, okay? And that Docker file is present in the downloads demo folder of mine. If I do an ls, there is a Docker file. Perfect. So let me say cat Docker file. In fact, let me open this in gedit. So sudo gedit Docker file. Yes. Now the Docker file is the most important file if you want to build your own custom images, because whatever you want for the application to run, those dependencies are specified in this file. You have to say which is the base image that you have to first of all download from the Docker Hub and use that as a basis for your application. And then you have to say the other commands that you want to run. Now in this demo of mine, I'm simply downloading an Ubuntu image from the Docker Hub, and I'm just echoing this sentence. Hi, this is Vardhan from Edureka. So it's a very simple process, right? I'm pulling one Ubuntu image and I'm doing an echo on that particular image. So you can just save this, close this Docker file, and then execute this particular Docker file, okay? And since I am in this folder, I can use the dot to specify that the Docker file is present in this directory. Now let me first clear that screen and then run that command again. So the command is docker build -t. Let's give the name of the image as my custom Ubuntu image. Custom Ubuntu. Well, that's good enough, right? And then I'm going to say dot because the Docker file to build this my custom Ubuntu image is present in the same path. Okay, so it says my custom Ubuntu should be in lowercase. Okay, no problem. So let me just check my Docker file once. Okay, now the reason I got this is because my image name cannot be in caps. So what I'm going to do is let me rerun the command with a different name, possibly in small letters. Okay, my custom Ubuntu. Okay, perfect. The command got executed. So if you can see here, it says sending the build context to the Docker daemon. And since I had specified only 2 steps in my Docker file, those 2 steps are being executed here. Step 1 is it's pulling the Ubuntu image from the Docker Hub. And since it's already there in my local repository, it's using whatever is there. Okay. And step 2 is running the echo statement. Hi, this is Vardhan from Edureka, right? This was the second step. And the same echo command has been executed over here. Hi, this is Vardhan from Edureka. Correct? Perfect. So I hope you guys got a good understanding of this particular command, because this is the most important command if you want to make it as a DevOps engineer or a person that's regularly working on Docker, because all of the images that you will be working on in your office or in your workspace, you will have to be working on custom images for your application. So remember how this command is used and how the applications are built. So let me just clear the screen and go back to my slides and see what is the next command in store for us. Okay, so the next command is the Docker container command. And this Docker container command is basically used to manage your containers. Now, let's say you have n number of containers, and because so many containers are active at the same time, your system may be lagging, right? There's a performance issue. So at that time, you might want to close or end certain containers, right? Kill their process. So at that point of time, you can use the container command and kill the container straight away. So it's just one of the different options that we have. So there are a number of other commands which can be used with the Docker container as the parent command. And I would request you to look up the set of commands on Docker docs. Okay. But for now, let me just go back to my terminal and execute one of these commands and show you how they work. So let me go back to my terminal here. And here I'm going to run that command Docker container, and let me run Docker container logs. Okay, but so here let me run the command Docker container logs to basically find out the different logs that are associated with my container. Okay, now the thing is, in arguments I have to specify the container name or the container ID, and since I don't know it right now, let me first find out what is my container ID. Okay, so I'm going to do a docker ps command to list down the different containers. Okay, there are no active containers, so I'm going to do a -a flag. So these 2 commands I will explain in detail at a later point of time, guys. Okay, but anyways, getting back to our problem here, you can see that the hello world container got executed, right? So I'm going to copy the container ID here, and now I'm going to find out what are the logs of this Docker container logs, and then I'm going to paste the container ID. This way, whatever logs were generated for this container, those would be displayed. Perfect. Worked as though the container executed again. So the same thing can be done for any of the other containers. Okay, if I do a docker ps -a and see, there are so many other containers which are there right in my system, I can copy the container ID of any of these and I can execute the same thing again and again. Docker container logs, right? And then I can paste this. So this time the logs of this particular container, which is 916 and this entire ID, this logs have come out. And like I said, with Docker container, you have various other options, correct? You have options like Docker container kill, you have Docker container remove, and all those things. So I can use a Docker container remove and hit enter. And basically when I do that, this particular container is off. So if you remember this ECC, right? This container is the hello world container. And when I said RM, this container is removed. So if I go back and do docker ps -a, then the first entry for the hello world container would not be present. And yes, as you can see, it's not present, right? The hello world container is not present here. Now that's what I want to show you. So I've cleared my screen, and now let me get back to my slides. So I basically executed the docker container logs command and the docker container rm command. So you have various other options. Like I said, you have the container kill, which can be used if you want to kill any one particular container. Okay, you can use the docker container run command to start any container which has been temporarily stopped or which is inactive. Okay, and if you want to again start the container from something that has been stopped, you can use the docker container start command. And these are just a few of the commands, and the entire list of docker container commands can be found in docker docs. Okay, so I would request you to go to docker docs and then see the entire list of commands if you want to learn more about this command. In the meanwhile, let me go to the next slide and continue with our session. The next command that we're going to talk about is the docker login command. Okay, and as simple as it sounds, this is used to log into your Docker Hub account. Can any of you guess why we would need to log in? Well, it's for the simple reason that you might want to push any of your image that you have created locally, right? So when you're working with a team who are all using Docker, then you can just pull the Docker image or create a new Docker image from scratch at your end and build a container. And if you want to share that container with other people in your team, then you can upload it to Docker Hub, right? So how do you upload it to Docker Hub? So if you want to upload it, you don't have any other workaround. So you do it through the terminal. And to do it through the terminal, you have to first do a Docker login. Once you've logged in using your Docker container credentials, then you can simply start pushing your Docker image to the Docker Hub. Okay, so that's why this command is really important. So let me go to my terminal and show you this command. The command is docker login. When I hit enter, it says login with your Docker ID to push all images from Docker Hub. If you don't have a Docker ID, it says head over to this website. So this is where you can create a new Docker ID. Okay, and the username, it says in brackets, it says Vardhan NS. That's my username because I'm already logged in. So I'm just going to hit enter without entering the username again. And the password I can enter is my password. So that, of course, I'm not going to reveal to you people. But once you enter the password and hit enter, then it says login succeeded, right? If your credentials are a match, then you are successfully logged in. And once you're logged in, you can start pushing your Docker images, which you worked on locally, to your Docker Hub. Okay, perfect, right? So let's clear the screen and get back to our slides. Now, like I said, the next command is basically to push your Docker image to your Docker Hub. Remember, the command should have your Docker ID / the image name. Okay, my Ubuntu image, this may be the name of the image that you might have created locally. Okay, but if you want to push it to the Docker Hub, you have to tag it with a name, and that name should be your Docker ID. Okay, so let me get to the terminal and show you how this command works. So let me first look for the image that I want to upload to my Docker Hub. Okay, so when I hit Docker images, the list of all the images come out. And if you remember, my custom Ubuntu is the name of the image which I created. Now let me try pushing this image to the Docker Hub. Okay, so I'm going to copy this and first clearing the screen. And here I need to tag this image with my Docker ID, right? Because right now it has the name my custom Ubuntu and I cannot upload it to Docker Hub with this name. Now, since I have to tag it with my name, there's a command called docker tag, and here you have to specify what is which image that you want to tag. So the image is my custom Ubuntu, and here let me specify my Docker ID / the image name. So I'm going to say Vardhan NS. Okay, now that's my Docker ID and / my custom Ubuntu image, right? So this is the name of my image. I can even change the name, but I've just retained my custom Ubuntu as the name of my image. So when I hit enter, this image would be getting uploaded to Docker Hub. And now this image has been renamed to Vardhan NS / my custom Ubuntu. We can verify the same by running the command docker images. And as you can see here, there is one image with the name my custom Ubuntu, and then there is another image with Vardhan NS / my custom Ubuntu. Correct? Now this is what I have to upload. So now I can use the docker push command. So I'm going to say docker push, and then simply specify the image that you want to push. Docker push /my custom Ubuntu. Hit enter, and the image would be getting uploaded to Docker Hub. And once when you do it from your end, after this command is executed successfully, you can go to your Docker Hub and check that your image which you created locally has been uploaded to the Docker Hub, and it can be shared and accessed by other people. Okay, perfect. So this shows that my image has been uploaded, and let me just clear the screen and get back my slides and move forward. And this command is something that I already executed some time back, right? If you remember, I used the docker ps command to identify which are the containers which are currently active in my system, right, in my Docker engine. So that's what this does. PS basically stands for processes, and when you hit Docker processes, then all the container processes which are currently running in your Docker engine would be listed. However, if you append this command with a yay flag, right, then all the containers which are inactive, even those containers would be listed down. So that is the difference between these two commands, docker ps and docker ps with a flag a. Now let me go to my terminal and show you that. So docker ps first, okay, and right now there are no entries because there are no containers which are currently active. But if you want to find out all the containers irrespective of whether they are active or whether they are not active, then it would list down all the containers in my system, right, or in my host, and that's what it's going to do. Docker ps -a, and as you can see, there's an entire list of Docker containers over here. There's the custom image which I created, and then there are various other images over here which I used to build a container, and I've shown you how they work in my previous sessions. So the contact list, Angular, and then there is a demo app one. These were images which I used for my Docker Swarm and for my Docker Compose videos respectively. So if you want to go and see those videos, then the link will be there in the description below, guys. And I would request you to go through those images to understand other Docker concepts better, okay? Because Docker Compose and Docker Swarm, they are the advanced concepts in Docker, and that's a must know if you want to make it as a Docker professional. The link for those videos are in the description below. So let me just clear the screen and get back to what I was doing. So the next command that we have is the docker stop command. Now the docker stop command is basically used to shut down any container. So if there is any container in your Docker engine which is running, right, in your host, and if you want to stop it, then you can use this command. And do note that this command would not be shut down right away. It might take a few seconds because it would be gracefully shut down, waiting for the other dependencies to shut first. Okay, it's not a forced stop. It's a very gentle stop. That's what this command is. But we have something called as a docker kill command. Okay, and what this docker kill command does is it ungracefully stops your container. As in, if there is any container that is actively running, it would straight away kill it. In spite of it's something similar to force kill, right? So that is the difference between these two commands, docker stop and docker kill. Kill would straight away kill your command. Now before I show a hands-on of this, let me go forward and talk about a few more commands. There is something called as a docker remove, right? Docker rm. This one, what it does is it removes a container. At this point of time, you have to remember that if you want to remove any container from your host, you have to first stop it. And how will you stop it? By the two commands that I explained in the previous two slides. You either force kill it or you kill it gracefully using the docker stop command or the docker kill command. And once you've used those two commands, you can remove them from your repository, okay? And we have another command that is the docker rmi, okay? So the docker rm would remove containers. But if you want to remove images itself from your repository, then you can use the docker rmi command. Okay, guys? So these are the four different commands that we have here, which are regularly used. Now let me open my terminal and show you how they work. First, let me do a docker ps. And since there are no containers which are currently active, what I'm going to do is I'm going to start a service. Okay, I'm going to containerize a particular service, and then I will show you how to stop it or kill it or remove it. Okay, there is one particular image demo app one, okay, which I used to deliver my previous session. There was the Docker Compose session, right? Over there I used that particular image and I created an Angular application. So I'm going to first start that service, and the command for that is docker run -rm. I'm going to say port number is 4200:4200 because it's an Angular application. Let's give it a name. It's --name, right? So let's give it a name my Angular application, or let's give it a name, my demo application. Okay, and demo app 1 is the name of that image. So when you hit enter, first the image would come up, right? The image would be spun and the container would come up. Let's just wait for the container to become active. So let me first open a new tab of this terminal. Okay, and here let me run the command docker ps, and you can see that 42 seconds ago this app was created, right? The demo app 1. Here it says the webpack is compiled successfully. So if I go to my Firefox, the servers would be active, the Angular application would be active. Okay, but if I want to temporarily stop this container, or if I want to kill this, then I can use those commands docker stop, or I can use docker kill. Okay, so let's use those commands and see how they work. I'm going to say docker stop followed by the container ID, correct? Hit enter. So the docker servers are stopped. Now if I do a docker ps command, this container would not be active. Okay, and over here also you can see that which was temporarily compiled, it has ended, right? Even the service is not hosted anymore. So that's how the docker stop command works. So let me go to this command and restart the same service. And over here, this time instead of using the docker stop command, let me say docker kill. Okay, sorry, I've just used the same container ID, right? So I need to do a docker ps first. Okay, and yeah, now this is the container ID which I have to kill. So I'm going to say docker kill, pasting this container ID and hit enter. And that container has also ended. So even the service has exited from here, right? So that's how you kill a container. That's the difference between the stop command and the kill command. Okay, so I'm just going to clear the screen. And after these two commands, there are two commands like docker rm and docker rmi, right? They are used to remove containers and images respectively. So let me go ahead and do that. First, let's run the command docker rm. Okay, and now you have to specify which container you want to kill or remove. So for that purpose, let me first find out which are the different docker containers that are there in my system. So when I do a docker ps-a, there are a number of containers, and from here let me remove this test Angular container. Okay, this is the name of the image and this is the container ID. So I'm going to copy this container ID and go back here. Let me clear it, and here let me run the docker rm with the container ID, and when this is returned, it means that my container has been deleted successfully. And the benefit with this is I have freed up a little more space in my host, right, in my Docker engine. Now guys, similarly we saw how to remove a container. Okay, now let me go here, let me do a docker images. So these are the list of the different images that are there in my repository, and if I want to remove any of these images, then I can do docker rmi. And what we have here is we have a Redis image and we have an Alpine image which I do not need. So let me copy this Redis image and remove this image from my repository. So the command is docker rmi this time, because remove image is what it stands for. And I can specify the image name, or I can even specify the image ID. So image name is good enough. So that's what's happening, right? It says untagged and deleted. Perfect. Now I can clear the screen, and what I wanted to show you, I've showed you already. Now if I run the docker images command again, then Redis would not be visible here. So you can see Alpine, but you can't see Redis, correct? So that's how it works. So let me go back to my slides and go to the next command. We spoke about stop, we spoke about kill, we spoke about docker rm, and we also spoke about docker rmi. Now the next command that is in question is the docker exec command. Okay, and this command is used to access any active container, right? Any container that is actively running. If you want to access the bash of that particular container, then you can use this exec command. Okay, and we use IT flag over here. So you can either use -IT together, or you can use -I space -T. Now what I does is it's basically, it says access your container in interactive mode. So that's the option this flag specifies, and that's why we're able to access the container. Okay, and you have to specify which container you want to access, followed by the word bash. So let me go back to my terminal and show you how that works. So over here, let me clear the screen and do a docker ps and check which containers are actively running. None of them are running right now. So let me start a container over here. Okay, let me do a Docker. In fact, I can start one of the containers I started sometime back. The demo app one, right? The one I spoke about is the Angular application. Let me start this same container. Let's wait for it to come up. Perfect. Now it says Webpack compiled successfully. So now let me go to my browser and hit localhost 4200 because my Angular application is active on port number 4200. Right. So this is that Angular application which I was talking about. So if I go back to my terminal, you can also see that I have specified 4200 as the port which is to be used to access that application on my host. And this is the port number it's running on internally in my container. So I'm mapping my container port to my host port. And because of this, I could access that Angular application on my web browser. Now, getting back to our slides, we were supposed to use the docker exec command to access this container, right? So right now, I cannot access this container over here. So let me access this container in a new terminal. So this is the new terminal. And here, if I do the same docker ps command, the new container is active. So from here, let me copy the container ID and then run the command docker exec with the flag IT, followed by the container ID and then bash. Bingo. So right now I am inside this container. So all this time, this was the user, right? Edureka@ubuntu. This was my host machine and this was my username. Right now, I'm logged in as a root user inside the container with the having the ID, this one, because this is what I specified over here. So now we are not in my local system, we are inside the container. And what can we find inside the container? We would basically find dependencies, libraries, and the actual application code of this particular Angular application, which is hosted over here, right? Which you can see. All the project codes would be present inside this container, correct? So let's verify if that is the case by checking if we are actually there. And by doing an ls, you can see all the different files here. We have a Docker file which was used to build this application, and then we have a package.json file, which is the most important file to build any Angular application or any mean stack application. And then we have protractor.conf.js, which is used to test any Angular applications. And then we have so many others, right? We have an src folder, we have an e2e folder, and then we have node_module. So this is where all your project dependencies are stored, correct? So package.json specifies what are the project dependencies that you want, and this is where it's all stored. So this is my Angular application, right? So if I go one directory back, I am in this src folder now. Okay, let me do an ls. I have app here. Let me go one path back again and do an ls. And here you can see that I have other folders like bin, games, include, lib, local, sbin, share, and src. Now all these are inside my container. I hope this was enough evidence for you. I hope it was. So I'm back here, and yeah, that's how you access your container. If you want to make changes, you can make changes here. Okay, and since we are inside the container, let's just create a new file. So let's just say touch f1. So the touch command is used to create an empty file, right? So now if I do cat f1, of course there is nothing, but let me do a sudo gedit. Okay, so I don't need to give a sudo because I'm already logged in as root user. So I'm just going to do gedit f1. Okay, so it's not letting me access this command, right? Okay guys, anyways, that's how you access the container. Okay, so let me just clear the screen. And if you want to exit the container, exit the bash, then you should use the command exit. So when you hit exit, you're back as the Edureka user on your Ubuntu host system. Interesting, right? So I'm going to clear the screen and go back to my slides and check what's next. And then we have the docker commit command. And what this docker commit command does is that it basically creates a new image of an edited container on the local repository. In simple words, it creates a new image of any container which you have edited, correct? So let's execute this docker commit command and see how that works. Let me go to my terminal here. Let's first run the docker ps command and check this is the container ID. I accessed my Docker container, so I hope some changes would have been there. So let's create a new image of that particular Docker container. Okay, so I'm going to say copy and run the command docker commit and then specify the container ID of your container, and followed by that you have to specify the name of your new image. So I can say vardhan ns / my image, right? My Angular image. So this would basically create an image of this container which is running. And bingo, perfect, it's done. So if I run the command docker images, then there will be a new image with this name and tag. Let's verify that by going to docker images. Let's go up, and as you can see, there is Vardhan slash my Angular image. Perfect. This is what we wanted to verify. Correct. So let me clear the screen and go back here. And yes, the Webpack is compiled successfully. This was the message we got earlier. So anyways, let's not worry about that. That's what a Docker command does. So if I want to stop this container service, then from the new terminal, let me just kill that container service. Correct. So this is the ID. I'm going to copy this, and then I'm going to say Docker container stop, and my container would have stopped. So here, yes, my service has stopped over here. Bingo. So I'm going to clear the screen in both the places. Okay, now let me get back to my slides. So the next command that we're going to talk about is the docker export command. Correct. So the docker export command is basically used to export any Docker image in your system into a tar file. Correct. So this tar file is going to be saved in your local file system, and it's not going to be inside Docker anymore. This is another way of sharing your Docker images, right? So one way was by uploading it to Docker Hub. But in case you don't want to do that, you don't want to upload it to Docker Hub because the image is very heavy. So in that case, this is an alternative which is used in the industry, where we do a Docker export from one machine and we save that image as a tar file. And this tar file is imported inside the destination system, and over there it can be accessed again and the container can be run. So let me show you an example of that by first of all getting to it. Okay, so it says Docker export, right? So this is the syntax for that. Okay, you say Docker export, you use the output flag with 2 hyphens. You can specify the name of the tar file that you want to store it with, and then you have to specify your image name over here. Okay, so the image name over here is my container, so you'll have to specify your image name. So let me go to my virtual machine, and what are the Docker images that I have available? There is Vardhan slash my Angular image. There is my custom Ubuntu. So what I'll do is, let me save this my custom Ubuntu image. Okay, this is my image and the image ID is this, right? So I'm going to copy this, go back to this terminal, and what I'll do here is I'll say Docker export double hyphen, which is the flag. I'm going to say output flag is equal to, I have to specify the name of my tar file, right? So my Docker tar file, I can say that my Docker tar file, and here I have to specify the container name. So Docker images wouldn't do for that, so I'm going to do a Docker ps -a. So I have a custom image here, right? So let me save this particular image. So I'm going to copy the container ID, copy this, and paste it over here, which indicates that I will create a tar file of this particular container, and this tar file would be saved in this repository itself, Edureka@ubuntu. Now, since it's a heavy container, it's going to take a few seconds, and it's done. And we can verify that by doing an ls. The name we gave was my Docker tar file, correct? And then you can see there's a my Docker tar file, which is basically a TGZ file. So if you go back to your documents, you can see that there's a new tar file, my Docker tar file, that was created, and you can verify the same my Docker tar file over here. This is the newly created tar file. So I can go back to my slides here, and let me just clear the screen. Okay, perfect. So going back to my slides, I've shown you how the Docker export command works and what's the benefit. Now in the next slide, we have the Docker import command. Now the Docker import command is basically used to import any tar file. If you have any tar file which has been given to you by your fellow developer, and if you want to create a container out of that one, then you have to import it, right? So how is that possible? So this is the syntax for that. The command is docker import and then the complete path of that demo file, of that tar file. Okay, so for this particular purpose, I have already created one tar file because I wanted to create one which can be imported very soon. So I created a tar file over here, demo tar. So it is present inside my downloads folder, correct? So let me import that file. So I'm going to say docker import, and then I have to specify the complete path. So it's /home /edureka /downloads /demotar. Let's hit enter, and this particular image has been successfully imported. You can verify that by seeing the first few characters of the newly created image. Okay, so let's run the command docker images over here, and you can see that just recently 23 seconds ago a new image was created, right, with the same image ID 23EF, and it is the same image ID over here, right? It starts with the same sequence characters, and right now it has no name. So that is how you easily import Docker images. Okay, you first export it and then you can import it. So let me just clear the screens of both the tabs, and now getting back to my slides, I'm done with my Docker import command, and now comes the advanced Docker commands. Okay, so up till here we saw the Docker commands, which are very basic and which can be executed easily. But here comes the challenging part: Docker Compose and Docker Swarm. Right, these are all advanced concepts in Docker, which solves a lot of business problems, and of course the commands are also little advanced in nature. So first, let's start with Docker Compose. There are two variations to it, and the two syntax can be seen over here: docker-compose build and docker-compose up. So these are the two commands which work very similar to Docker build and Docker run, right? So Docker build is basically used to build a new image from a Docker file, correct? Similarly, a Docker Compose build is used to build your Docker Compose by using your Docker YAML file. Now your YAML file stands for yet another markup language, and now in the YAML file we can specify which all containers we want to be active. Okay, and you have to specify the path of the different Docker files which will be used to create those containers or those services. And that's what Docker Compose does, right? It creates multiple services, and it's basically used to manage all those services and start them at one go. So it would use more than one Docker file. Probably if you go through my previous video on Docker Compose, I have explained it in detail over there. I have used 3 different Docker files, and using those 3 Docker files, I have created 3 services, right? And the 3 different services are the Angular service, the Express and Node service, and the MongoDB service. The MongoDB was used as a database, the Express and Node was used as my backend server, and Angular was used for my front end. Okay, now the link to this video is present in the description below. Okay, but let me just quickly wrap this up by saying that if you want to build that, you use the Docker Compose build, and if you want to start your Docker Compose and start the container service, then you can use the Docker Compose up. This is very similar to the Docker run command. Okay, and that's what your Docker Compose does, right? It creates multiple Docker services and containerizes each of them and gets the different containers to work together. So perfect. Let me go back to my terminal and let me do that for you. So Docker PS, there is nothing. So right now we are in the home/edureka folder, correct? So let me do ls, and there is a folder called MeanStack app. So I'm going to cd into this particular folder, and here if I do an ls, you can see that there's a Docker Compose.yaml file. So let me do a gedit Docker Compose.yaml file. So over here you can see that I have specified the commands to create 3 different services. One is the Angular service, other is the Express service, and finally my database service. Okay, I have explained all these things in my previous video. I repeat, the link for that video would be in the description below. Okay, so let me quickly execute this YAML file. Okay, so if I do a Docker Compose build, then this command would look for this Docker Compose file inside this directory. Okay, and then it would once this image is built, I can straight away execute that command by using the Docker Compose up. Okay, so I'm just gonna replace build with up. This way my Docker Compose would also be up and running. Earlier I showed you an Angular application, and this time it's going to be an entire MeanStack application, which is going to involve everything: MongoDB, Express, Angular, and Node.js. So my Express is up and running, my Angular is up and running, my MongoDB is active on port number 27017, my Express would be active on port number 3000, and Angular, as usual, would be active on port number 4200. So let's verify the same by going over here. Okay, it also says Webpack compiled successfully. So this time if I refresh this, there's a different application that would come up. Correct. So this is my main stack application. On port number 4200 is the front end. On port number 3000, this is my server end, which simply says foobar. And then on port number 017, there is my MongoDB. Right. So these are the three different services which are active on my various port numbers. So going back to my terminal, I can do a docker ps to verify that there are three different services of mine which are running. Now, if I want to stop each of these services, I can simply do a control C from here, and hopefully it stops. Yes, all three services have stopped. Let me execute the same command, and this time, yeah, they're all gone, right? So the docker ps command shows no containers active. Bingo. So I'm going to clear the screen out. Okay, and go back to my slides and go to the next command. And the next advanced command that we have is the Docker Swarm command. Docker Compose, I told you, was to basically have a multi-container application, right? And Docker Swarm is, however, used to manage multiple Docker engines on various hosts, right? So usually you might be aware that your Docker engine is hosted on one particular host and you're executing your Docker commands over there, right? That's what we were doing all this time. Even Docker Compose did that. On the same host, three different services were started. But with Docker Swarm, the benefit is that we can start those services in multiple machines. So you will have a master machine, which is nothing but the Docker manager, as visible from here. And then you will have different slaves, or which are called as worker in Docker terms. So you have a manager and worker. And whatever service you start at the manager will be executed across all the machines which are there in that Docker Swarm cluster. Okay. So it says, right, it creates a network of Docker engines or hosts to execute the containers in parallel. And the biggest benefit of Docker Swarm is scaling up and ensuring high availability. Okay, so some of the commands which are associated with Docker Swarm are these. If you want to first of all start off creating a Docker Swarm, then you use this command, Docker Swarm init, and you say advertise. Okay, and then you have 192.168.1.100. It's supposed to be two hyphens over here. Okay, yeah, so this is how the syntax is supposed to be. Docker Swarm init hyphen advertise hyphen adder, and then you have to specify the IP address of your manager machine. So if I start the swarm from this particular host of mine, then this would assume the role of my manager. Okay, and in this syntax, remember, I have to specify my own IP address so that the other workers who will be joining my network would subscribe to my IP address over here. So let's quickly go and execute this first command, and let me show that to you. Okay, so let me open up the terminal, and the command is Docker Swarm init, which stands for initialize, with the flags advertise, adder, and then the IP address. So the IP address of my VM is 192.168.1.100. Okay, so when I hit enter, see what happens. It says swarm is initialized, and this is the current mode. This particular node is now a manager. Okay, and if you want other machines to join this particular manager as workers, then they have to use this token. So you have to just copy this, go to the other machines and execute it. Supposing this is another machine of mine. Okay, I'm giving you an example. So over here, you would have to paste that token. Okay, so this is called the token. You just hit enter and then you will join as a worker. Okay, so that's how the Docker Swarm command works. Now I cannot go into too much details with respect to how Docker Swarm works. Okay, because there again it will take a lot of time, and if you want to actually learn Docker Swarm, you can go and watch the other video which I delivered a couple of months back. Right, that video is called Docker Swarm for high availability. Okay, and that is a detailed video, and you will enjoy that video because with that video I've shown how Docker Swarm can be used, and you will see the power of Docker in that particular video. So I would request you to go there, and the link for it is again below in the description. Okay, so I would request you to go there if you want to learn more about Docker Swarm. But getting back to our slides, we have other commands here, right? So the Docker Swarm join is what I already explained to you. So followed by this, you will have a token. So if you give that, you can join a particular Swarm cluster as a worker. Okay, so if you want to regenerate that particular token which is needed to join that particular cluster. Then at the manager's end, you can execute this command, docker swarm join token. So it would generate that token and give it to you. And similarly, if you want to leave the docker swarm cluster, then you can execute this command, docker swarm leave. Okay, so if you execute this command straight away at the worker's end or the nodes, then it would simply leave. Okay, but at the manager's end, it would not leave just like that. You would have to append the flag force. So let me show you that. Let me just execute the command, docker swarm leave. If it was a worker, it would leave right away. But since it's a manager, like I said, it says use the force option. So let's use that. Okay, docker swarm leave with double flag force. And it says the node has left the swarm. Perfect, right? So this is all about docker swarm, guys. Okay, so let me go back to my slides and cover the one last command that is there for today. And that command is the docker service command. So this command is used to control any existing docker service, be it any container or be it a docker compose or docker swarm or anything else, right? So docker service is a very underutilized command, I would say, because if you want to control your different nodes when you're in a docker swarm, then you use the docker service. You use the docker service command to list down the different nodes that are there in your cluster. You use the docker service ps command to find out what containers are being executed in a particular node. And then if you want to scale the number of containers, supposing you have a cluster of 5 machines and then you have 5 containers running on each of those machines. If you want to scale those containers to 25, that means you will be executing 5 containers on each machine, right? So for that, you have to use the command docker service scale. If you want to stop any container on any particular node, then you use the command docker service stop. And then if you want to find out the different logs, then you use the command docker service logs, docker service rm, and so on, right? So the docker service command is, let me repeat, it's used in sync with your docker swarm and docker compose primarily. So that's why these form the advanced docker commands. So let me go to my terminal and quickly show you a glimpse of this. So it's docker service. If we do an ls, you will not have any options listed because it says this is not a swarm manager currently. But if I start my docker swarm and then if I run the same command, docker service ls, then you can see that the output is different, right? I have a few attributes here, id, name, mode, which is basically details about the different worker nodes in my cluster. But since no worker has joined my cluster, there are no entries here. So that's how it is. So let me just end that. So that is the docker service ls. If you want to find out the logs, then you can do that too. Docker service logs. So if you use the docker service log, you have to specify which service you want to check the logs of and what is the task, right? So which task and which service. So it's that simple, guys. So that's how docker service is used. Okay, guys. And again, if you want to stop any service, if you want to remove any service, you can use these commands, docker service stop or docker service remove.
What is Docker Compose? So the definition says Docker Compose is used to run multi-container applications. Multi-containers, right? So, well, the thing is, you use one container usually to host one service, right? Now, that's what we discuss all this time. Now, let's take a case of a massive, big application, all right? And it has multiple services. And in fact, there are multiple web servers which need to be placed separately on a particular server or on a particular VM, because it might cause an overhead, because maybe 2-3 servers cannot be hosted on the same machine. So at that time, what we usually do is we have a new VM and we host it there, right? Or we have a new server altogether. For example, if you want to monitor your application, then you might probably use Nagios. So Nagios, there will be times that you'll have to host it separately in a different machine. And similarly, you will have various servers like Jenkins and many web services. So at that time, you instead of having a different machine or having a different VM, we can simply have a different container. Okay, you can have these multiple services hosted in these multiple containers. So each container will be hosting one service, and then these containers would be run such that they can interact with one another. Okay, exactly how it works in the in case of servers or VMs. So it's exactly the same way, but it's just that it's going to be one command, a very simple command, which is going to get your Docker Compose up, and this Docker Compose up, it's like a grid, right? So it will run all the three containers at the same time. It will host all these, and it will get them to interact with one another. So that's the benefit with the Docker Compose, and that's the whole point of today's session, right? I want to show you how awesome Docker Compose is this way. So yeah, moving on to what I'm actually going to show you in today's session. I'm going to show you how to set up a mean stack application, like I mentioned earlier. So first of all, the mean in mean stack has 4 different things. So the M stands for MongoDB, which is the database, and E stands for Express, A stands for Angular, and N stands for Node.js. Now together, this is a full stack application. Okay. Now since we are using a combination of these 4 tools, we acronym it to a mean stack application. Okay, that's what it's acronymed to. So this full stack application is again a web service, so such that you have a front end client, and you have a back end server, and then you have a database. So whenever you have your clients or your customers interacting with your web server, they would be interacting with the client. Okay, the client of your front end client. So the data that they pass over there, right? Whatever actions they perform or whatever requests they make, that would go to the client. That would go to the server, and the server would do the necessary function. So it would have to sometimes need to fetch the data from the database. So in that case, it would fetch the data and provide a response, or sometimes it might have to do various other functions. So the actual functionality would be done by the server, and the displaying part would be done by the client, and the actual data would be stored inside the database. So that's how the full stack application works. It's a combination of these 3 services: a front-end client, a back-end server, and a database. And that's what I'm going to use, right? So if I want to have these 3 services, then I would have to create 3 different containers, right? So I have container number 1, which I can use for my MongoDB, which would be my database. I have container number 2, which I can use for my backend server. I'm going to use Express and Node.js in combination. And the third service that I'm going to use is my front-end client. Okay, so I'm going to use Angular for that purpose. Now, I'll be hosting these 3 services inside these 3 containers, and each of these 3 containers would be built from their respective Docker files. Okay, as you can see, there's Dockerfile 1, Dockerfile 2, and Dockerfile 3. Now, in the same way that I explained in the previous slide, we have a Docker file which would build the image first, and then that would be spun into a container. The same process follows here also. Okay, it's just that for each of these containers separately, we would be using a Docker file, and each of these Docker files would be called one after the other with the help of our Docker Compose file. So Compose is what is the key term that you need to note here, and the Compose file it's a YAML file basically. Okay, yet another markup language. And in the YAML file, you specify the location where your Docker file is present, and then you also specify the port numbers that container needs to use to interact with the other container. Okay, and at times if you have a database in place, you might also have to specify the link of the database. The server and the database need to be connected. So for that purpose, you do that. So that's how the Docker Compose works, and that's the overview that I've given you. Right, 3 containers, built from 3 Docker files, which would be called by the Docker Compose file, which is a YAML file. And there you go. You will have a web application hosted that's up and running. All right. Mean is nothing but a full stack application that involves the combination of these 4 technologies: Angular, Node.js and Express, and MongoDB. Okay. So the 3 services that my mean stack application involves are primarily the front-end client, the backend web server, and the database. So this is the same thing that I explained a couple of minutes earlier, but since you have a pictorial representation, I hope this you can relate to this better, right? And my front-end client is going to be my Angular, and the backend server would be Node.js and Express, and database is going to be MongoDB. Okay, so you guys shouldn't have any problems now, and these 3 services would be hosted separately in the 3 different containers. Okay, and that would be built from my Docker Compose file. So that's what I'm going to do now. Now let's see how to containerize and deploy a mean app by using Docker Compose. Great. So first of all, let me open my virtual machine. So first of all, I have my terminal here and I want to show you my project. Okay, so this is my MeanStack app is the folder where I have my project present. So as you can see, there is one Angular app folder which is basically containing all the codes of my for my client for the front end. This is the back end server where all my codes are present again, and this is the compose file which I've written, and this Docker compose file is what is going to do all the work for us. Okay, it's a really simple work. And one thing you might notice here is that I don't have a Docker file for my MongoDB, right? So I mentioned earlier that I would be using a Docker file for creating the third container, but in this case, I don't really need to do that. Okay, so a Docker file is a little complicated procedure, but for my database, I don't need to build something from scratch, and I don't need something customized. So I can just simply use an existing MongoDB image which is there on the Docker Hub. I can use that and link that with my backend server. So that's why I don't have that. But instead, I've directly called that MongoDB image over here. Okay, so this is the YAML file, and if you guys are watching this video at later point of time, you can also relate and you can understand what I've specified here, because I've mentioned in comments, I've mentioned what each and every line does. Okay, so it'd be helpful for you people. Do come back and have a look at this later if you're having any problem, but in the meanwhile, let me explain each line here. So in the first line, we are saying the version to be used is 3.0. Okay, so you have to install a version of Docker Compose separately, and Docker Engine will anyways be there, right? And you have to download a version of Docker Compose which matches your Docker Engine version. Okay, because certain versions of Compose is not compatible with certain versions of Engine, so you have to just look up the right version. And I'm using version 3.0 of Compose, and I have version 1.16 of my Docker Engine. Okay, so just make note of that. And yeah, you got to specify the version. That's going to be your first line, and after that you simply specify the different services that you want to run. Okay, the keyword for that is services, and you give a colon here and you specify the 3 different container names. Okay, and each of these containers will contain the actual services. So in case of my Angular, this is going to be the name of my container number 1, right? And here I'm saying build this container from the Docker image that is present in this particular folder, this particular path. Okay, similarly, Express is the name of the second container, and I'm asking it to build this container from the Docker file that's present in this particular path, Express server. In case of my MongoDB image, I'm creating the container with the name of database, and I'm not giving a Docker file here. I'm just saying pull the image from the Docker Hub. Okay, so it would use a image that is the Mongo image with the latest tag, and it would use that. Okay, so let me just quickly go to my folder and show you where the Docker files are present. So this is the Angular app. Now since my compose file is here, from my compose file, this is the path where my Docker file will be present, right? So this is that Docker file. So let me just open this Docker file and keep it here. And similarly, if I could just go back, there's Express server folder, right? So this is the code where my codes for server side is present, and my Docker file for that is present over here. So now coming back to my YAML file, after specifying the path of each of these Docker files, I'm specifying the port numbers on which they should be running inside my where the port mapping, how the port mapping happens. So whatever application you're hosting inside the Docker container, right, that would be hosted in one particular port number of your Docker. So you have to map it to one of your port numbers of your local host machine. If you want to see the UI, if you want to interact with your web browser, then you have to map it with a particular port number. Okay, so I've said this is going to be the local machine port number on which it would be visible, and this is the port number on Docker where the application is going to be running. Okay. Similarly for Express, it's 3000:3000, and for MongoDB, it's 27017:27017. So each of these port numbers are default for these applications. Okay, so I haven't done much of a deal over here. Let me just, since I've explained the YAML file in a decent fashion, okay, there's one more thing left. There is links. Okay, now this line, if you see, I'm linking my server side to my database. Okay, now since I have a database where it needs to fetch data from on a regular basis, we have to give the keyword links with a colon and just specify the container name. So that's why my third container is going to be the MongoDB container. It's going to have the container name of database, and I'm linking that over here. All right, so it's pretty simple. And now that I've explained each of these compose files, it's time I explain the Docker files. So this is the first Docker file which I created for my front end, and it's very similar to the Docker file that I used for my previous session. If you people remember, if any of you are were there in that session, you might realize that first of all, I'm using a from command to pull the node image, okay, with the version 6. I'm doing this from the Docker Hub, and inside this image, I'm creating a new directory, okay. Make directory is the Linux command that you use. I'm doing that with the p flag. I'm creating this path, okay. So I'm using the p flag so that I'm creating the entire path, the parent path also, /user/src, okay. So I'm creating this folder inside my Docker image, and I'm changing the working directory to the newly created folder or newly created path, okay, project path. And what we need to do is we have to copy all your dependencies. You have to copy all your project codes and all these things, right? So that's what I mentioned when I was delivering the slides. All your project codes, all your applications codes, the dependencies, libraries will all be packaged together. So that's what we are doing here. I'm first saying copy the package.json file to the project path, okay. Now if you can let me just show you the package.json file. So this is the package.json file. First of all, I'm copying this one inside my Docker image. Now that's because this file is the most important file, which has details about which version of dependencies are needed for your code. So for my Angular code, which is present over here, by default my Angular code would be present in src/app path. So whatever I would need, the versions of that dependencies would have to be mentioned in the package.json file, okay. So I'm copying this file inside my image first, and after I copy it, I'm running a npm cache clean command, okay. So npm stands for node package manager. It manages your application here, and cache clean is I'm just removing the cache here. It's not a very important command, but the important command is npm install. So when you give the npm install command, what this does is it would first of all look for the package.json file, okay. The npm, which is node package manager, would look for the package.json file, and whatever versions of dependencies are mentioned inside it, those would be downloaded, okay, and they would be present inside a new folder called nodes_modules, okay. So that would be created, and it would have to be moved to this particular path inside your it should be moved inside your Docker image, right? So that command is what I'm doing next. So after downloading the node_modules, all the actual dependencies, that along with the actual project codes, so those also I'm copying by giving the dot command here, okay. So when I say dot, whatever is present in the host machine, everything in that particular path would be copied to my Docker container path of this, and then I'm simply doing an expose 4200, indicating the fact that I want this container to have an open port at this 4200, okay. And the same 4200 is what I'm using over here. Since 4200 is where Angular is hosted, I'm mapping that to my host machine's port of 4200, okay. This I do in the YAML file. But anyways, when I specify the port number where it's running, I can simply do an npm start command, okay. And when you run an npm start, it's you're starting a node package manager, which would straight away look for your codes. So your codes would be present inside the src folder, okay. You have another folder called app, so it would look for everything here, and whatever is present here, it would start executing them. And yeah, that's how, of course, the dependencies would be present inside the same image, so your application would be successfully hosted in that way, okay. And similarly, going to the second Docker file, this is for creating the server side, okay. And if you can notice, there's not much of a difference. So almost every step is the same, except for me exposing the port number here. So I'm saying my server would be hosted at port number 3000 of my Docker container, okay. And this again I'm mapping in the YAML file to the host machine port number 3000, okay. So that's the only difference. This is the only difference in both the Docker files. And now that I've also mentioned where these files are present inside my YAML file, I can simply execute this Docker compose file to have my to have my servers hosted. So the command for that is let me check where am I right now. Okay, home/Edureka. I'm going to cd to the folder, and here we have the same set of files and folders, right? So this is the file that we want to execute, and the command to execute the Docker Compose file is docker-compose space up. Okay, there's a very simple command, and your Docker file would basically be executed. As you can see, it's starting the Angular 1 container, database 1 container, and the server-side container. Great. So guys, this is going to take a minute. Okay, the ng live the development server is listening on localhost 4200. Great. This is an indication of my client side. Okay, so it says webpack compiled successfully. That's great. My web service is hosted. Now what I can do is I can open my web browser here and go to those particular port numbers and see if my service is up and running. So if you remember, my client is hosted at port number 4200, right? So let's hit enter. I can either give localhost or I can give 0.0.0.0. Either of that will do. And as you can see, my Angular client is up and ready, and my app is simply about having a form page. Okay, so I can add details here, my first name, last name, phone number details, and I can just click on add to get the details, and that details would go to my database. So that it's a very simple application which we've created. And similarly, you can verify if the server is running by going to the port number where it was hosted. And if you can recall, this was the port number it was hosted on. Foobar, great. So this was the authentication that I needed. And localhost 27017 is where MongoDB is hosted. So for MongoDB container, you will get a message like this. It looks like you are trying to access MongoDB over HTTP on the native driver port. And if you get this message, it means your container is up and running. Very good. All right. So we can just test our web application by giving the name details here. Okay. So the first name, let me say, I'm going to give my own name. I'm going to say Vardhan. All right. Last name, I'll give NS. Phone number, I can just give a random number here. Okay. And if I say add, this data would go into my database. That's my MongoDB container. All right. Great. So it shows that already I have these details present. Okay. So I have this one record, and now this record has been added. Okay, now let's verify that by making an API call. Now I've only explained the client aspect. The server side aspect is something that I didn't explain, right? You guys should know by now that the client will take the request from the server would take the request from the client and query on that, right? If there's a if there's a request to access the database, then it would fetch it from the database and respond to the client. So let's do that. This of course is the UI that I created, which shows my database. But anyways, to verify if the same thing has gone into my database, actually we can do that by going to the server here and going to this particular URL. Okay, there's a /API/contacts, right? So this is basically a API call that my server is making, and at this URL at /API/contacts, it can view what data is present inside my container. So it says that the first record that is present is this one. It has an ID of this, which was generated automatically, and of course the first name, last name, and the phone number was what was given. Okay, and this was the record that I created recently, and as you can see, even this is present. So if you want if you want to play around a little bit, you can do that, and let me just do that by deleting one of these records. Okay, I'm going to delete the first record, and now if I just go back and refresh this page, you can see that the first record is gone. Okay, so we have just Vardhan, we have NS, and the phone number. Now that's because we deleted that from the database itself, and I made a call from my server, from my client, sorry. So I hit a delete button from my client. That request went to my server first, and the server would indirectly go to the database and delete that particular record. And since I did a /API/contacts, since I refreshed this would return whatever is present inside the database. So it's that's what is visible here, right? So currently this is the only record that is present in my container, in my MongoDB database, right? So that's what's visible here. And similarly, these are just two functionalities I showed you. There are a couple of more functionalities and that we can do with this image. You can retrieve one particular record if you want to. You can do all these things, okay? And this is just my application. You can come up with your own customizations. You can build your application in your own way, correct? And you can do all these, and of course I cannot go into depth. I can't teach you in detail what the different parts of this application is, but instead I can point you to one of the videos, which is a Yadreka video, which has a complete tutorial on how to create a mean stack application. Okay, so let me just give you the link of that video in some time, but before that I just want to quickly show you that this was the Express server page, and again we had the package.json file here, the app.js, which is basically the entry point into my server. And in this app.js file we would have details about what APIs are there, what functions function calls can be made, and whenever that particular function call is made by the client, then it would be routed to this route.js file inside the routes folder. Okay, so the definition of those functionalities would be present here. So whatever actions need to be performed when clicked on that, the rules will be specified here. So that's how the server communicates with the database and forth, right? So that's how it works. And yeah, that's the explanation of both the mean stack, the complete explanation, right? The Angular app and the Express server. What is Docker Swarm? So a Docker Swarm is a technique to create and maintain a cluster of Docker engines. Okay, now what I mean when I say a cluster of Docker engines is that there will be many Docker engines connected to each other, forming a network. Okay, now this network of Docker engines is what is called as a Docker Swarm cluster. And as you can see from the image over here, this is the architecture of Docker Swarm cluster. Okay, and there will always be one Docker manager. In fact, it is the Docker manager which basically initializes the whole swarm. And with the manager, they will have many other nodes on which the service will be executing. So there will be times when the service will also be executing at the manager's end. But basically, the manager's primary role is to make sure that the services or the applications are running perfectly on the Docker nodes. Okay. Now, whatever applications or services that are specified or requested, they will be divided and they would be executed on the different Docker nodes. Now, this act is called as load balancing, right? The load is balanced between all the other nodes. So that's what happens with the Docker Swarm, and that's the role of a Docker managers. Now, let's go and see what are the features of Docker Swarm and why it's really important and why it's the go-to standard in the industry. That's because with Docker Swarm, there is high availability of these services. Okay, it's so much so that they can be 100% high availability all the time, right? That's what high availability means, right? So how is that possible? That's possible because at any point of time, even if one node goes down, then the services which are running inside that node, they can start. The manager will make sure that that service is started on other nodes, right? So the service is not hampered. Even though the node may be down, the load is balanced between the other nodes which are active in the swarm. So that's what a Docker manager does, and that's why the Docker manager is heart of the Docker Swarm cluster. Okay, that's one feature. The other feature is auto load balancing. Now again, the auto load balancing is something that is related to high availability itself, where at any point of time, if there is any downtime, at those times the manager will make sure that those services are not stopped and they are continued and executed on other nodes, right? So that the manager would do. But along with that, load balancing also comes into the picture when you want to scale up your services. Supposing you have say 3 applications and you have 3 nodes for that, right? So including the manager, you will have 4 nodes because manager is also technically a node. Okay, so you have a manager node and then you have 3 different nodes. So in this case, the 3 services which you deploy, they will be running on 3 different nodes. And if you want to scale them at a later point of time, let's say you want to scale them up to 10 services, then at that time, the concept of auto load balancing would still come into the picture, wherein the 10 services, they would be divided between the nodes. All right. So it would be such that you will have probably 3 services running on one node, 3 more services running on the other node, and the remaining 3 services on the other node, and the one service that is left out, that would sometimes be run on the manager, or it would be load balanced on some other node. Okay, and the best part with Docker is you don't need to do any load balancing. It's all done on its own, right? So there's an internal DNS server with which the Docker manager manages, and the DNS server makes sure that it allocates the DNS server makes sure that all the nodes are connected in the cluster, and whenever any load is coming, it would balance the traffic between the different nodes. Okay, so that's one big advantage with auto load balancing. And another feature is that of decentralized access. So when we say decentralized access, it means that we can access these managers or these nodes from anywhere. So if you have these managers or these nodes hosted on any server, then you can simply SSH into that particular server, and you can get access to that particular manager or node. So if you access the manager, then you can control what services are being deployed to which nodes. Okay, but if you log in or if you SSH into the server which is a node, then you can control or see which service is running inside that node itself. Okay, but however, you can't control the other nodes if you're inside a node. Only the manager node can do that for you. But anyways, all that we need is to log into or SSH into a Docker manager and control which services are running, right? So that's all we need. That can happen this way. And of course, it's very easy to scale up deployments. So I also spoke about that earlier, where you can, if you want, let's say you already have 10 services, and if you want to suddenly scale it up to 50 or say 100 services, then what you can do is you can just buy a few more servers and deploy those 100 services into those servers, right? So it's a very simple functionality where you can do it with just one single command. One single command is all it takes to scale up your number of services or applications to the desired amount, right? And you will have multiple services running inside that same Docker node. So each node can have will probably have 10 or 15 services running, and it basically depends on the number of nodes that you have. But ideally, you shouldn't do that. You cannot have too many services running inside the same node, because that causes performance issues, right? So all those things you can do. And finally is this concept of rolling updates. And rolling updates is by far the most catchy feature, because when we say rolling updates, what we mean is these applications or services which are running, right, they will have to be updated at one point of time or the other. Down the line, you will have to update it. So at that time, what will you do? You cannot update manually in every single machine, right? If you don't have Docker, if you have hosted your web servers on either virtual machines or on actual web servers, then what happens? At that time, you would have to go to each and every system and then probably update it everywhere, right? Or you might have to use other configuration management tools. But with the help of Docker, you don't have all those problems. You can simply specify you can use the rolling updates functionality for that, and you can specify a delay. So in the delay, it would update one service or each service which is hosted or deployed inside every node. It will update each of those services one after the other with a delay of the specified amount of time, right? So even when one service is getting updated, the other service is not down, and because of that, there is high availability. Since the other service is still up and running, there is no downtime caused, right? So you can be sure of that. In spite of and rolling updates are very simple also. So it's just one command and you're all done. These are the benefits of Docker Swarm, and these are reasons why you should implement Docker Swarm in your organization if you have a massive web application, web service which is deployed over multiple servers. So that's the big benefit with the Docker Swarm, right? So moving on to the next slide. Okay, now it's time for the demo. Okay, now let's see how to achieve high availability with Docker Swarm. But before I get started with the hands-on part where I would be showing you on my virtual machines, I want to first go through what I want to show you with respect to high availability, okay, and how to achieve it with Docker Swarm. Okay, so first of all, in terms of high availability, the ideal definition is that you have the application or the services deployed in each of the web servers. Okay, now look at this architecture where I have 2 nodes and I have one manager. Okay, and I have Docker Engine running on each of these each of these nodes, and each of these are all highly available. Okay, so at this point of time, I don't have any problem, okay, with respect to any services, and my application is deployed in each of these servers. Okay, each of these servers or each of these nodes. So at this point of time, if I try to access my browser, and if I try to access this port number in my browser, I can see my application running. Okay, now this is the application which I will be showing you my demonstration on, and this is also the application which I executed a couple of sessions back. Okay, the link of this application, the demo of this, I will share it at the end of the session. Okay, but don't worry about that, because this session is all about Docker Swarm. So getting back, what I was saying is, since these are hosted in each of these servers, I can access the application that I've deployed on each of these machines. But look at this scenario where my service is only hosted on one particular node this time. Okay, I have the other services connected to my cluster. Okay, this is my Swarm cluster where it's all connected, but the application is not hosted on these two nodes. So at this time, can you guess what happens? Does anybody think that the application will not be accessible on these machines? Can anybody tell me that? If you people think like that, can you just well, if you think like that, then you people are wrong, because since it's connected in a cluster, these Docker, whatever is hosted on one particular node, they can also be accessible on other nodes. So even in spite of the fact that these servers do not have the application running, the web port on which this application is hosted, right, this port number will be internally exposed to all the nodes inside this cluster. And since the port number on which it's running over here, that is 4200, since that is exposed to the cluster, then in all the other nodes in that cluster on the same port number 4200, the application would be accessible, right? Same thing with even this particular node. So on 4200, you can access this Angular application. This is the second scenario of high availability. But this is just a scenario where you don't have your application. This is the third scenario where high availability is actually being implemented. Okay, now you have a scenario where you have your 3 nodes and 2 of your nodes or 1 of your nodes goes down. Okay, so this time you don't have your application itself. Forget about the fact that Docker is not the application is not hosted. Forget about that fact. Think about this scenario where your node is not accessible. It's down for some reason, for some natural calamity. At that point of time, do you think you can't access it? You can. Well, that's because the nodes would be connected inside the Docker cluster, the Swarm cluster, and the port number would be exposed. So because of this reason, you would still be able to access, you would still be able to view the Angular application on these servers, right? Now that's the benefit of having a Docker Swarm cluster. All right, so this is how the high availability factor is achieved with the help of Docker Swarm, and this is what I'm going to show you in my hands-on part. But before I go to that part, let me just quickly run through these Docker Swarm commands. Okay, so these commands is what I will be using extensively in my demo. And these are also the most common Swarm commands that you need to use when you're starting with your Docker Swarm cluster. Okay, so first of all, to initialize the Swarm, you use this command. You say Docker Swarm, and in it, you use double flag and say advertise adder. Okay, followed by that, you specify the IP address of the manager machine or that same machine where you're starting this service. Okay, so the when you do this, whatever IP address is specified here, that particular machine would be acting as a manager. Okay, it is also ideally the same machine on which this command is running, right? The IP address of what you specify here, it should be the same machine. So that's the thing, and whenever you issue this command, this Swarm would be initiated along with the manager being this particular machine which has this IP address. Okay, that's what happens when you do when you initialize the Swarm. And of course, when you initialize the Swarm, you will get a token. It's more like the entry key using which your other workers can join your Docker cluster. Okay, but getting back to our Docker Swarm, once you've initialized your Swarm, you can list the different services that are running inside that Swarm. Okay, you can list the different nodes that are running. you can check which all nodes are connected to your Swarm cluster. You can check what all tasks of services are running. You can check, you can create a new service as in a new container, and then you can also remove that new container, and you can scale them up using these commands. Okay, so use the docker service ls to list down the services that are running. Then if you want to drill down on one particular service and check in which node one particular service is running, then you can use the docker service ps command. Okay, so it lists down that process when you issue it with the name of the service that you want to check for. And then if you want to create a new service, then you use this command of docker service create. Then you specify the name of the service, in fact, and you got to specify the image which you want to use to build that particular container and service. And finally, to remove a service, you use this docker service rm followed by the name of that particular service. And finally, if you want to scale your services, then you can use this command, docker service scale, and then you can just specify the name of the service, and you can specify the number that you want to scale it up to. Okay, so in this case, if I had the service which had 2 replicas, then by simply specifying is equal to 5, I would have scaled it up to 5 different replicas, right? So these are the Swarm commands which are applicable from the manager end. And now going back to the node end, if you want to list down all the nodes that are there in your Swarm, then you can use the docker node list. Okay, do note that here it was all about the different services. Okay, and these commands cannot be run on the docker nodes. Okay, they can only be run on the docker managers. Okay, so here you have the docker node ls, which lists down all the managers and the nodes. And then if you do a docker node ps followed by the service which you want to in fact, if you do a docker node ps, it basically lists down all the containers or services that are running inside that machine. Okay, now this command, again, it can be run on even nodes. Okay, this cannot be run on all the nodes. So the node ls, it can be only run on the manager. And finally, if you want to remove a particular node from your service, from your cluster, then you can run the command docker node rm followed by the id of that particular node. Okay, but at times you might not be able to do that. That's because the node might still be connected to the cluster. So in that case, what you have to do is you have to use the docker swarm leave command. When you use this command, you can get, if you run these commands from the nodes, then the nodes would leave the cluster, and then you can just end your cluster, right? And finally, if you can just run the docker swarm leave from the manager end, then you can end the whole cluster itself. So even the manager would leave, and manager would ideally be the last instance to leave, right? So when there are nodes there, you cannot have the manager leave with the nodes being present. So that's one thing. And at times you would be given a error saying that you cannot leave the cluster because you're a manager. So at that time you can use the flag force flag. Okay, so at this time you're as a manager, you can leave the cluster and your cluster session ends there, right? So these are the top commands which are in question. So yeah, I think it's a time for me to go to my session. Okay, it's time to go to my hands-on session where I'll open up my virtual machines. So for the demo purpose, I have 3 different VMs. Okay, and inside these VMs I have 3 different Docker engines, and I will be basically using 2 of the Docker engines as my node, and I would be using one of them as my manager. Okay, so this is my manager 1, as you can see over here, and this is the password. Okay, so this is the manager 1, which I'm going to start the service, the whole swarm and the services from here. Okay, and if I go here, this is my worker 1, as you can see over here. Alright, and this is worker 2. Now in these 2 nodes, I would be executing my applications or services. Okay, so first of all, if you want to create the swarm service, then you have to run the command docker swarm init advertise adder followed by the IP address. So the IP address of this manager machine is 192.168 dot 168.1.100. Okay, so great. So my swarm is initialized, and as it says, if you want to add a worker to this swarm, then you have to run this token. Okay, now this is the token. Let me copy this token and run this at the node's end. Okay, so I'm going to go to worker 1. I'm going to paste this token, and when I hit enter, it says this node has joined the swarm as a worker. Now let me verify that. If I go back here and if I issue the command docker node list, then it says that I have one manager, which is myself. Myself is being indicated by this asterisk, okay, referring to this own system, which is also the leader. So it says manager status leader, correct? The status is ready and availability, it's active. And recently I added the worker node, so it says even this is available. Now let me go to the third VM and enter the token here, and it says even this node has joined as a worker. Now if I go back to the manager and run the same node list command, you can see that the worker 2 has also come in now. Okay, now that's because I have I issued the join command at my node end. So I'm gonna clear the screen, and now we can start creating our services. So first of all, if you want to create a service, the command is docker service create followed by the name of the name flag. Okay, so you specify the name of the service that you want to give. Let's say I want to say Angular application. I will say this, and followed by this we should specify the name of the image. So the image name is demo app 1. Okay, and along with this I also want to specify the port number on which I want to do the binding, because the Angular application which is being hosted in one particular port number inside my container, that has to be mapped to my browser port number, right? If I want to access it on my web browser, that is this Firefox. So for that reason I'll use the -p flag, and I'm going to say 4200 of the browser port should be mapped to 4200 of my container port. So this is the command. Okay, now this command simply creates one instance of this service Angular app, which will be built from this image demo app 1. Okay, and it would expose the port number 4200 from the container to the port number 4200 of my browser. So let me hit an enter, and let's see what happens. We got to give it a few seconds because it's a big application, right? Yeah. So now let's do a docker service ls. Okay, you can see that one Angular application is created. Now this is just a warning. Okay, you can ignore this because this is the confirmation that your service has been started. Okay, you can ignore such warnings. If it's this what you need to look for. Now if you get this image ID, then it means that your service has been created. Okay, this is the service ID basically. So as you can see here, right now the mode is not replicated. There is just one single instance, and the same thing you can see over here. It says replicas is 1, the same name which I specified, the image that it used, and the port number where it's active right now. Okay, now let me do a docker ps command from the manager and check if this application is running inside this node. So yes, it says that this application is running over here. Now parallelly, let me go to my worker 1. Okay, this is also connected to the same cluster, so I'm going to do a docker ps over here. You can see that I have got no output, so this means that there is no container that has started inside this node. Okay, this is the worker 1. Similarly, let me go to worker 2 and say docker ps. Again, there is no output when it with this. Okay, it says no container has started. Now if I go back to the manager and verify, I can verify in which node this application has started, and the command for that is docker service ps followed by the name of the application, that is Angular app. So when I hit enter, you can see that the name of the application is this is the ID, and the image that was there and the node where it's running. So it's hosted in the manager one. In my system itself, it's hosted, okay, primary system. The desired state is running, and the current state is running about a minute ago. Okay, now let me go to my browser and access localhost 4200. Now, as you can see, this particular this is the Angular application which I've hosted. Okay, now I've explained what this application is about in one of my previous sessions. I would request you to go to that video and get more details about this application. Okay, I want to just quickly get back to my session here with respect to Swarm. So, since I've started my application, I can access it over here. Now, as I explained earlier, all the nodes in your cluster can see the application that you've started, right? I explained that earlier, right? Now let's verify that by going to the other nodes. So in spite of the container not being hosted on this particular node, I can get the same Angular application over here, because the port number would be exposed internally between the different nodes in that cluster. Same thing with my Docker worker too, right? So if I do, well, I've already done a Docker PS. You can see there's no container here. So let me just quickly go here and do a localhost 4200. Yeah. So you can see the application is hosted even on this particular node. Now this is good news. So this means that your application is successfully hosted on the cluster and it's accessible on all the nodes, right? Now I'm going to do a Docker node ls. And yeah, we have 3 different nodes. It's the application executed over here. If you want to verify that, you can also do this. Docker service ls. Okay, it's just one application, and if I do ps with the Angular name, with the image name, it says it's running here. Great. This is one of the scenarios which I wanted to show you. Okay, but I want to show you another scenario where the application can be hosted on multiple nodes at the same time from the manager. Okay, and the command is not going to be too lengthy also. Okay, so last time what I did, I basically executed the container at one end, right? So that was executed only over here. Let me but before I go to the next scenario, let me remove this service. Okay, so the command to remove the service is docker service remove Angular app. So when you get this output, it basically means your application has stopped, the deployment has been removed. So if I try and refresh this 4200 port, it says it's unable to find anything there. And similarly, you won't be able to find it on any of the other nodes also, because the cluster itself does not have access to this particular Angular application right now. But now let me go back to what I was talking about, the second scenario where I can start the same service on all the 3 nodes. Okay, the same Docker service which I created, I'm gonna issue that with a slight modification. So after my port options, after this flag, I'm gonna use this flag of mode. Okay, I'm gonna say mode is global. Now with the help of this flag, the application which I'm deploying, which I'm hosting, this will be basically deployed onto all the 3 nodes of mine. Okay, I can show you that by first hitting enter, and let's see what the status comes. Okay, so it'll just take a few seconds because it's being deployed to multiple nodes, right? That's the only thing. So yeah, again, the service has been created. This is the service ID. Now let's do a docker ps and check. And there's one instance of this application running in this same manager. Okay, like before, it's running over here also. And let me verify that if it's running over here this time by running the same docker ps command. Yes, as you can see, 17 seconds ago, this application was created. And similarly, if I go to the third VM and run the same docker ps command, it's opened over here also. This means that the application this time was deployed to all the 3 nodes parallelly. Okay, we can also verify that by going to the 4200 ports of each of these machines. So this time the app is back up, right? It's running again. Same thing, I can refresh this, and I will see the application coming here. It's just connecting. And similarly, over here also, I would have the same success scenario. Okay, it's connected. Great. This is the movie rating system that has been deployed across all the 3 VMs. Now let me verify this. Give you the way you can confirm this is by running the Docker service. First, you do the Docker service ls command. Okay. So with this, you have the mode as global. Okay. And it says replicas is 3 of 3. That's because there were 3 different nodes connected, and since it's deployed to all the 3, it says replicas is 3 of 3. Correct. The only difference last time was it was 1 out of 1. This time it's 3 of 3. And to give you drill down further into details as to if it's running on each of these nodes, we can use the command docker service ps followed by the application name, that is Angular app. So when I hit enter, as you can see, it says there's 1 instance running on worker 1, 1 instance running on manager 1, and the 3rd instance running on worker 2. Great. So this is what we this is the real fun part with Docker, right? With one single command, you can do all these things. So let me also, we just verified this, right? Now comes the concept of high availability. If any of my node goes down, then what happens? Will I still get access to my application over there, right? That question needs to be answered. So let's see if that is gonna happen. So for that, let's say my internet of my worker 1, right? This is my worker 1, right? Let's say my node is down, and to get my node down, I'm just going to do a disconnect. Okay. So right now it's not connected to the internet, and if I go here and do a docker node ls command, which would list down all the different nodes in my system, you can see that the status for worker 1 is down. Okay, all this time we were getting ready. That's because the status was that's because the server was up. But since I turned off the internet in my worker 1, it's telling status as down. But in spite of that, I won't have any problems accessing any application. Okay. So even though I refreshed it, you could see that on this port number I could access this application. That's because in spite of the fact that this node is connected to the cluster, I can access this, right? And the very fact I can do that is because all the machines or all the nodes in the cluster will have the port number opened, right? It would be exposed between all the other nodes. The same concept I explained during my slides, right? So in spite of the fact that my node being down, I could do this. Now this solves one aspect of high availability, right? So in this case, even if I have like multiple nodes going down, then some of the nodes which are good enough, which are healthy, those can satisfy all my services for a temporary period of time. But of course, I'd have to bring up my nodes again, right? So this is how one high availability can be accessed. That's one thing. So let me just go back to my worker 1 and enable internet again. Okay, so that I can continue with my demonstration. Okay, I'm connected now. So if I do a docker node ls again, and let me just refresh this. Yes. Now it says the status is ready. Great. I'm going to just clear the screen. Now, since I ran last command where I did it in global mode, I had an instance running on each of the nodes, right? So this time, let's say I don't want to do that. I have 3 different nodes, but I want to host the application only on 2 nodes. Well, I can do that also. I can set the number of replicas of my service over there in the command where I'm starting my service. So let me go back to that start command and modify it as per our needs. So I'm going to remove this mode global. Once you remove this flag, you can add replicas and set the number of services you want. Okay, but before this, I would have to remove the service, right? Sorry, my bad. I just forgot to do that. So let's say docker service remove Angular app. So I've removed it now, and I'm going to restart the service. Okay. So now let me start modifying this start command. So I'm going to remove this global mode, and I'm going to say replicas, and I'm going to set the replicas to 2. Now this would indicate that I will have two running instances of this service between the three nodes. Okay, it will load balance between the three nodes, and the manager will choose on its own, it will deploy the application on two of the best performing nodes. Let's verify if that's happening. So yeah, the success, so it's successful. We can verify that by doing a docker node ps. Okay, this would basically list down if the container is present in this node. Yeah, there is one container or one service running over here, but to get a detailed to get more details, let's run the docker service ps command. Okay, let me just clear the screen out and run that command again for you. So when I do this, it says that two instances have been created, right? One has been started on my worker 1 and the other has been started on my manager 1, right? Two instances between the three nodes. Let me also do this for you. Let me do a docker service ls to confirm the replicas, right? It says the mode is replicated mode and it's 2 out of 2, correct? So no hassle anywhere here, right? So if I refresh it, I would still have the Angular application hosted. This is worker 1. It's anyways hosted over here, so I don't need to verify anything. But to give you a confirmation, I can do that also by running the docker ps command. So the docker ps would list down all the containers and services running in this particular node. So when I hit enter, I have one entry here, okay, for one service that got started. However, in this node 2, the worker 2, I do not have the application, right? So let me verify that by running the command docker ps. Okay, it's not running here, there's no service, but in spite of that, the application would be running here. So that's the concept of Docker cluster, wherein all the nodes will get access to what's there in the Docker cluster. So that's the fact. And now comes the concept of scaling up and scaling down, right? This is one thing which a lot of people have this doubt, because it's not always done, right? In spite of having a cluster where you have only 3 nodes, we can scale it up to any number of services that we want to. So right now I have 2 different services, right? If I do a docker service and if I do a ls, you can see that there are 2 services running. Now if I want to scale it up to let's say 5 services, I can do that too. That would also happen. And the simple command to do that is docker service scale, and we should choose the application, and we have to set the number we want to scale it up to. Let's say I want to scale it up to 5. So in this case, 3 more services would be added on to this cluster. Okay, I'm going to go ahead and hit enter. And yeah, so it says the application has been scaled to 5. Now let me run the same docker service list command, and when I do that, it says right now 3 replicas have already been started, and let's give it a time. Let's give it a few minutes so that it can start on all the other nodes. Okay, in the meanwhile, I'm gonna I'll clear the screen first, and I will do a docker service ps and Angular app. This would tell me on which nodes my applications are going to get deployed. So it says out of the 5 on worker 1, there on 2 of those services will be running on worker 1. Okay, as you can see here, service number 1, this is the service number 2, right? This is running on worker 1, and again on worker 2 there will be 2 services running. You can see these 2 services over here, worker 2, and then on manager 1 there is 1 service running. This is because I scale it up from 2 to 5. Now let me do a docker service list command to check if all my replicas are up. Yes, so we've given sufficient time, and by now all the services are up and running. We can check it over here, but we don't need to because we know for sure that it's going to be hosted anyways. So this is good news, correct? So yeah, this is this is how we can easily scale up, we can easily scale down, and we can achieve a lot of comfort by using Docker. Correct? So yeah, guys, so this brings an end to my session, to my hands-on session. I've also showed you how to scale up and scale down. I've showed you the concept of high availability. Also, the whole concept of load balancing happened here. But there is one more thing which I also want to add on from my side. Okay, and that is, why will services be executed at the manager's end, right? A manager ideally is not supposed to do any work, right? That's what the workers are for. The manager just manages. So this is a question that you can come up with. It's a very valid question. So if I want to do that, then I can again run just one command and enable that functionality also. Okay, and the command to do that is, there is docker node update. I can use the availability flag here. Okay, and I can say drain, and I can choose which node I want to drain. So when so drain basically stops allocating services to that particular node which is specified. So over here, if I specify manager 1, then, and if I hit enter, then from now on, the service which is allocated over here, right, this would shut down and a new service would be created on either worker 1 or worker 2. That would happen. Or if I don't want to drain my manager, I can also drain one of the workers. I can either drain worker 1 or worker 2. But let's say for in our case, we want to down the manager. So I can do that by simply hitting enter over here. And yes, we've got this as the return value. That's great. So now if I do docker service ps angular application, which is the same command, you can see that the manager 1 has been shut down. Okay, and there has been an additional service that has started on worker 1. So right now there is worker 1 running is 1, 2 and 3. So 3 running on worker 1 and these 2 are running on worker 2, right? So I'm going to clear the screen here and re-execute the same command, and also show you what happens now when I do a docker node list. Okay, the node list will basically list down all the nodes connected inside that cluster, right? So I'm going to do a docker node list, and over here this time you can see that for my manager 1, which is this ID, the status is ready. However, availability is not active, it is drained. Okay, even though it's the leader, it is drained. So from now on, if I scale up the service or whatever I do, even if in case of high availability, at that time I cannot no services will be allocated to my manager unless and until I remove the drain. Okay, I can remove the drain by again specifying the command of active. So let me run that command and show you that. So here, instead of saying drain, if I change the availability to active, then I can start allocating services to my manager also. So if I hit enter, it says I've got manager 1 as the return value. And again, if I run the same docker node ls command, availability is there. And from now on, whichever, if I scale up only at that point of time, will my manager start getting resources. So these would what are existing, right? This will not get allocated to my manager. In case if there's any downtime, if any of my node goes down, then at that time manager 1 will get access, right? And yeah, that would happen. So this is the simple demonstration which I want to show you. It sounds simple, but this solves a lot of industry issues. Correct? It's one of the best tools I've worked on. Docker and Docker Swarm is one amazing technology that also I've witnessed. So I hope you've also understood what kind of what I'm talking about over here. Correct? So yeah, that brings an end to my demo session here.
So before I deep dive into what exactly is Docker networking, let me show you the workflow of Docker. Alright guys, so this is the general workflow of Docker. So a developer writes a code that defines all the application requirements and dependencies in an easy to write Docker file, and this Docker file produces Docker images. So whatever dependencies are required for a particular application
is present inside this image, and then when we run this Docker image, it creates an instance, and that is nothing but the Docker containers. This particular image is then uploaded onto the Docker Hub. So from these repositories, you can pull your image as well as you can upload your images onto the Docker Hub. Then from the Docker Hub, various teams such as the quality assurance team or the production team will pull the images and prepare their own containers, as you can see from the diagram. Now, these individual containers will communicate with each other through a network to perform all the actions required, and this is nothing but Docker networking. So what exactly is Docker networking? So when containers are created, these isolated containers have to communicate between each other, right? So the communication channel between all the containers introduces the concept of Docker networking. Alright, so now what would be the goals of Docker networking? So Docker is flexible, in other words, I mean pluggable. By flexibility, I mean that you can bring in any kind of applications or operating systems or any kind of features in Docker and deploy them in Docker. Next, Docker can be easily used in cross-platform. By cross-platform, I mean you can have n number of containers running on different operating systems, like one container can run on the Ubuntu host, other container can run on the Windows host, etc. like that, right? So you can have all these containers work across with the help of Swarm clusters. After that, we have Docker offering scalability. As Docker is a fully distributed network, it makes the applications grow and scale individually. Then we have Docker using decentralized network. This enables the capability to have your application spread and highly available. So in the event that a container or a host is suddenly missing from your pool of resources, we can automate the process of either bringing up additional resources or passing over to the services that are still available. Apart from offering the decentralized network, we have Docker being really user-friendly. So Docker makes it really easy to automate the deployment of your services or containers that would make things easy for you in your day-to-day life. And finally, we have Docker offering out-of-box support. So the ability to use Docker Enterprise Edition and getting all the functionalities very easy and straightforward makes Docker platform to be very easily used. So those were the goals of Docker networking. Now, to enable these capabilities, we have the container networking management, and to do that, we have the libnetwork. Now, what is this libnetwork? So libnetwork is an open source in which you can read through the source code and you can automate all of that as an open source. So libnetwork is basically a Docker library that implements all of the key concepts that make up the CNM model. Now, what exactly is this container network model? Well, container network model formalizes the steps required to provide networking for containers while providing an abstraction that can be used to support multiple network drivers. So CNM requires a distributed key value store like console to store the network configurations. The container network model has interfaces for IPAM plugins and network plugins. The IPAM plugin APIs are used to create or delete address pools and allocate or deallocate container IP addresses, whereas the network plugin APIs are used to create or delete the networks and add or remove the containers from networks. A container network model is basically built on three main components: the sandbox, endpoints, and the network object itself. So a sandbox contains the configuration of a container's network stack. This basically includes the management of the container's interfaces, routing tables, and DNS settings. Now, a sandbox may contain many endpoints from multiple networks, right? An endpoint is something which joins a sandbox to a network. Endpoint can belong to only one network but may only belong to one sandbox. And finally, as I was talking about network is a group of endpoints that have the ability to communicate with each other directly. Now that you know a brief about the container network model, let me tell you the various objects involved in this model. The container network model comprises of 5 main objects: the network controllers, drivers, network, endpoint, and sandbox. Starting with network controller object provides the entry point into the libnetwork that exposes the simple APIs for users such as the Docker engines to allocate and manage networks. Since libnetwork supports multiple active drivers, both inbuilt and remote, network controller allows users to bind a particular driver to a given network. Next comes driver. Driver is not a user visible object. but drivers provide the actual implementation that makes the network work. Driver can be both inbuilt and remote to satisfy various use cases and deployment scenarios. The driver owns the network and is responsible for managing the network, which can be further improvised by having multiple drivers participating in handling various network management functionalities. After the driver object, we have the third object as network. Network object is an implementation of the container network model. As I said, network controllers provide APIs to create and manage the network object. Whenever a network is created or updated, the corresponding driver will be notified of the event. The lib network treats network object at an abstract level to provide the connectivity between a group of endpoints that belong to the same network and then also simultaneously isolate them from the rest. The driver performs the actual work of providing the required connectivity and isolation. The connectivity can be within the same host or across the multiple hosts. After that, the next object that we have is endpoint. As I discussed before, endpoint mainly represents a service endpoint. So it provides the connectivity for services exposed by a container in a network with other services provided by other containers in a network. So the network object provides the APIs to create and manage endpoints, and an endpoint can be attached to only one network. Since endpoint represents a service and not necessarily a particular container, endpoint has a global scope within the cluster as well. And finally, we have the sandbox. So the sandbox represents containers network configurations such as the IP address, MAC address, routes, and DNS entries. A sandbox object is created when the user requests to create an endpoint on the network. The driver that handles the network is responsible to allocate the required network resources such as the IP address and pass the info called as sandbox info back to the lib network. So, the lib network will make use of the OS specific constructs to populate the network configuration into the containers that is represented by the sandbox. So, a sandbox can have multiple endpoints attached to different networks. Alright guys, so that was a brief about the various network model objects. Now, let me tell you the various network drivers that are involved in Docker networking. Docker networking has mainly 5 network drivers involved with it: the bridge, host, none, overlay, and MACLAN network. So starting with the bridge network is the default network driver. So if you do not specify a driver, then this is the type of networking you're creating. So the bridge network is a private internal network created by the Docker on host. All the containers are attached to this network by default. The containers can access each other using this internal IP, and if it is required to access any of these containers from the outside world, then port forwarding of these containers is performed to map the port onto the Docker host. Bridge networks are usually used when your applications run in standalone containers that need to communicate. Another type of network is the host network. This removes the network isolation between the Docker host and the Docker containers, and then it uses the host networking directly. So, if you were to run a web server on port 5000 in a web app container attached to the host network, it is automatically accessible on the same port externally without requiring to publish the port, as a web container uses the host network. This would also mean that, unlike before, you will now not be able to run multiple web containers on the same host on the same port, as the port are now common to all the containers in the host network. The third option is the none network. The containers are not attached to any network and do not have any access to the external network or the other containers. This is usually used in conjunction with a custom network driver and is not available for Swarm services. The next network that we have in the list is overlay network. So to understand this network, let's consider a scenario. Let's say we have multiple Docker hosts running containers. Each Docker host has its own internal private bridge network in the 172.2.17 series, allowing the other containers running on each host to communicate with each other. However, containers across the host have no way of communication with each other unless you publish the ports on those containers and set some kind of routing yourself. This is where the overlay network comes into play. With Docker Swarm, you could create a new network of type overlay, which will create an internal private network that spans across all the nodes participating in the Swarm cluster. We could then attach the containers or services to this network using the network option while creating a service, and then we could get them communicate with each other through this overlay network. So you can say that you can use overlay networks to facilitate communication between a Swarm service and a standalone container, or between two standalone containers on different Docker daemons. And finally, we have the last network, that is the MAC-LAN network. So MAC-LAN networks allow you to assign a MAC address to a container, making it appear as a physical device on your network. Then the Docker daemon routes traffic to the containers by their MAC addresses, and then the MAC-LAN driver is sometimes the best choice when dealing with legacy applications that expect to be directly connected to the physical network rather than routed through the Docker host network stack. So guys, that was about the various network drivers. Now let me brief you a little bit about Docker Swarm and tell you the significance of Docker Swarm in Docker networking. In simple words, if we have to define Docker Swarm, then Docker Swarm is a cluster of a machine all running on Docker. This provides scalable and reliable platforms to run many containers, which enables the IT administrators and developers to establish and manage a cluster of Docker nodes as a single virtual system. So, as we know that Docker Swarm is a technique to create and maintain cluster of Docker engines, what exactly is this cluster of Docker engines? So let me tell you that in a cluster of Docker engines, there will be many Docker engines connected to each other forming a network. This network of Docker engines is what is called as a Docker Swarm cluster, as you can see from the diagram on the screen. And this is also the architecture of Docker Swarm cluster. So there will always be one Docker manager. In fact, it is the Docker manager which basically initializes the whole swarm, and with the manager, they will have many other nodes on which the server should be executing. So there will be times when the service is also executing at the manager's end, but the manager's role is to make sure that these services or the applications are running perfectly on the Docker nodes. Now, whatever applications or services that are specified or requested, they will be divided and then they would be executed on different nodes, as you can see in the diagram here. So these different nodes are nothing but the workers. Alright guys, that's all you need to know about Docker networking. Now let's move on to the hands-on part. In our hands-on part, first I'm going to show you how to create a simple network and how to deploy the service over your network. And after that, we'll create a Swarm cluster and then we'll connect two services and then we will scale a single service. Alright, so let's get started with our hands-on. So first, we're going to deploy an application named Apache 2 by creating a Docker service in the default network, that is the bridge network. So apart from that, we'll also initialize the Swarm cluster as we want it to work on two different nodes, that is the manager node and the worker node. So for that, let me open my terminal and then let me type in the command sudo docker swarm init -advertise -addr and then mention the IP address, right? So I'll mention the IP address of the manager node and then I'll click on enter. Once you click on enter, you'll be asked for the password. So type in the password and then you can see that the swarm has been initialized. Now to connect the slave node to this particular manager, you have to copy this link and then go to the slave node, open the terminal and then paste it here. So you can see that this node has joined the swarm as a worker. So that is the manager and this is the slave. Now let's go back to the manager node and over here, we're going to deploy an application named Apache 2 by creating a Docker service. So for that, you have to type in the command docker service create --name, give the name of the application, --mode, that is which mode we want it to work. We want it to work in the global mode, -d, -p, that is port forwarding, and then we'll mention the port where it's going to work. So it's going to work on 8003 and then mention the account name from which the Docker image has been pulled. So once you click on enter, you can see that your Docker service has been created. Now to check whether your Docker service has been created or not, you can use the command docker service ls. So this will list all your running services. At present, we just have one service, that is Apache 2. Now to check whether it is running or not, you have to go to the slave node and then open the web browser here and then let's go to the local host to the port 8003. So let's go to the port. So you can see a message that it works. So that means our application has been deployed onto a container and then it is also connected to the Swarm cluster. So the worker also has this particular application. Now, if you want to deploy a multi-tier application in a Swarm cluster, How will you do that? So let me show you how to do that. So before I do that, let me tell you what are we going to connect. So basically we have two applications, that is the web application and the MySQL database. So the web application has two parameters, that is the course name and the course ID. And once you mention the details and you click on submit query, it will be automatically stored in the MySQL database. This multi-tier application is connected with each other through the overlay network. So let's start doing it. So first let's create the overlay network. So for that you have to type in the command docker network create -d overlay my overlay 1. So my overlay 1 is basically the name of the network that I'm giving. You can give any other name that you want. After that, let's create a service for the web app application. So for that, I'll again type in the command docker service create -name. Name of the application is web app 1 -d network, and we'll connect it to my overlay 1 network, and then -p for port forwarding, and then we'll mention the port on which it is going to run, and then we'll mention the account details from which this Docker image will be pulled. So after that, you can just click on enter. So you can see that your Docker service has been created. So let's check it once again. So for that, you'll type in the command as docker service ls. So you can see that the web app 1 service has been created. Now we'll create another service for the MySQL application. So for that, you'll type in the command docker service create -name MySQL, that is the name of the application, -d network. The network through which we want to get connected is my overlay 1 -p for port forwarding. Let's mention the port, and then the account details. So for that, let me mention the account details. So you can see that your Docker service has been created. So let's check again. So for that, we'll type in the command docker service ls, and you can see that the MySQL service has been also created. Now what you have to do is you have to go to the web app application, and inside which you have to make some changes. So to go inside the web app service, you need to know the container ID. So to know the container ID, you have to type in the command docker ps. So this will list all the container IDs that are present on this node. So you can see that web app 1 and Apache 2 are present. At present, we need container ID for web app 1, right? So to go inside this container, you'll type in the command docker exec -it, and then copy this container ID and then paste it here, and then end the command with bash. So you can see that you've gone inside this container. Now you have to go to a file index.php and make some changes. So for that, we'll type in the command nano and mention the directory. So this PHP file opens up. Now you have to change the server name to MySQL since we want to get connected to the MySQL server, and then change the password to Edureka. And let's say we keep the database name as hands-on. After that, use the keyboard shortcut Control X, press on Y, and then save the file. So once you're done with this, you have to exit the container. So for that, type in exit, and you can exit the container. Now you must have observed here that only the web app and the Apache 2 services can be seen on this node, whereas we are not able to find the MySQL. That is because it is present in the slave node. So let me show you there. So let me go to the terminal, type in docker ps, and you can see that the MySQL service is over here. So why is that so? That's because Swarm is performing load balancing. It is dividing its containers into two different nodes so that it can balance the load properly. So now what you have to do is you have to go inside the MySQL container. So for that, you'll type in the command docker exec-it, and then mention the container ID of this particular container, and then end the command with bash. So you'll go inside this particular container. Now once you're inside this particular container, you need the access to use MySQL commands. So for that, you'll type in the command mysql -u root -p edureka. So once you type in this command, you can see that you've got the access to use the MySQL commands. So -u is basically the user, and -p is for the password. And if you have a question that why are we using -it here, that's because we're opening the container in the interactive mode. So once you get the access of MySQL, you have to create a database and then you have to create a table inside it. So for that, you'll use the MySQL command such as create database hands-on. And then you have to use that database. So for that, you'll type in the command use hands-on. So you can see a message that the database has been changed. Now you have to create a table. So for that, type in the command create table. Let's say courses is the name of the table, and then mention the two parameters. So we have course name, which is of varchar type. Let's say it allows a length of 15 characters. And let's say we have course ID of varchar types of 12 characters. And after that, close the bracket. And this creates a table for you. After that, you have to exit your MySQL connection. So for that, you'll type in exit. And then you have to again come out of this container. So again, type in the command exit and you'll be out of this container. Now what you have to do is you have to go to the slave mode and then run this index.php file. So for that, let me open localhost. Since the web application service was running on 8001 and index.php file. Alright, so you can see that our Docker sample app has been opened up. Now before you include the details, let me go back to my web app container and let me show you what all I've changed in the file. So you have to mention the server name to be MySQL, your username to be root, password to be your password, and then database what I've mentioned there, that is hands-on. And the name and ID would be the parameters that I would give. So it would be course name and course ID. And then you have a basic PHP file in which you write the SQL command that insert into the course name and the course ID, which will basically include the details that we fill into the application to be stored directly into this table. Now let's go back to the slave node. And now let's mention some details. So let's say we mention a detail to be blockchain and the course ID to be randomly some number. And then we'll submit the query. Once you submit the query, you can see that a new record has been created successfully. So let me just create few records. Alright, so I've typed in few records. Now let's go back to our MySQL container and get into the database and see if our table has all the records entered stored or not. So let's go back to the terminal. So now let me type in the command docker ps. And then I'll type in docker exec-it, mention the container ID. Now I'll type in the command mysql-u root-p edureka. So this will give my MySQL connection. So now I'll type in the command as use hands-on. So database has been changed. Now I'll type in the command as show tables. So it will show me the tables that I've included in database. So I have this table included. Now let me type in the command select star from courses. So this will basically list all the details that are stored inside this table. So you can see that we have entered so many details with the help of this web app and that were directly stored into our MySQL database. So guys, that's how you can, connect multi-tier applications over the overlay network. Now, if you want to scale any particular service, you can just scale that service by using a simple command. So for that, you have to go back to your manager node and then use the command docker ps to list all the containers. Alright, so we have two containers. Let's suppose we want to scale this web app service for around 5 times. So you can do that with a simple command, that is docker service scale web app 1 is equal to 5. So you can see that the web app 1 service has been scaled to 5 times. Now, if you want to check whether it is working or not, you just have to type in the command docker service ps web app 1. So you can see 5 instances of the same services. So guys, that's how you can deploy a simple application over the default network and also connect multi-tier applications with an overlay network, and finally you can scale any particular services. So guys, that was a short demo on Docker networking.
The project that I'm going to show you is that of an Angular application which is created by my team. And what I'll be doing is I'll be deploying this Angular application by implementing the DevOps strategy. The first topic that I'm going to talk about today is what is Angular. And after I talk about Angular and give you an introduction, I'm going to talk about
what is DevOps, right? So this is going to be very brief. I'll quickly talk about these two things, and then I'm going to go to the third topic, which is the different DevOps tools and techniques to achieve continuous deployment. Because this is the highlight of today's session. I'll be spending a lot of time on this slide and on the final slide, which is containerizing an Angular application the DevOps way. And the DevOps way basically includes a combination of these three tools: Git, Jenkins, and Docker. Alright guys, so enough talk. Let me get started with my first topic, and that is, what is Angular? So Angular is an open source client-side framework for deploying single page web applications, right? And the keyword that you need to note here is single page applications, and that's acronymed as SPA. There are quite a few technologies for developing single page applications. So Angular is a very popular one. React.js is another popular technology. Similarly, Vue.js, and we have a couple more. And well, the thing that you got to ask me here is, why single page applications, right? So you might ask, why am I having a demo on single page applications, right? Well, the answer for that is because single page applications are the way forward. They are more effective and they are easier to build, and they come with a lot of other benefits that I of course can't mention in today's session because that'll get too detailed. But I do have a couple of benefits here that I've mentioned on the slide, and you can see that on your screen now. And the biggest reason and the most important factor is single page applications, which are created by technologies like Angular and the other JavaScript technologies. These applications are really fast, and they are fast because while accessing any web page which is developed in Angular or such technologies, that time your browser will fully render the entire DOM in one single time, and later on it only modifies that view or the content displayed to you when you interact with that web page, right? And even these modifications will be done by the JavaScript which runs in the background. And yeah, you can see an example of an SP architecture over here, right? So you have basically any web application which is developed with the help of Angular, right? So they'll be called single page applications, and they'll have three different components, first of all. Or well, let's not say three components. In my example, it's three components, but in general they'll have different components. And the components that you can expect there to be are those of a navigation bar where you can switch from one tab to another tab. Then you'll have a sidebar, right? Again, you can filter down to different options that you want to be displayed, and then of course you'll have a content bar, right? So similar to how you have a sidebar, you'll have another component called the content, which will be the actual display. So whatever you're actually viewing on your on your web page, that will be displayed over here, and what is displayed here can be controlled from here by clicking on the different information, or you can also control that by switching or clicking on a different option in the navigation bar or in the sidebar. So you can switch the view like that, and when you do it this way, your browser will not take too much time to fetch the information from the server, because the entire DOM will be fetched at one go. So that's the big benefit with single page applications, and especially Angular implements, Angular is used for developing single page applications. That's why it's the way forward, and it's really popular, and it's the technology is really coming up. So my team has developed a single page application using Angular, and that's what I'm going to deploy today, right? Now let me quickly go to the next slide and talk about what is DevOps here, right? I'm sure everyone here knows what DevOps is. It's a software development approach which involves continuous development, continuous testing, continuous integration, continuous deployment, and continuous monitoring of the software throughout its development life cycle. Well, I've mentioned this numerous times in my various sessions, and I expect you to know this, okay? But what you might not know is which of these tools are used for continuous deployment, right? So on a higher level, I can say that Docker is the most important tool for achieving continuous deployment, okay? But as you can see on the screen, I will also be showing the act of continuous development and continuous integration in today's session. So continuous development is achieved with the implementation of Git and GitHub. Continuous integration is achieved with the implementation of Jenkins, and continuous deployment is achieved with the implementation of Docker. Well, using GitHub, you can pull the code from the repository, right? And then using Jenkins, we can deploy that code to the production environment or the servers or virtual machines, whichever suits you. And then finally, we can make use of Docker to containerize those deployments. So that's how the different DevOps tools that you see here, Git, Jenkins, and Docker, that's how they can be orchestrated to achieve automation and for software development. So that's how things go. And in my Angular application, I'm going to use these three tools, right? These three DevOps tools. Now, moving on to the next slide. Now, this slide, which is all about deploying an Angular application, this is the most interesting slide in today's session. And you can ask me why. And the reason for that is, the reason it's interesting is because we are using Docker majorly, right? We are pulling all the code from Git, and then we are using Jenkins to integrate it into Docker, and we are creating multiple containers by using Docker. Basically, Docker containerizes application along with all its dependencies, right? And when we say containerizes, it means that we are packaging the code of the application along with all the required packages and dependencies in a lightweight manner, which is not too heavy on the server on which we are deploying the application to, right? So, and the best part with these Docker containers are that they can be run on any operating system, irrespective of the one it was built on. Well, what that means is I can containerize any application. In my case, let's say in my case, I have the Angular application, right? What kind of dependencies will my Angular application have? The dependencies that your Angular application would primarily need are those of Node.js, Node Package Manager, which is again acronymed as NPM, and of course the package.json file, right? So Node.js is basically going to be the backend for your Angular application. NPM is going to install an Angular application and maintain all its dependencies and the versions of those dependencies. And the package.json file is again the most important file, right? Because it's going to contain details about your project, about what dependencies are needed and what versions of dependencies are needed. All these things will be present in your package.json file. So basically these three files will be the dependencies. And in my case, what I can do with the help of container is that I can have a container, I can install all these dependencies, I can place them all together, and I can simply, without having an operating system that's actually powering it, I can package all these things into this particular container, and I can just, share it with other people. And what the other people have to do is they just have to, run the container, and they can just boot it with the help of any operating system, right? So that's the benefit with containers. So developers can containerize any app that's created in a Mac operating system, and probably they can upload that container or image to Docker Hub, and someone in a remote location can download that Docker image and spin a container out of it, while the person that's remotely located, while he's having a different operating system. So the guy who built the application, right, who built the Docker image, he could have done it using a different operating system, and the guy who's actually running the container at a remote location, he can have a different operating system. So that's the big benefit. So you guys are getting the advantage that lies here, right? With the help of Docker and with the help of containerizing all your applications and dependencies, minus the actual operating system. Okay, so anyways, I think it's time to move on. And now I've reached my demonstration aspect, right? So now that I've told you what exactly is what I'm going to do, right? That's going to be the architecture of how I'm going to deploy my Angular application. Now that you know it, I'm going to start with my demonstration, and what I'm going to do is I'm going to do it with the help of continuous deployment using Jenkins and Docker, and we will also use GitHub from where we will be pulling the code, right? So let me first of all open my virtual machine for that. So first of all, to achieve this continuous deployment, like I told you, Jenkins is the broker, right? So Jenkins is the one that pulls the code from the repository, and that is which is going to help us build Docker images and spin containers out of those images. So what I have to do is I have to first of all open my web browser and launch my Jenkins dashboard, right? So Jenkins is by default hosted on port number 8080. So let me just launch that particular launch that port number on my local host. Sorry for the delay, guys. It's lagging a little bit. Right, so this is the port number where Jenkins is hosted. Now, in the meanwhile, let me just quickly go to my terminal and show you my project folder where my actual application is present. So here's the terminal, and my project is present in this folder. I've created a demo folder inside which there's a top movies, right? So the top movies is the project which I created, the project folder, And what you see here, these are the different files and folders present inside this project folder. Let me also open it through my file explorer here and explain what these different packages, files and folders are for. So this is the project that I created, and as you can see, there are a number of files here, and the number one file that I want to talk about is that of a Docker file. Right now, the Docker file is basically used to build your Docker images and spin containers out of those Docker images, right? And to build your Docker images, you specify the commands inside the Docker file, right? And then you just execute that Docker image which is built by issuing the run command. That time your Docker container would be spun, and that time your container would be ready and your application would be hosted on a particular port number, and then it would be mapped to a particular port on your local host. So all these functionalities are done with the help of Docker file. Okay, now, but that is only with respect to Docker. And the other things here, the other folders and the files that you see here, these are with respect to my Angular application. So we have different files like the package.json file, we have node_modules, we have src folder. So all these things, well, first of all, let me talk about the package.json file. Right now, this package.json file is a very important file which contains all the details about my project. It contains which version of which dependencies my project needs, what's the name of my project, what versions of dependencies my project needs to implement. All these details would be present inside my package.json file. So without the package.json file, your application cannot get hosted. It's, for those of you who are new, you can consider this to be like the metadata, right? If people know what is a metadata, so package.json does a similar role, right? But here comes the question: how will the package.json file be initiated, right? From how do you execute the package.json file? What's the first step? And that's where this whole node_modules folder comes into the picture, right? So you have a command called npm install, right? So npm install is nothing but, the npm stands for node package manager, right? So it installs all the dependencies that your project needs. And when you run the command npm install through your terminal, so at that time, it will look for the package.json file in that particular directory. So I have to execute the npm install from the directory where my package.json file is present. From here, if I execute that command, that time, it would first of all initiate the package.json file, and whatever dependencies are present over here for my project, for my code, all those would be installed and downloaded and installed from the node repository, right? In my case, it would be node repository, but yeah, otherwise you would just download it from the internet and you would have it already, and all those dependencies would be present inside this folder called node_modules, right? And this folder node_modules is going to be a very heavy folder, right? There's going to be a lot of contents here, so it's ideal that you don't place it in the GitHub. If you want to share your project with someone else, you in the real world environment, what happens is you just share the package.json file, and when they do the npm install, that time they would automatically get all the dependencies installed as per the package.json file, whatever specified here. So that's what it does. And then you have other files here, right? Other configuration files like protractor.configuration file. You have the TypeScript configuration file, the TypeScript lint configuration file, and you have the other files here. So guys, all these configuration files are the configuration for your Angular applications, right? Be it the TypeScript configuration or the linting configuration or the protractor. All these can be considered, basically these are the boilerplates that come with the actual Angular application. So that's these are dependencies, right? So you need it with your project, and the folder src. So this is where your actual project would be present. So whatever code you've written for your Angular application, that would be present here. So yeah, these are basically the contents of my repository, and these are what is needed for containerizing my Angular application. And maybe you would find I've not explained this folder, right? E2E. So this one basically is used for the end-to-end testing. So whatever is needed for that is present in this package here. But yeah, on a high level, this is what you need to know. These are the packages, and the first thing that I got to do is to containerize this application. The first thing I have to do is I have to pull the code from my GitHub repository, and I will do that with the help of Jenkins. Right, so even though I have it locally, in a real world environment, developers or engineers would pull this code from GitHub, right? So I will show you how that happens by first of all going through my Jenkins dashboard here. This is my dashboard. I already have a project called demo. So this is the one that I want to show you a demonstration of. So this contains, I've already pre-built the environment so that I don't waste much time and downloading everything, and because downloading everything and installing everything would take a lot of time. So if I have the environment ready, I can just show it to you straight away. So I have it over here, and if I go to configure, I can show you what are the elements that I've defined already. So let's just wait for this to come up for a minute. First of all, we have to go under the source code management, right? So this is where you need to first of all enter the GitHub repository from where you want to pull your code, right? Now let me just open this repository and show you what I'm going to pull. It's basically the same content that is there in my local host, in my host system, right? So whatever you saw over here, the file explorer, most of the contents over here are there in my GitHub repository, except for the node modules, because this gets installed automatically when you run the package.json file. Yeah, so you guys see this, right? So we have the same E2E folder, we have the SRC folder, and then we have various other files like the Angular CLI JSON, we have the Docker ignore, we have the Docker file that's present. Why the Docker file is present inside the GitHub repository? The reason I have the Docker file inside the GitHub repository is because wherever my code is present, right? So that's where my execution should ideally happen. And if I have my Docker file present in the same directory, then I can run my Docker file. I can use my Docker file to build my Docker image inside that repository, and it will also look for the dependencies and the Angular code for my application, all these things from the same repository. So that's why I have the Docker file in the same repository, right? So that's what Docker file is used for. And then similarly, we have the other dependencies like the package.json, the tsconfig.json, the other things which I spoke about, which was there over here. So the same thing we have in our GitHub repository. So getting back to our Jenkins, we first of all specify that we want to pull the code from here, and what we do next is we can go down to the build option. So under build, we have our shell here, right? So whatever commands you specify here, they would be executed on your shell. So since I'm using a Linux system, I've chosen to execute these commands on my shell. Well, in case you guys are executing it at your end, if you're using a Windows system, you might probably want to choose Windows batch command and then specify the commands that you want to run in your Windows CLI, right? So that's the only difference. But yeah, whatever commands I specify here, they will be run on my shell. And the command that I'm first of all running is that of docker build, and I'm building the image called demo app1. So right now I'm using the docker build -t flag t command to build a new image called demo app1, and it would build this application based on the Docker file which is present in this folder. So this is the folder where my Docker file is present, right? So I can, in case I do a cd and if I give this folder, then I would have moved to that particular directory, and then I can just simply replace this path with a dot. So that's another alternative. But yeah, otherwise you can specify the entire absolute path also here. So I've done that, and it's basically creating a new image based on the Docker file and the instructions present inside the Docker file in this command. And then in the second command is the Docker run command. Okay, so the image that was created here, demo app1, so that image is basically being run. Okay, you spin an image into a container by running this command docker run, and you specify other options while doing this. We specify flag rm, we specify single flag p, and then we specify the port numbers. So the p flag is used for mapping your Docker containers port to your host machine's port. So over here, the 4200 that you see here, this is the port number of my host machine on which the subsequent or the equivalent port on which my Docker container, right? So whatever is basically present in my Docker container, the port number, whatever is hosted there, that would be visible inside my 4200 port in my host system. Okay, so yeah, it's an Angular application, right? It's a web application. So what you have to do is you have to host that in one of the ports. And I have by default, Angular applications are hosted on port number 4200, and I've also specified the same in the package.json file. So that's where you specify the port number. And what I'm saying here is, whatever is running inside my Docker container in port number 4200, that should also be visible or available in the port number 4200 of my host machine. So that's what the flag here stands for. And then we have the name I'm giving this container which I'm building. I'm giving it a name, Top Movies 1. And yeah, this is basically the image, same image that we are first of all spinning with the help of our Docker file. So these are the two commands that I'll be running. And at this point of time, if there are any of you who are new to Jenkins, or if you are new to Docker, if you execute the same commands from your execute shell, you might have a problem. So can any of you guess what that problem might be? Right? So I can give you a hint. The problem would lie over here. Okay? So it would lie right at the beginning of this command. Well, no problem. See, the thing is, any Docker command that has to be run, it has to be run with the sudo access, right? Only the root can execute any Docker command, especially the build and the run command. Okay, but there are few commands which can be executed without the sudo, but yeah, these two commands especially need sudo access. If you are executing the same two commands from your terminal, then you can just simply prefix this whole command with sudo here, and then the shell would prompt you for the password, and then you can enter the password. But what would you do in case of Jenkins, right? So this is Jenkins. You cannot put sudo here because Jenkins cannot manually enter the password for root access, right? So root credentials Jenkins doesn't have. So in this case, what you need to do is you have to give the sudo credentials or the root credentials to Jenkins itself. So Jenkins is actually a user. If you guys notice, if you go under or let me just tell you this. Jenkins is a separate user because it's a web server, right? And any commands that you execute through Jenkins, it would be executed as the user Jenkins. So what you have to do is, similar to how you you execute Docker commands without sudo, how you create a new Docker group and you add your user, the user from which you're executing, you add that user to the group. Similar to that, you have to add your Jenkins user to the Docker group, and you should give the Docker group the root access. So the Docker group would basically be on par with root in terms of the access that it has over the system. So that's the important step that you need to do, because otherwise if you don't enable this access, then your command is not going to get executed. It would say failure, permission denied. So that's the thing. And yeah, if you have these two ready, then it's pretty much ready, right? Your Docker file would be used to build the image, and then that image would be used to get the container out. So I'm just going to save this and quickly show you how to build this application. Okay. So to build the application, you can simply go to build now, right? You can see the build history here. These are the previous times I ran the same command. And if I do it again, build now, it says build is scheduled, and you would see a new build pop up over here. Build number 12, right? So if I click on this, and if I go to console output over here, you would get to see what is the status of this build. So let me just go here. And yeah, if you go to console output, you will get to see what's happening. So similar to the output that you get on your terminal, something like that you will get over here. Okay, we're here already, so let me just quickly go up. As you can see, the first set of commands have started executing using your by Jenkins, and the first one was to pull the data, the code from Git, right, and from the Git repository. So whatever was there is being fetched over here, and then the first command that we're executing on the shell can be differentiated with this command. The plus symbol basically indicates that it's a command that's being executed on the command prompt. So the docker build -t demo app is the command that's being built, and when you build it, you can see that there are various steps being performed. So for each line in your Docker file, there will be a step that will be performed. Now let me quickly go to the Docker file and explain what are the different steps that are going to be performed. Okay, so at this point of time, I'm going to go back here and let me open the Docker file and explain the different steps. Because if we want to host a node, if we want to host an Angular application, we have to first of all pull a node image, right? Your Angular application would be present, or it would be hosted only when there's a node application which is running at the back end. So the first command, that is from, it's going to pull the node image which has the tag 6, right? So version number 6 of node. So probably this is what is going to get pulled with the help of from node 6. And when it pulls, then what you got to do is you have to use a run command to make a directory inside this particular image. So you use the -p flag to specify the path that you want to create, /user /src /app. So you're creating this particular path inside your Docker image which you've pulled, and then you're changing the working directory to the path that you created by using this command workdir and this. And the first thing that you got to do, that you need to notice here, is the package.json file which is present in my local system, that I'm moving to my path which I created inside my Docker image. Now that is because this is the file that contains all the dependencies that are needed to basically download all the node modules, right? So whatever dependencies are there inside the node modules, they will be downloaded with the help of package.json. So right now it's present in my local system. I'm specifying Docker to copy this file into the directory path here, and then once you've done that, it asks me to run the npm cache clean. Now if you're running the npm install for the first time, or if you're using npm for the first time, you might not need it, but since I've run this command earlier, I'm just using it because I want to avoid any version conflicts between the different dependencies, right? So dependencies can be of different versions of Angular 2 version or Angular 4 version and all those. So I'm just using this to keep myself healthy there. And then I'm using the run npm install. So this is the most important command which would basically start everything. So the npm is the node package manager, and when the moment I issue this command, my package.json file would be searched for, and when it's located, the commands there, the dependencies which are there inside, those will be created inside a Docker modules, right? Node modules. Inside that folder, everything will be created. So that's what this command does. And the next command is all about copying every single file or folder which is present inside my inside my host directory, that I'm copying it into my host folder. So the other files that are those of configuration files which I spoke about earlier, the TypeScript configuration file, the TypeScript lint file. So all those applications will also be copied to this image inside my to this path inside my Docker image. And then I'm finally saying expose 4200 because this is the port on which my AngularJS application would be hosted. And then I'm finishing it off by specifying this command of npm start. So you do the npm install here. So at this point of time, your dependencies are ready, everything is ready to be, your application is ready to be deployed and hosted, and the start is what is going to actually do the hosting onto this port number 4200, right? So that's what the Docker file instructions are, and the same instructions have been running on my Jenkins. So it says step 1 of 9, it's pulling from here and it's moving to this directory, and it's creating a new directory, moving the working directory to this, and then copying the package. So each and every step is being executed one after the other. If any of them fail, then you would have a notification saying this step failed and check your command. So all those details. But anyways, since ours is successfully built, this is the ID of my image which was generated, right? And yeah, this is the tag has been added to it. And the next command that's being run from my shell is the docker run command with the --rm flag and the p flag, right? The same command which I explained earlier. And when this command is executed, it says that your ng-serve is being hosted. So this is the localhost port which I'm mentioning, on which I wanted to run, and you can see the status here, right? It says 0%, 10% here. You have again, 10% here, and yeah, basically it keeps increasing. So we have 11%. So it's a big process. So there's a lot of dependencies that gets downloaded, and in the meanwhile that we saw the Docker file, that I was explaining the Docker file, we have all our packages downloaded and installed, and your application is actually hosted. So it says Webpack compiled successfully, right? So this is the success message. If I now open the localhost 4200, then you would see that my Angular application is up and running, right? So you can see that the application name is Movie Rating System. And this is something that I didn't tell you. This was the application which my team created for me, and this project is all about the top 250 movies that you have to watch before you die, right? Some of the the biggest blockbuster hits of Hollywood. So all those are present here. It's the Angular. You will get the Angular feel over here by looking at the different components. So the logout option that you see here, this is a different component, right? If I log out, then I do not get to see the list of movies. But if you log in, only then you will get to see that, right? And then you have the navigation bar here where you can switch to different tabs. You can go to the Edureka home tab. You can go to the the about tab where again we have other details. And then if you log in successfully, then you will get to see the movie list that we have. So let's just wait for this to log in, and I can show you the movie list that we have. Yeah, so you have the movie list here, right? So in the navigation bar, let me just click on this movie list, and you can see the 250 movies that we choose are have been the best ever Hollywood movies. Yeah, so the number one movie that you have to watch is The Shawshank Redemption, right? And then we have other movies like Godfather, the part 2 of Godfather, Dark Knight, 12 Angry Men, which again is my favorite movie. We have Schindler's List. We have a number of movies here which which is our favorite, of course. And we've created an application this way. And this is a simple web application, a single page web application that we created. And you can create all these things if you know how to work with Node.js, and if you know how to work with AngularJS, right? Similarly, if I go to the Edureka tab, we have details about Edureka over here. So we believe in tech up your skills, rediscover learning. So we have that, live classes and expert instruction. So this is the interface that we built, that we created in our application, and that's what I want to show you. And in the movies list again, I mean, of course, we have the list of movies, and if you click on any of the movies, you can look at the details of that movie, as in when it was released, what is the genre of the movie, who was the director, writer, who are the actors in the movie, and what ratings it has got. So whatever data we have here with respect to ratings and writer and stars, these were basically basically got from IMDb, right? So it was those IMDb ratings that we are using as data set.
In today's session, we're going to discuss about the two most popular DevOps tools, which is Jenkins and Docker. And we are going to see how these tools can be integrated to achieve a better software delivery workflow. So first off, let me run you through today's agenda. First, we're going to see what exactly Jenkins is and how it works. Next, we're going to see how Docker solves the problem of inconsistent environment by containerizing the application. Once we're done with that, we'll briefly have a discussion on microservices, because on the hands-on part, I'm going to deploy a microservice-based application by using Jenkins and Docker. Now, after you've got a brief idea about microservices, we're going to look at a use case and see how to solve a problem statement by using Jenkins and Docker. And finally, we're going to move on to the hands-on part, where we'll deploy a microservice-based application by using Docker and Jenkins. So guys, I hope you find the session interesting and informative. Let's get started with our first topic. Now, before listing down a few features of Jenkins, let me tell you some fun facts about Jenkins. Currently, there are over 24,000 companies which use Jenkins. To name a few, there is Google, Tesla, Facebook, and Netflix. Now, there has to be a reason why such reputed and successful companies make use of Jenkins. Now, let's discuss a few key features and see why Jenkins is so important. All right. Now, the first feature is that it is an open source, freely available tool, which is very easy to use. It has various features like the build pipeline plugin, which lets you graphically visualize the output. And apart from that, there is also a feature known as user input, which lets you interact with Jenkins. All right. Now, one major feature of Jenkins is that it implements continuous integration. Now, what is continuous integration? Every time a developer commits into a source control management, that commit is continuously pulled, built, and tested using Jenkins. Now, how does Jenkins do all of this? Now, Jenkins has over 2,000 plugins which allow it to integrate with other tools like Docker, Git, Selenium, etc. So by integrating with other tools, it makes sure that the software development process is fully automated. All right. So it is also an automation server which makes sure that the software delivery cycle is fully automated. Now let's see how Jenkins works. So here you can see there is a group of developers committing their code into the source code repository. Now, every time a developer makes a commit, it is stored in the source code repository. Now, what Jenkins does is, every time a commit is made into the source code repository, Jenkins will pull that commit, build it, test it, and deploy it by using plugins and other tools. All right. Now, not only is it used for continuous integration, it can also be used for continuous delivery and continuous deployment with the help of plugins. So by integrating with other tools, the application can be deployed to a testing environment where user acceptance tests and load testing is performed to check if the application is production ready. And this process is basically continuous delivery. Now it can also make use of plugins to continuously deploy the applications to a live server. So here we saw how Jenkins can be used for continuous integration, continuous delivery, and continuous deployment by integrating with other tools. All right. Now let's move on to what is Docker. Now before we discuss about Docker, let's compare virtualization and containerization. Now the goal of virtualization and containerization is to solve the problem of the code works on my machine but it does not work on the production. Now this problem happens because somewhere along the line you might be on a different operating system. Now let's say your machine is a Windows machine and you're pushing the code to a Linux server. Now this will usually result in an error because the Windows and Linux support different libraries and packages. And that's why your code works on the development server and not on the production server. All right. Now when it comes to virtualization, every application is run on a virtual machine. Now a virtual machine will basically let you import a guest operating system on top of your host operating system. Now this way you can run different applications on the same machine. All right. Now you're wondering what is the problem with virtualization. Now one major drawback of virtualization is that running multiple virtual machines on the same host operating system will degrade the performance of the system. Now this is because the guest operating system running on top of your host operating system will have its own set of kernel and set of libraries and dependencies which take up a lot of resources like the hard disk, processor, and RAM. And another drawback is that it takes time to boot up, which is very critical when it comes to a real-time application. All right. Now to get rid of these drawbacks, containerization was introduced. Now in containerization, there is no guest operating system. So instead, the application will utilize the host operating system itself. So basically, every container is going to share the host operating system, and each container will have its own application and application specific libraries and packages. All right. So within a container, there's going to be an application and the application specific dependencies. I hope this is clear, guys. Now that we've discussed containerization, let's see how Docker uses containerization. Now Docker is basically a containerization platform which runs applications within different Docker containers. So over here you can see that there is a host operating system on top of which there is a Docker engine. Now this Docker engine will basically run container number 1 and container number 2. Now within these two containers are different applications along with their dependencies. All right. So basically within a container, every application is going to have its own dependencies installed. So it does not have to bother any other container. Okay. So basically there is process level isolation that happens here. All right. Now there are three important terminologies to remember when it comes to Docker. Now the first is the Docker file. Now the Docker file basically contains the code which defines the application dependencies and requirements. All right. And through the Docker file, you're going to produce the Docker image which contains all the dependencies such as the libraries and the packages of the application. Next is the Docker container. Now every time a Docker image is executed, it runs as a Docker container. So basically Docker container is a runtime instance of a Docker image. So now let's look at a Docker use case. Now over here you can see that I've created a Docker file. Now within the Docker file, I basically defined the dependencies of the application. Now out of this Docker file, a Docker image is created. So basically the libraries and the packages that the application needs is installed within the Docker image. Now every time the Docker image is run, it runs as a Docker container. Now these Docker images are pushed into a repository known as Docker Hub. Now this repository is very similar to the Git repository wherein you are committing code into the Git repository. In this case, you're going to commit Docker images into the Docker Hub repository. All right. Now you can either have a private or public repository depending on your requirements. Now after the image is published to Docker Hub, the production team or the testing team can pull the Docker images on their respective servers and then build as many containers as they want. All right. Now this ensures that a consistent environment is used throughout the software development cycle. Now let's look at what are microservices. Now guys, I'm going to explain what microservices is because we need to deploy a microservice based application in our demo. Just to take it up a notch, I've implemented microservices. Now first, let's look at the monolithic architecture. Now over here, let me explain this with a small example. Now on the screen, you can see that there is an online shopping application which has three services: customer service, product service, and cart service. Now these services are defined within the application as a single instance. So when I say single instance, it means that these three servers will share the same resources and databases, which make them dependent on each other. Now, if they share resources, obviously they're dependent on each other, right? Now, you must be wondering what's wrong in this architecture. Now, let's say that the product service stops working because of some problem. Now, because the services are dependent on each other, the customer and the cart service will also stop functioning. So basically, if one service goes down, the entire application is going to go down. All right. Now, when it comes to a microservice application, the structure of the application is defined in such a way that it forms a collection of smaller services or microservices, and each service has its own database and resources. All right. So basically, customer microservice, product microservice, and cart microservice will have their own database and their own resources, and therefore they're not going to be dependent on each other. All right. So they are basically independent, autonomous microservices. All right. Now let's look at a few advantages of microservices. Now the first advantage is independent development. Now when it comes to a monolithic application, developing the application takes time because each feature has to be built one after the other. So in the case of the online shopping example, only after developing the customer service, the product service can be started. So if the customer service takes 2 weeks to build, then you have to wait until customer service is completed, and only then you can start building the product service. All right. But when it comes to a microservice architecture, each service is developed independently. And so you can develop customer service, cart service, and product service parallelly, which will save up a lot of time. All right. Now the next advantage is independent deployment. Now similar to independent development, each service in a microservice application can be deployed irrespective of whether the service before it was deployed. So each service can basically deploy individually. Now fault isolation. Now when it comes to monolithic application, if one of the services stopped working, then the entire application will shut down. But when it comes to a microservice architecture, the services are isolated from each other. So in case any one service shuts down, there will be no effect on any other service. Now the next advantage is mixed technology stack. Now each microservice can be developed on different technology. Now for example, the customer service can be built on Java and the product service can be built on Python and so on. All right. So basically you're allowed to use mixed technology to build your microservices. Now next is granular scaling. Now granular scaling means that every service within an application can be scaled independently. So basically the services are not dependent on each other. They can be developed, deployed at any point of time, irrespective of whether the previous service is being deployed or not. So guys, I hope you're clear with the advantages. Now over here, we're going to compare how microservices can be deployed by using virtual machines and Docker containers. All right. Now when it comes to a virtual machine, now let's say that we have a microservice application which has 5 services. Now in order to deploy these 5 services on a virtual machine, we'll need 5 virtual machines. All right. Now each virtual machine will be for one microservice. Now for example, if I allocate 2 GB RAM for each virtual machine, then 5 of these virtual machines will take up 10 GB RAM. And the microservices may not even require so much of resources. So we'll just end up wasting these resources, and at the same time you're occupying too much disk space, which will degrade the system's performance. Now let's see how Docker containers deploy microservices. So instead of running 5 virtual machines, we can just run 5 Docker containers on one virtual machine. Now by doing this, we're saving up a lot of resources, but when it comes to a Docker container, you don't have to pre-allocate any RAM. The Docker container will just utilize the resources that are needed. And another point to remember here is that Docker containers are lightweighted. They do not require additional guest operating system. Instead, they just share the host operating system. All right, so this makes them very lightweight when compared to a virtual machine. Now let's move on to the use case. Now basically, we're going to try and understand the problem with the help of an analogy. Now over here, you can see that in the favorable environment, the soil is fertile and the tree is watered at a regular basis. And as a result of this, the tree grows properly. But when the tree grows in an unfit environment where the required dependencies for growing a tree are not present, then the tree will die. All right. Now, similarly, when an application runs on an inconsistent environment which does not support the application dependencies, then the application will fail. All right, guys, now let's look at the problem statement with a small example. Now, let's say that a developer is building an application using LampStack. Now, after the application is developed, it is sent for testing. Now, this application runs properly on the testing server, but when it is deployed to production, a feature or the entire application fails. Now, this may happen because the Apache version of the LampStack is outdated on the production server. So due to the difference in the software versions on the production and development server, the application fails. Now, in order to get rid of the inconsistent environment problem, we're going to deploy an application using Docker. Now, Docker will make sure that the environment throughout the development cycle is consistent. Now, deploying a monolithic application can cause many problems. Like, for example, if one of the features of the application stops working, then the entire application will shut down. So for this reason, we're going to create a microservice-based application and build it on the Jenkins server, and finally use Docker to maintain a consistent environment throughout the cycle. So over here, you can see that there are 4 microservices, and for each microservices, I've built a Docker file. All right. So first, let me discuss what each of these microservices do. Now, the account service and the customer service are the main microservices, whereas the discovery and gateway services are supporting microservices. Now, account service will basically hold the account details of a customer, and similarly, the customer service will have a list of customer details. Now, discovery service, which is a supporting service, will hold details of the services that are running on the application. And apart from that, it will also register every service in the application. Now, what the gateway service does is, on receiving a client request, it will route the client request to the destination service. Now, to be more specific, it will provide the IP address of the destination service. Okay. So now that you know how these microservices work, let's move on to the next part. Now, basically, these microservices are coded and their dependencies are put into a Docker file. Now, for each of these Docker files, a Docker image is created by packing the Docker image with the jar files. Now, how do you create a jar file? A jar file is created by running the mvn clean install command, which basically cleans up anything that was created by the previous builds, and it will run the pom.xml file, which will download the needed dependencies. So whatever dependencies are needed are stored in this jar file. All right. Now, once the Docker file is packaged with the jar file, then a Docker image is created for each of these microservices. So here we're going to use Jenkins to automate all of these processes. So Jenkins is basically automatically going to build and then push these Docker images to Docker Hub. Now, after the images are pushed to Docker Hub, the quality assurance or the production team can pull these images and build as many containers out of it. All right. So basically over here, we're going to create Docker files for each of these microservices, and then we're going to package these Docker files along with the jar files and create a Docker image for each of these microservices. All right. Now, after creating the Docker images, we're going to push these images to Docker Hub, after which the quality assurance or a production team will pull these Docker images onto their respective servers and build as many containers as they want. I hope this is clear. So now let's practically implement all of this. Alright guys, so I've logged into Jenkins and I've created 4 different jobs, each for one microservice. Alright. Now let me just show you the configuration of one of these jobs. Now let's go to account service. Let's go to configure. So guys, make sure that you enter your GitHub repository here. So go to source code management, click on Git, and then enter your repository URL over here. Now let me just show you what we're doing here. Now within the build step, I've selected execute shell. Now let me just show you how that's done. So it's simple, just go to add build step and click on execute shell. So when you click on execute shell, a command prompt will open like this and you can type this code on that. Now what I'm doing here is, first I'm changing the directory to account services because I'm running the account service within this job. After that, I'm performing an mvn clean install, which I explained earlier. Now, once we're done with that, we're going to build a Docker image and then we're going to push it to your Docker Hub account. Now, these are the credentials to my Docker Hub account, where Zulekha is the username of my Docker Hub account and edureka-demo is a repository that I've created in my Docker Hub account. Then click on apply and save. Now, apart from account services, I've built jobs for the other services as well. Now, let me just show you customer service also. Let's go to configure. Now within the source code management, like I said earlier, enter your repository URL. After that, go to the build steps. Over here, you can see that I'm changing the directory to customer service. Then I'll perform MVN clean install. So next I'm going to build Docker images. Now over here, customer is basically the tag of the image. So whenever this image is going to get pushed to my Docker Hub, the tag is going to be customer. All right. Now similarly for account service, the tag was account. Now I've done the same thing for all the other jobs. All right. Click on apply and save. Now guys, in order to run these 4 jobs as one workflow, I've created a build pipeline. Now this pipeline will basically execute these 4 jobs in one workflow. Now if you want to know how to create a build pipeline, please refer the video in my description box. I'm going to leave a link where you can see how to create a build pipeline. All right. Now let me just show you my GitHub account. Now over here you can see that I have account service, customer service, discovery service, gateway service, and also there's Zipkin service. Now guys, this service basically keeps a track of all the other services. So it's going to keep a track of where the requests are going and how the requests are getting sent from account service to customer service. Now within account service, you can see that I have a Docker file, Jenkins file, and a pom.xml file. All right, guys, now let's start building our application. Just click on run. Now here you can see that account service is getting executed. Now let's individually go to account service first. Let's click on account service. All right, here you can see that it's building this job. So basically here what we're going to do is we're going to change the directory to account service. After that, we're going to perform an MVN clean install, and then we're going to build an image and push that image to Docker Hub. All right. So guys, remember to provide your Docker Hub credentials. Now this job has successfully executed. Now after this job has executed, it's going to trigger the next job, which is customer service. Now let's look at the build pipeline. Now over here, this has turned green because account service has completed execution. Now customer service is currently running. So let's look at the build in customer service. So after the account service has completed execution, guys, you can also check the output of account service from here. Scroll down, it says success. Now after account service has finished, let's trigger the customer service. So customer service starts executing now. Now let's individually look at customer service. Now over here, you can see that customer service is building. Now in this job, we're basically going to change the directory to customer service. After that, we're going to perform an MVN clean install command, and then we're going to build and push a Docker image to Docker Hub. All right. So once this is completed, the next job in the pipeline will get executed. Okay. All right, guys. So this is successfully executed. Now you can see that customer service has also turned green, which means that it has successfully finished building. All right. All right, guys. So you can see that customer service has completed execution. Now let's trigger the build of discovery service. Now let's look at the output of discovery service. So guys, you can see the output from here itself. Let's click on console. All right. So within the discovery service again, we're going to change the directory to discovery service. After that, we're going to perform an MVN clean install. And once we're done with that, we're going to build an image and then we're going to push it to Docker Hub. Guys, make sure you have entered your Docker Hub credentials. All right, guys, so this is completed execution. You can see that it says success. Now it's triggering the new build, which is gateway service. So here you can see that gateway service has started execution. Let's look at the console output. All right, so similarly in gateway service, first you're going to change the directory to gateway service. After that, you're going to perform an MVN clean install command. And once you're done with that, you're going to build an image and then push it to Docker Hub. So guys, gateway service has successfully completed execution. Now the build pipeline has fully turned green, which means that the entire workflow has completed execution. Now let's go to our Docker Hub account and see if all these images got pushed to Docker Hub. All right. So I'm going to my Docker Hub. Now let's go to the Edureka demo repository. Now over here, you can see that the account, customer, discovery, and gateway services, all of these 4 images are pushed to Docker Hub. All right. So with this, we've come to the end of the demo. Now, after pushing these images to Docker Hub, any quality assurance team or any testing team can pull these images onto their respective servers so they can easily deploy this to production.
Docker and Node.js tutorial. So why use Node.js with Docker? So as it speeds up the application deployment process, deployment becomes easier where there are a lot of things which you don't need to look at while deploying. If it runs locally on your Docker container, surely it will run on any other machine or any other server on any Docker container. Application portability increases. You're developing on Windows, deploying on a Linux. You don't need to care about all that. If it works in one container, it will work in another container. Simplifies the version control process, promotes component reuse, very light footprint, and puts less overhead on the app. Now let's start with a simple Node app. I'll do npm init, create an empty project. So we have a empty package.json file. We'll go ahead and install Express. So we'll try to create a very simple hello world application using Express. So it will be a web application. Express is a very popular web framework created on Node. So if we open the package.json, we can see the name of the application, and mainly in the dependencies we have Express listed over here. Okay, we'll create our app.js file. That will be our app. Let's write our application over here. First, we'll import the Express module. We'll use that object of the Express module to create our app object. We'll use the app object to listen. So this is where we're actually starting our HTTP server, and it has to listen on a particular port. We can use any port number over here. 3000. The port numbers that are commonly used are 3000, 8080, or 888 four times. Basically any number, any port that is open on your system. And then finally, we'll just create one route where the app would be giving a response if that route is hit in the browser. We'll just send hello from Docker. Okay, I think that's all we need. Just a simple demo. We'll try and run this. Okay, app listening on 3000, no errors. We'll open this. Okay, hello from Docker. We have it. Great. So I'll close this now. Now let's Dockerize this application. So as you remember, the three basics of Docker: Docker file, Docker image, Docker container. We need a Docker file over here. Just write Docker file. No need to give any extension. Okay, it's still a text file. We'll open this. Now this is where we will tell Docker what to do. Before moving on with the commands, this is the Docker Hub website, hub.docker.com. I suggest you please create an account on this website. Or I guess when you go to download the Docker, I think it'll tell you to create an account or Docker ID. So once you have an account on hub.docker.com, you go to explore, and this is where you see all the popular images of Docker. So anytime you're working with any language platform, for example, let's say Node.js in our case, or PHP or .NET, or using in databases, let's say like over here, Postgre or Couchbase, all these standard technologies, they have their own official Docker images already on the Docker Hub. You don't need to create images for these from scratch because these are already available to use. So in our case right now we need to use the node on the Docker. So you just search for node. Okay, and as you can see, we have node. It's an official image. Official image means this particular Docker image is created by the people who create node. Okay, like Mongo Express. So this Docker image is created by the people who actually create the Mongo Express library. Okay, and then obviously there are verified publishers, like for example Microsoft, and anybody can upload a Docker image over here in the hub. Okay, and you can also filter them by the categories, the kind of image that you want, the supported OS, supported architectures, etc., etc. So for us, all we need is this node Docker image. So this is the image upon which our image will be built and the container would be working. Okay, so coming down, how to use this image. Okay, so you need to go to this guide. It'll open the GitHub page of Node. Okay, so over here, create a Docker file in your Node.js app project. Specify the node base image with your desired version. This will be the first line of our Docker file. So this is the official Docker image that we want to use, and this is the version of that Docker image, not the version of Node. You can have a look at all the supported Docker image versions of Node. I think 10 is good for us. I think it is the latest one. We don't actually need to go and dig into which version supports what, but this is good for us for now. Okay, moving forward. Now, what do we want to tell Docker to do? First, we'll create a working directory for the Docker. So this is where we are telling Docker to like create a app directory for itself, where whatever work or things the Docker needs to do for our application, Docker can put it inside the app folder. We'll tell Docker to copy our package.json. And if you remember, Docker file is inside our app folder. Okay, so this is inside our app folder. So we don't need to give any paths for any files that we are referencing. So I can directly say copy package.json inside the app. Okay, run npm install. So this is like very easily understandable commands. Copy package.json inside the app folder and then run the npm install. So this command will be run inside this folder of the Docker container. And what npm install would do is whatever packages are listed inside package.json, if you remember, we have Express. So those packages will be installed. Okay. Then we tell Docker to, now dot over here means the current directory the file is in. So this is our current directory. And we're telling Docker to copy everything from the current directory to the app folder and then run the command node. So this is the command which even we use to run the node app. Okay, so this is what Docker would run inside its container. And lastly, if you remember, we had a port number which we were using. For us, it's 3000. So we need to expose a port number as well. Okay. Yeah, so I think this is it. We are done. Now we'll try and run this inside Docker. Okay, so first we need to build the Docker image. We only have a Docker file right now. So next step is to build a Docker image from the Docker file. We need to give a name to the Docker image. I'll name it Hello Docker. Okay, because the mistake that I did is to put a dot in the end, suggesting the current directory we are in. Okay. So as you can see, these are the commands that is running one by one. It's going through all the steps from node 10, work dir, copy package.json, run npm install. And this over here, it might take a while because it needs some time to download the packages listed in package.json. Okay, and then it went through everything, fine. Okay, now we have the image created. Now we need to run the Docker app. So the command for that is docker run. Also, again, we do have the Docker documentation online, which you can refer anytime. Okay, so any language, any platform, technology you learn, always try and refer to the official documentation. If you can like refer from it, study from it, that is the best always. Another thing, even in the terminal, in the console, you can always look at help. It'll list out all the options that you can give to the command. So these are the options for the run command, not the Docker command, the run command. Okay, all the options for the Docker command would be, okay, Docker help. Okay, so these are all the subcommands and options that you can use with Docker. So moving on, we're going to run the image Docker run. Now IT means we want the Docker to run in an interactive shell. So if you look at the options, that's not required, but it's good. Okay, so -i, -i interactive keeps standard input open even if not attached. and T. Allocate a sudo TTY. TTY means a terminal. So Docker run, and we want to tell Docker which port we are exposing and which port we are using inside the application. So again, if you look at help, there is this P option, publish list, publish a container's port to the host. So we'll be creating a Docker container which is running on the host. Host is our Windows operating system. We need to tell which port the Docker is exposing and which port is being used by the app inside. This port 3000 over here and this 3000 over here can be different. Okay, it's not compulsory that they should be the same all the time. We can have 8000 over here and 3000 over here, and all we need to do is map it in the command. But over here it's the same. So Docker run. So IT, what basically would do is, I'll show you when the command runs. So this first 3000 is the port number we listed in the Docker file, the port exposed by Docker, and the second one is what our app is using. Okay, now our image name was hello Docker. Let's run this. Okay, we have some error. It says it's already allocated. Okay, we'll try another port. This may be due to because I was already doing some tests and running this. Now, once I've changed the Docker file, I need to rebuild my image. So we'll run the build command again. Okay. Now I'll run the image. Docker run interactive 888 and 3000 inside the application. Hello Docker. And we have running. Now let's try and run again. Okay, the site can't be reached. Now, if you remember, we have this Docker toolbox thing open, and it has its own machine IP 192.168.99.100. 192.168.99.100, port number 3000. Okay, so I'm sorry, but I had another instance running already on that port. That is why it did not allow me to run that Docker image on that particular port. I changed my Docker file port to 8888, and that is the one that is being exposed. So for us over here, the port number should be 8888, and that is where I see the message hello from Docker, which is what we have used. Hello from Docker. The reason why 3000 is working is because there's already another Docker instance running in the background, which I didn't close, and it says hello world. So there's actually another Docker container already running on that port, and that is why it did not allow me to run the Docker container on this port. So as you can see, I already had one running, which I forgot about. Sorry about that. So our app is running right now on the port 8888, and that is the port exposed by Docker to my operating system, which is Windows. But the port on which the app is running inside the Docker container is 3000. So the app is still running on 3000, but Docker is exposing our app to port 8888, and that is what we have mapped over here. And minus -it means it's interactive. Right now, this message, what you're seeing, is actually from a console inside the Docker container. This is not from our own CMD or command line. Okay, so now I can press Control C to end this. Okay, yeah. So as you can see, it has ended. Okay. So I was able to give it the command to end it, and that command went to the console of Docker container. So I hope you enjoyed it, the small demo. Okay. And yeah, this is what we actually did basically: create the Node.js app, create the Docker file, build the image, and then execute it.
Let's look into the topics for today's session. So we'll start today's session by understanding what is a virtual machine, and then I'll tell you the benefits of virtual machine. After understanding that, I'll tell you what are Docker containers, and then I'll tell you the benefits of Docker containers. After an introduction of virtual machine and Docker containers, I'll tell you the difference between Docker containers and virtual machine, and then the uses of them. So now let's get started with the first topic for today's session, that is, what is virtual machine? A virtual machine is an emulation of a computer system. In simple terms, it makes it possible to run what appears to be on many separate computers on hardware that is actually one computer. The operating systems and their applications share hardware resources from a single host server or from a pool of host servers. Each virtual machine requires its own underlying operating system and then the hardware is virtualized. Not only this, but a hypervisor or a virtual machine monitor is a software, firmware, or a hardware that creates and runs virtual machines. It sits between the hardware and the virtual machine and is necessary to virtualize the server. Since the advent of affordable virtualization technology, IT departments have embraced virtual machines as the way to lower costs and increase efficiencies. Now, with the note of this, let me tell you the benefits of virtual machines. So, the benefits of virtual machines are mainly all the operating system resources are available to all the applications. They have established management and security tools. And not only this, but they're better known for security controls. Now, who are the popular virtual machine providers? Well, the popular virtual machine providers are VMware, KVM, VirtualBox, Xen, and Hyper-V. So now that you have understood what is a virtual machine, let me tell you what Docker containers are. So as we all know that Docker is the company driving the container movement and the only container platform provider to address every application across the hybrid cloud. With containers, instead of virtualizing the underlying computer like a virtual machine, only the operating system is virtualized. Containers sit on the top of a physical server and each container shares the host operating system kernel and usually the binaries and libraries too. Now, sharing the operating system resources such as libraries significantly reduces the need to reproduce the operating system code and means that the server can run multiple workloads with a single operating system installation. Containers are thus exceptionally light and they're only megabytes in size and they just take few seconds to start. In contrast with that, virtual machines take minutes to run and are an order of magnitude larger than the equivalent container. All that a container requires is enough of an operating system supporting programs and libraries and a system resource to run a specific program. What this means is that in practice, you can put 2 to 3 as many as applications on a single server with containers that you can with a virtual machine. In addition to this, with containers, you can create a portable, consistent operating environments for development, testing, and deployment. So now that I've told you about containers, let me tell you the types of containers. So mainly there are two different types of containers, that is the Linux container and the Docker containers. So the Linux container is a Linux operating system level virtualization method for running multiple isolated Linux systems on a single host. Whereas Docker started as a project to build single application Linux containers, introducing several changes to the Linux containers that make containers more portable and flexible to use. At a high level, we can say that Docker is a Linux utility that can efficiently create, ship, and run containers. So now that I've told you the different types of containers, let me tell you the benefits of containers. So containers offer reduced IT management resources, they reduce the size of the snapshots, they're used in quicker spinning of apps, and they also make sure that the security updates are reduced and simplified, and they also make sure that there is less code to transfer, migrate, and upload workloads. Now, who are the popular container providers? Well, the popular container providers are the Linux containers, the Docker, and Windows Server. So now that I've told you individually what a container is, what a virtual machine is, and how do these two work, now let me show you the major differences between Docker containers and virtual machines. Well, the major differences come with operating support, security, portability, and performance. So let's discuss each one of these terms one by one and let's know the differences between both of them. So let's start with the operating system support. The basic architecture of Docker containers and virtual machines differ in their operating system supports. Containers are hosted in a single physical server with a host operating system which is shared among them. But the virtual machines, on the other hand, have a host operating system and an individual guest operating system inside each virtual machine. Irrespective of the host operating system, the guest operating system can be anything, like it can be Linux, Windows, or any other operating system. Now, the Docker containers are suited for situations where you want to run multiple applications over a single operating system kernel. But if you have applications or servers that need to run on different operating system flavors, then virtual machines are required. Sharing the host operating system between the containers make them very light and helps them to boot up in just a few seconds. Hence, the overhead to manage the container system is very low compared to that of virtual machines. Now, let's move on to the second difference, that is security. In Docker, since the host kernel is shared among the containers, the container technology has access to the kernel subsystems, as a result of which a single vulnerable application can hack the entire host server. Providing root access to the applications and running them with a super user privileges is therefore not recommended in Docker containers because of these security issues. On the other hand, virtual machines are unique instances with their own kernel and security features. They can therefore run applications that need more privilege and security. Now, moving on to the third difference, that is portability. Docker containers are self-contained packages that can run the required application. Since they do not have a separate guest operating system, they can be easily ported across different platforms. The containers can be started and stopped in a matter of few seconds compared to that of VMs due to their lightweight architecture. This makes it easy to deploy Docker containers quickly in servers. On the other hand, virtual machines are isolated server instances with their own operating system. They cannot be ported across multiple platforms without incurring compatibility issues. For development purposes, where the applications have to be developed and tested in different platforms, Docker containers are the ideal choice. Now, let's move on to the final difference, that is performance. Docker and virtual machines are intended for different purposes, so it's not fair to measure their performance equally. But the lightweight architecture makes Docker containers less resource intensive than the virtual machines, as a result of which containers can start up very fast compared to that of virtual machines, and also the resource usage varies among the two. In containers, the resource usage such as CPU, memory, input, output varies with the load or traffic in it. Unlike the case of virtual machines, there is no need to allocate resources permanently to containers. Scaling up and duplicating the containers is also an easy task compared to that of virtual machines, as there is no need to install an operating system in them. So now that I've told you the differences between Docker containers and virtual machines, let me show you a real life case study of how Docker containers and virtual machines can complement each other. So all of us know PayPal, right? So PayPal provides online payment solutions through their account balances, bank accounts, credit cards, or promotional financing without sharing the financial information. Today, PayPal is leveraging OpenStack for their private clouds and runs more than 1 lakh virtual machines. Now, one of the biggest desire of PayPal's business was to modernize their data center infrastructures, making it more on demand, improving its security, meeting compliance regulations, and also making everything cost efficient. So, they wanted to refactor their existing Java and C++ legacy applications by Dockerizing them and deploying them as containers. This called for a technology that provides a distributed application deployment architecture and can manage workloads, but must also be deployed in both private and public cloud environments. So, PayPal uses Docker commercial solutions to enable them to not only provide gains for the developers in terms of productivity and agility, but also for the infrastructure teams in the form of cost efficiency and enterprise grade security. The tools being used in production today include Docker commercially supported engines, Docker Trusted Registry, and as well as Docker Compose. The company believes that containers and virtual machines can coexist, and thus they combine these two technologies. Leveraging Docker containers and virtual machines together gave PayPal the ability to run more applications while reducing the number of total virtual machines and also optimizing their infrastructure. This also allowed PayPal to spin up new applications much more quickly and also on as needed basis. Since containers are more lightweight and instantiate in a fraction of a second, while virtual machines take minutes, they can roll out a new application instance quickly, patch up an existing application, or even at the capacity to compensate for peak times within the year. So this helped PayPal to drive innovation and also outpace the competitions. So guys, that's how the company gained the ability to scale quickly and deploy faster with the help of Docker containers and virtual machines. So now let me summarize the complete session in a minute for you. So Docker is a containerization app that isolates applications at a software level. If a virtual machine is a house, then the Docker container is a hotel room. If you do not like the setup, then you can always change the hotel room, as it is much easier than changing a house, isn't it? So, similarly, as a hotel has multiple rooms sharing the same underlying infrastructure, Docker offers the ability to run multiple applications with the same host operating system and sharing underlying resources. Now, it is often observed that some of them believe that Docker is better than a virtual machine. But we need to understand that while having a lot of functionality and being more efficient in running applications, Docker cannot replace virtual machines. Both containers and virtual machines have their own benefits and drawbacks, and the ultimate decision will depend on your specific needs. But let me also tell you that there's some general rules of thumb. That is, virtual machines are a better choice for running applications that require all of the operating system resources and functionalities, where you need to run multiple applications on servers or have a wide variety of operating systems to manage. Whereas the containers are a better choice when your biggest priority is to maximize the number of applications running on a minimal number of servers. But in many situations, the ideal setup is to likely include both. With the current state of virtualization technology, the flexibility of virtual machines and the minimal resource requirements of containers work together to provide environments with the maximum functionality.
These will be the parameters I'll be comparing these two tools against: installation and cluster configuration, GUI, scalability, auto scaling, load balancing, updates and rollbacks, data volumes, and finally, logging and monitoring. Okay. Now, before I get started with the difference, let me just go back a little bit and give you a brief about Kubernetes and Docker Swarm. Okay. Now, first of all, Kubernetes and Docker Swarm are both container orchestration tools. Orchestration is basically needed when you have multiple containers in production and you will have to manage each of these containers. And that's why you need these tools. Okay. Kubernetes was first of all created by Google. Okay. And then they donated the whole project to the Cloud Native Computing Foundation. And yeah, now it's a part of the CNCF open source project. Okay. And since Kubernetes was Google's brainchild, it has a huge developer community and a lot of people who are contributing to Kubernetes. So if you have any errors at any point of time when you're working with Kubernetes, then you can straight away put that error on github.com or Stack Overflow, and you'll definitely have solutions to those errors. So that's the thing about Kubernetes. And we consider Kubernetes to be more preferable for a complex architecture because that's when the whole power of Kubernetes comes out. So Kubernetes is really strong. Okay. If you're going to use a very simple architecture, maybe an application which has very few services and which needs very few containers, then you're not going to really see the power of Kubernetes. When you have like hundreds of thousands of containers in prod, that's when Kubernetes is actually beneficial. And that's where you see the difference between Kubernetes and Docker Swarm, right? So Docker Swarm, on the other hand, is not that good when you have to deal with hundreds of containers. Okay. So functionality wise, they are pretty much head to head with each other. Okay. So with both, you can set up your cluster. But yeah, Docker Swarm is a little easier and it's more preferable when you have less number of containers. Okay. But whatever it is, if you are dealing with prod environment, then Kubernetes is your solution because Kubernetes will ensure your cluster strength in prod a little more, at least when you compare it to Docker Swarm. Okay. And yeah, the Docker Swarm community is unfortunately not as big as the Kubernetes because Google is basically bigger than Docker, and Docker Swarm is again owned by and maintained by Docker Inc. So that is the deal with Kubernetes and Docker Swarm. All right. But never mind the fact that the base containers which are used for these are again Docker containers. So at the end of the day, Docker is definitely going to be a part of Kubernetes and as part of Docker Swarm. It's just what you do after your containers. That's what matters, the container management part. Okay. So anyway, I have given you a good brief about these two tools. Okay. Now let's get down to the functional differences between these two. Let's start with installation and cluster configuration. Now for setting up your cluster with Kubernetes, it's going to be really challenging in the beginning because you will have to set up multiple things. You'll have to first bring up your cluster. Then you have to set up the storage volume for your cluster, and then you have to set up your environment, and then you have to bring up your dashboard, you have to bring up your pod network, and when you bring up your dashboard, you have to do the cluster role binding and all these things. Okay, and then finally you can get your node to join your cluster. Okay, but with Docker Swarm, it's pretty simple and straightforward. You need to run one command to bring up the cluster and one command at the node end for it to join the cluster, and two simple commands and your cluster is running. You can straight away get started with deploying. Okay, so this is where Kubernetes falls short. It's a little more complicated, but it's worth the effort because the cluster strength that you get with Kubernetes is way more stronger than Docker Swarm. Okay, so when it comes to failover mechanisms and to recovery, in such places, Kubernetes is a little faster. And in fact, Kubernetes will give you more security compared to Docker Swarm because your containers are more likely to fail with Swarm than with Kubernetes. So it's not like I'm saying that your containers will definitely fail, but if at all they fail, then there are more chances of your containers failing at Swarm than with Kubernetes. Okay, so that's about the cluster strength. And if you are really important about your prod environment, and if you have a business which is basically running over these containers, then I would say your preference should be Kubernetes, because at the end of the day, business and your containers running in prod are more important. So the cluster is more important, and that's why Kubernetes. Now moving on to the next parameter, we have GUI. Now Kubernetes wins over here also because Kubernetes provides a dashboard over which we can basically control our cluster. Not just control, we can also figure out and get to know what is the status of your cluster and how many pods are running in your cluster, how many deployments are there, how many containers are running, how many services are running, and which are your nodes. You will have all these details in a very simple fashion. Okay, so it's not like you don't get all these things with Docker Swarm. Okay, you get it with Docker Swarm also, but you don't have a GUI over here. There's no dashboard where you can visually see everything. So you can use the CLI with Docker Swarm and you can use the CLI with Kubernetes also. But it's just that Kubernetes provides you a dashboard, which is a little better. And to our eyes, it's a little more easier to understand when you see graphs, when you see your deployments would say your all your deployments are 100% healthy. When you see some things like that, you will relate to it a lot more and you will like it a lot more. So that's this additional functionality which you get with Kubernetes. Okay, so that's where Kubernetes wins over here. And I also want to add another point that with your Kubernetes dashboard, you can easily scale up your containers and you can also control your deployments and make new deployments in a very simple fashion. So even non-technical people can use Kubernetes. Okay, but I mean, if you're a non-technical person, then what are you doing with containers, right? So that's what veterans would say. So seasoned developers would say that, I mean, if you're not technical enough to deal with containers, then you don't deserve to be here. So that is one point which can defend Docker Swarm, but it does not change the fact that Kubernetes makes our life easier. Now moving on to the third one, which is scalability. Both Kubernetes and Docker Swarm are very good for scaling up. Okay, so that is the whole point of these tools. So when we say orchestration, this is the biggest benefit. Okay, Kubernetes can scale up very fast. Swarm can also scale up very fast, but there's a saying that Swarm is 5 times faster than Kubernetes when it comes to scaling up. That is the point. So I think Swarm just nudges Kubernetes over here to victory, right? But yeah, whatever it is, it's scaling up. That's what matters. Since both can do it, well and good. So the next point is auto scaling. Now, if I was a salesman, then I would use this whole point of auto scaling as my sales pitch, because auto scaling is all about intelligence, right? With Kubernetes, your Kubernetes will always be analyzing your server traffic, and whenever there's a sudden increase in your traffic, your Kubernetes will automatically scale up your number of containers. Okay, and then when the traffic reduces, then automatically your number of containers will also be scaled down. Okay, so there's no manual intervention whatsoever. I don't need to barge in. So if there's a weekend coming up and if I'm pretty sure that my website is going to get a lot of traffic over the weekend, over the Saturday and Sunday, then I don't have to manually configure my deployments for the weekend. Kubernetes will automatically do that for me. And with Docker Swarm, that is a major drawback because you cannot do auto scaling. You will have to do it manually. Okay, you can do scaling. It's not that scaling is a big deal, but during emergency situations, it's really important. Okay, Kubernetes will automatically analyze that, okay, you're getting a lot of traffic today, and it will automatically scale it up for you. Okay, but Swarm is a little different. And if there's an emergency and if your containers are running out of the number of services which they can request, then they cannot do anything. I mean, worst case scenario, they will just die out. Okay, so this is where Kubernetes wins during these emergency situations because auto scaling is not possible with Docker Swarm. Now moving on to my next point, which is load balancing. Okay, now with Kubernetes, at times you will have to manually configure these load balancing options. Okay, with Docker Swarm, you don't need to do that because it's automatically done. Now, the reason you should do it with Kubernetes is because In Kubernetes, you will have multiple nodes, and inside each node, you will have multiple pods, right? And inside these pods, you will have many containers. Now, if your service is basically spanning over multiple containers running in different pods, then there's this concept of load balancing, which you have to manually configure, because pods can let all the containers inside them to talk to each other, okay? But when it comes to managing your load between these pods, that's where the challenge comes, especially when these pods are on different nodes, okay? So you will face times when you will have to manually configure these load balancing and you will have small issues, okay? But it's not that it's going to be major. You can still deal with it. But Swarm wins it because you have no concept of pods over here. You have a Swarm cluster in which there are containers. So these containers can be easily discovered by others, okay? So they use IP addresses and they can easily just discover each other and you're all good. So that's the point. And now coming to the sixth point, which is rolling updates and rollbacks. Let's say that these two are very important aspects, and these are some of the best features of these two tools, okay? Now, rolling updates is basically needed for any application. Now, be it a software application which is using Kubernetes or not, whether it's using Docker Swarm or not, any application needs updates, okay? So rolling updates is really important because any application would need to have updates to it, right? Any software application, any web application, it definitely needs updates to its functionality, okay? Now, if your application is basically containerized, then at any point of time, you don't need to bring down your containers and then make the updates. With the help of using these containers, the different containers and these pods can be progressively given the updates, okay? So in Kubernetes, we have the concept of pods, and inside the pods, we have multiple containers, right? So in Kubernetes, what happens is these rolling updates are gradually sent to each of these pods as a whole. So all the containers inside the pods will be gradually given these rolling updates, okay? With Docker Swarm, you have the same thing, but it's a little different because you don't have pods. The rolling updates are gradually sent to all the containers one after the other. That's the only difference. Okay, rolling updates are gradually sent to different containers in Kubernetes and in Docker Swarm, but in Kubernetes, it's to all the containers within the same pod. Okay, rolling updates sent one after the other to the different containers in the same pod. That's the point. And when it comes to rollbacks, again, both provide the same thing. Okay, you can roll back your changes. So if your master at any point of time figures out that your rolling update is going to fail, then you have an option of rollback. You actually have the functionality in both Kubernetes and in Docker Swarm. But the point is, there's no automatic rollback. In case of your Kubernetes cluster, if your master finds out that the update is going to fail, then it will automatically roll back to the previously stable condition. But with Swarm, the Swarm manager will not automatically do it. I mean, it provides optionality to roll back, but it's not automatic. That is the only difference between these two. So I think over here also Kubernetes slightly beats Docker Swarm, okay, just nudges ahead of it. And now coming to the seventh point, which is nothing but data volumes. Now data volumes is a very key concept because you can have a shared volume space for different containers, okay. Now the conceptual difference between these two is that in Kubernetes you have multiple pods and only containers inside that one particular pod can have a shared volume, okay. And the difference with your Docker Swarm is that since there are no pods, pretty much any container can share the shared space with other containers. So that is the only difference, okay? So I don't think I would go ahead and rate these two. It's just a functionality and a conceptual difference between these two tools, okay? Now moving on to the last point, logging and monitoring. So with Kubernetes, you have inbuilt tools which does the logging for you and also the monitoring happens, okay? So there's a particular directory where you can go and you can read your logs and you can find out where your errors are, why your deployment failed, why something happened. You can get all those details because it automatically does the logging. And the monitoring part is used by your master to basically analyze what's your cluster status at all the times, what is the status of all your nodes, what is the status of the different pods in the nodes, are all the containers up and running, are containers responsive. So Kubernetes uses monitoring for all these purposes, okay? But with Docker Swarm, there's no inbuilt tool and you have to use third-party tools, something like an ELK, right? So I've done that before and I've set up ELK to work with my Docker Swarm. And it pretty much does the same thing, okay? So with ELK, you can collect all the logs, you can figure out where the error is, and even monitoring can be done. But it's just that ELK is again not a very easy tool to set up, and it's that extra step which you have to do with respect to Docker Swarm, okay? So I think that's pretty much the end of the functionalities and the conceptual differences between these two tools, Kubernetes and Docker Swarm. Now that is the end of the theory part over here. I want to open up a Docker Swarm and Kubernetes and show you a demonstration and give you a feel as to how they work. Okay, so for that, let me open up my VMs where these two are installed. Let me start the demo with Docker Swarm first. So can everybody see my VM over here? So I have two virtual machines. I have a master and I have a slave. But when it comes to Docker Swarm, they are not called master and slave, but they are rather called manager and worker. So my manager is the manager of the cluster, and my worker will be the one that will be executing the services. All right. So like I said, with your Docker Swarm, it's very easy to bring up the cluster. And the command to do that is very simple. You can just specify Docker Swarm init advertise adder and just specify the IP address of your master. Okay. So in my case, my master or my manager's IP address is this one. Okay. So if I just hit enter, then everything's up and ready. I get the joining token, and if I just execute this command at my node end, then my cluster would be ready and I would be joining my cluster. Okay, so I'm going to copy this. Let me go to my worker, and here let me paste this. If I hit enter, then it says that this node has joined the swarm as a worker. Brilliant, right? So that's as quick as it is. And with your master, you got this message saying to add a manager to the swarm, you should use this other command. Okay, but that's only if you want another node to join as a master or as a manager. But otherwise, this command is good enough. So your cluster has been initialized in just a few seconds, right? So it's as simple as that. If you want to deploy an application, you can go ahead and straight away do that. Let me show you a simple application. Let me run a hello world and show you. I can use the command docker service create, and let me give the name as hello world. Okay, and the image to be used is the hello world image. Okay, so I will basically get a container having the name of hello world, and that would be created, and it could be both. It could be running in both the manager and on my node. But if I want one replica of that running in both my manager and my node, then I can set, then there's another flag I can use to set that. Okay, and that is the mode flag. I can say mode is equal to global. So with this, I will have one container running on my manager end and one container in my node. And this is where the difference is with respect to Kubernetes, because in Kubernetes, only your nodes will run the services. Your manager or your master will not execute any service. Okay, it will only manage the whole deployment. Okay, so there was a spelling mistake in my command. So let me just go here and say service. Okay, so let's just wait for a few seconds until my container is up and running. Great. So as you can see, my service has been created, and this is my ID. If I want to verify my cluster state and to check if my service is ready, I can run these commands. I can do a docker node ps. Okay, and this way I'll know how many containers came up and on which nodes they were executed. So it says on my manager there were 4 of these that started. Okay, and of course it's a hello world container, so it's basically shut down immediately. And I can do a docker node ls to identify how many members are there in my cluster. So with this, you can see that there are IDs for 2 different nodes. One is my worker and the other is my manager, right? And that's how simple it is with Docker. But with Kubernetes, it's a little more different. Okay, so I think by now you got a good idea of how simple Docker Swarm is. Okay, and besides, I can also check the service status by running a few commands, right? So I have a Docker service ls. So this would basically list down the containers which are there and the services. Okay, so it says I have a hello world container which is running and it's in replicated mode, and there is one replica of this particular container, right? So I can also check more. I can do a docker service ps, and I can say the name. I can say hello world, and I have details about my container, right? So initially there was one container which started off in my worker, and then it got shut down, and then one more on my worker, and then a couple of them on my manager. So these are the details, and this is how you drill down, right? So you've specified that I need one particular service, that is the hello world service, and I need this many replicas wherein I want them running on my manager and my worker, and then the container has been deployed and it's running, and that's what you can see here, right? So that is about Docker Swarm. And let me bring the VM down and bring up my Kubernetes VMs to show you a demonstration of Kubernetes. Okay, well, I hope the concept was clear to you, but in case if you have any doubt, then I would request you to go to Edureka's YouTube channel and watch my video on Docker Swarm, where I've shown load balancing between the different nodes, and I've also shown how to ensure high availability. Okay, so in the meanwhile, let me just shut this down. To bring down the cluster, I can basically get my nodes to leave the cluster first and then shut down the cluster itself. So if I want to bring down my cluster, I can do it with a simple command. But before I do that, let me stop the service which I created. Okay, so Docker service rm and hello world was the name. So I'm going to stop the service, and now there are not going to be any replicas of this service or this container. Okay, now let me go back to my node, and here let me leave the cluster, the swarm cluster. Okay, and the simple command for that is docker swarm leave. So if I hit the command at the node end, then this node will leave the swarm. Okay, so if I run the docker node ls command over here, then the entry for my node would be gone. It would have only one entry, that is my manager. Okay, but anyways, if I want to bring the cluster to an end, then I can get even my manager to leave the cluster, and I can execute the same command for that. I can say docker swarm leave and everything's back. So yeah, let me use force. Okay, node has left. So that's it with docker swarm. Okay, let me just close this terminal and go to my next demo. So now let me open up my VMs which have the Kubernetes running. Okay, so this is my Kubernetes master, and this is my Kubernetes node. Okay, now the thing is that I'm not showing you the entire setup over here because it's really complicated. All right, so I don't want to go ahead and execute all the 10-15 commands and show you the entire cluster setup because it's going to take a lot of time to do that. Rather, if you want to know how to do the cluster setup with Kubernetes, then you can go and see the blog which I've written. And also there's another video on how to set up the Kubernetes cluster. All right, so these two would do you of any help, the YouTube video and the blog, and the link to both of them are below in the description. Okay, so let me just straight away get started and tell you what I've already done. If I've wanted to set up the cluster, then there are a lot of things which I should have done. Okay, starting from here. So basically I've started my init command over here. I've specified which pod network I'm using. I'm going to use a Calico pod network, so I've specified that, and I've specified the address where the other nodes have to subscribe. Okay, and then there are various commands which I have to run with respect to setting up the environment. Okay, these, and then I've basically set up the Calico pod over here, and then I've made room for setting up the dashboard, and then I've brought my proxy up. Okay, yeah, and then from the second terminal I've done a few more things. I've brought up my dashboard account, so I have created a service account for my dashboard, and then I've done the cluster role binding by saying that this dashboard, that I'm the admin, and give me the admin privileges. So I've done that here, and then I've basically obtained the key, which is basically the authentication key for accessing the dashboard. So these are the so many other commands which are needed to be executed from the master's end before your node joins. And then after that, I basically went to my node, and then I executed the one command which I was asked to execute. Okay, so this was the join command generated at my master. So I took that and I pasted it here, and then my node successfully has joined the cluster. So this was the entire process, and you can go to my blog and to my videos and go through this whole process. Okay, so I've also brought up the dashboard, right? So let me just straight away go to the dashboard and show you how simple it is, how easy it is to make any deployment, because that is the whole advantage with your dashboard, right? Docker Swarm may be easier, that's what I showed you. With Kubernetes, it's much more better. And this is the Kubernetes dashboard that comes up. It comes up on this port number. All right, and if you want to start your deployment, it's very, very simple. Okay, you can just go to this create button over here, click on create, and then you have option. You can either write your JSON script, or you can upload the JSON file which I've already written, or you can click on this create an app. Over here, it's basically a click functionality, and here you can just put in your app name. So let's say I want to deploy the same Hello World app. So I'll just put the hello, I'll give the name over here, Hello World, and then the base image which I want to use for this is going to be the Hello World image, is going to be present in my Docker Hub registry or the Google registry. So Hello World is the image, and let's say I want 3 pods initially. Okay, and let me just straight away click deploy. Okay, and with that your application is deployed. And similarly, if there's anything else you want to containerize, it's as simple. If it's going to be an Nginx server or a Tomcat or an Apache server which you want to deploy, you can just choose the base image and hit on the deploy button, and yes, it's straight away deployed. And you'll get something like this, which would show what is the overview and what is the status of your cluster. Okay, as you can see, my deployments, my pods and replica sets, everything is healthy, 100%, right? So this is my deployments. So it says that 2 out of 3 pods are running. So let's just give it a few minutes, and then all the 3 pods will be up and running. Okay, you got to give it a few seconds because it's just 19 seconds old. And yeah, these are the 3 pods. The third one is coming up. Okay, because yeah, it says terminated because the Hello World container, it's a self-destruct container, right? It prints Hello World and it exits. That's what happens here. Same thing with replica sets. I've mentioned 2 out of 3 pods, which means that at all times there will be 3 pods running, and my replica sets and replication controller is the one that will control this aspect. Okay, so yeah, that is pretty much it, and that's how easy and simple it is to work with Kubernetes, right? So you can have your own opinion. You can choose whether you want to use Kubernetes, or you can choose if you want to use Docker Swarm. Okay, so my take on this is, if you have a very simple application, then you would rather be better off with Docker Swarm. Okay, and also if you have very few clusters which you are dealing with. But if you're dealing with a real prod environment, then I would say Kubernetes is a better option. And also when the containers are many in number, when you have a lot of containers, then it's easier to work with Kubernetes. You can just specify the configurations. You can say that I need these many containers running at all the times. I need these many nodes which are connected to my cluster, and I will have these many pods running in these nodes. And whatever you say, that will be followed by your Kubernetes. So that is why Kubernetes is better in my opinion. And you can have your own version. So whatever your choice is between the two, I would like to listen to your opinion. You can please put in your opinion in the comment box. And if you have any doubts, you can let me know. All right. So before I end this video, I would like to talk about the market share between Kubernetes and Docker Swarm. When it comes to new articles or blogs written on these 2 tools, then Kubernetes beats Docker Swarm 9:1. For every 9 blogs written on Kubernetes, there's 1 written on Docker Swarm. So that is the difference here, 90% is to 10%. Same thing with web searches, right? So Kubernetes has, way more searches, 90% more searches as compared to Docker Swarm's 10% search. And same thing you can say for publications, GitHub stars, and for your GitHub commits. Okay, so Kubernetes pretty much wins on every term here, and it's way more popular, and it's way more used, and it's probably more comfortable. And if you have any problem at any point of time, you have a huge community which will help you out with all the replies, right, of whatever your error is. So if you want simplicity, I would say go for Docker Swarm. But if you want cluster strength, and if you want to ensure high availability in your prod especially, then Kubernetes is your tool to go for. But however, both are equally good, and they are pretty much neck to neck on all grounds. And this was a statistic which I picked up from Platform 9, which is a very famous tech company, right? So they write about tech. So I think on that note, I would like to conclude today's session, and I'd like to thank you for watching the video till the very end. Do let us know on what topics you want us to make more videos, and it would be a pleasure for us to do the same. And with that, I'd like to take my leave. Thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!